Good morning, good evening, good afternoon, and happy time of your day.
Hello, everybody. Welcome to HashiTalks 2026.
Very excited to have everyone here. This has been a long time in the making. And I know if you've looked at the schedule, you've seen a lot of really awesome sessions coming up. Sam, what are you most excited about?
It's hard to pick, really. There's so many really good speakers today and really good sessions. So I'm obviously, big fan of Terraform, so I enjoy all the Terraform content. But I also have a little secret penchant for Vault as well. So I enjoy a little touch of that too.
I love it. I love it. I'm very excited. I mean, 48 sessions. This is probably the only live stream that I follow for more than an hour because it's worth it, right? We may sound subjective about this because we have a hand in this, but really it is very much worth it. Now, if you've just stumbled across LinkedIn or YouTube and came across this stream and you're wondering where you are at HashiTalks 2026, our 24-hour live stream. Keep in mind, this is a professional event, so be considerate in the chat, be friendly, be respectful, but definitely ask your questions. If you want the long version of these rules, check out hashicorp.com/community-guidelines and read the whole thing, or just be a nice person and help the people next to you.
Yeah, that's the basic summary of the rules. Be nice.
That is definitely it. So many sessions today. While we're in the chat and while you're all there, let us know where you're from, where you're tuning in from. The thing I love seeing most is that we're basically reaching the whole world at any time of the day, no matter what time it is there. So that is always great. But with that, I think we've wasted 4 minutes of your time. We've told you the rules. So Sam, who's our first speaker?
So our first speaker today is Marco. He is one of our HashiCorp ambassadors, and his session is titled 3, 2, 1 action. So without any further ado, over to Marco.
Thank you very much for this lovely introduction. Lovely to be here again. And it's probably the best way to start this stream is with the title 3, 2, 1, Terraform action. So to kind of kick us off today, I think, we've probably all been in a situation where, you were using Terraform and, it was doing really well in terms of like managing infrastructure as code or any kind of other API providers. But, you've all been in a situation where you had to kind of go and execute a script somewhere, right? Like just to kind of, fill in for the shortcomings on provisioning things. And, up until recently, you probably ended up with something like that. So, for example, spinning up Azure RM resource group, you wanted to do something extra to it. You probably needed to use a local provisioner and call local exec, which, in all honesty, it always felt a little bit of a dirty hack. And I'm sure we all felt a little bit like, oh, this is probably not what we should be doing. And, you kind of felt a little bit less good about yourself kind of using this thing, right? So, with keeping that in mind, I would like to kind of talk about Terraform actions, kind of a recent improvement of the latest Terraform 1.14 and how that can actually solve that problem going forward. But before we kind of jump into that, let me quickly just introduce myself real briefly. So I work as a principal consultant at a Scale Factory. My background is mostly from ops. So I've been working my way up from, system engineering, like, even pre-cloud when we were still doing things on-prem, if anyone still remembers that. And then all the way up to, system architecture and then consultancy at the end. I kind of wore different hats throughout my career. And I could definitely say I've seen many different things through that as well. Well, that's probably a discussion for another opportunity. I'm also an open source contributor and a maintainer of all the projects. So, for example, AWS Vault, Argo CD Helm chart, and Terraform module for provisioning Terraform Cloud workspaces. And I'm also an active supporter of other projects as well. As it was already mentioned, I'm also a HashiCorp ambassador, OpenUK ambassador, and I'm active in the AWS community as a community builder. And when I'm not doing all of those things, I'm a big fan of hiking and traveling as well. So that's kind of me. Feel free to connect through socials as well if you want to. But without further ado, let's just kick things off properly. So if we look at the typical Terraform workflow of the holy trinity, so to speak, where we have init, plan, and apply, that kind of covers the traditional CRUD model where you can create, you can read, update, or delete objects. But the real question kind of here is where this kind of falls short, or what do we need beyond there? And if we look at the shortcomings of that model, or the shortcomings of what Terraform was doing up to this day, is the reality is just that the day two activities are definitely much more than just CRUD. And when I talk about day two, I mean the life cycle of build, deploy, and manage, and I'm specifically targeting the manage bit here, where Terraform was really, really good tool for building and deploying, but probably the coverage of manage was kind of lacking a bit. We kind of always deploy, hopefully you deploy Terraform as part of the pipeline, and pipelines were always kind of the glue where everything kind of came together, and it was quite tightly coupled with kind of infra dependencies and running those scripts that I mentioned earlier. And following that, as we all know, scripts, and there's usually a lot of scripting and tribal knowledge involved in terms of how everything is glued together, and how you actually manage the whole build, deploy, manage lifecycle. And by not covering that last bit, the day two, obviously you would have a limited observability, and there are like huge governance gaps as well, in terms of it's quite fragile and can break without really good visibility if something were to go wrong. And it just kind of poses a natural question, like, what if Terraform could do more than just create, delete, update, and so on, right? Could it also react? And this is where Terraform actions actually come into play. So they were first introduced with, I think, at the last HashiConf with Terraform 1.14, and it's actually a first-class concept or a building block where you can actually codify and cover, in configuration, you can cover your day two operations. The way how they kind of work in general is they kind of trigger, they can trigger external, systems or executions as part of your configuration. And there are lifecycle aware hooks, and they have, from day one automation covered. So like I mentioned before, as you can see down here, we have a typical representation of, how you would normally execute scripts pre-actions. And that was always kind of a backstop where, Terraform configuration kind of fell short of, oh, we want to do something more after the resources spun up. And, as you can see down at the bottom, it always came with a warning that, you should consider other things first rather than kind of putting that in. And, it has other trade-offs as well. So, for example, if you're running it as part of the pipeline, this is usually executed as part of the runner in the pipeline, whether permissions there and so on. So it kind of really muddles the water, so to speak. So let's move on. So let's quickly have a look at, how the action block would look like in the configuration. And as you can see on this slide, it's not much more different than your typical Terraform resource. So obviously it starts with an action directive. This is how we define it's an action. Then it follows with the action type. So this is usually prefixed by the provider, and then just the name of the action. And then it just follows the logical label, which we refer the action to later on in configuration. It can include your usual suspects or meta arguments as well. So you can provide different providers. You can do count, you can do for each. Obviously, those are kind of mutually exclusive. And it comes with a so-called config block, which is an action specific. So depending on the action and its implementation, the config block would have a specific inputs for the action that you're executing. I will go through that a little bit later on through the demos, but just to keep that block in mind as we kind of trot along. So if we look at how actions actually work, as I mentioned earlier, they're part of the standard Terraform configuration, or HCL. There are two ways how can actually trigger actions. So the first one is a manual invocation through the CLI. And the second one would be event-driven. So you can actually bound actions to a resource lifecycle and kind of trigger those based on different events, like before or after create, update, or delete. As you're running actions, the status at the end of the plan and apply phase is actually updated. So it will give you an updated status of how many actions were actually run, or how many actions are you planning to run. And also, it runs in sync with actions to complete. So what I mean by that is, so the long-running ones might take Terraform runs to longer because the Terraform actually waits until the action completes. The initial AWS provider support came with actions for invoking Lambdas, CloudFront, cache invalidation, cold boot starts, transcribes, and so on. I would suggest looking at the current supported actions in the latest provider of choice change notes. So, as I mentioned earlier, you can invoke actions either by using a CLI or events. If you're using a CLI, it's as simple as just providing a new parameter -invoke. So it's a new flag where you can target an action. You can chain them together, so you can vote more actions if you want to. But preferably, you want to kind of trigger those actions as part of the event-driven lifecycle block. Terraform introduced a new block attribute called action trigger. So as you can see here on the slide, as part of the lifecycle block, you have an action trigger now, where you can go and link it to a specific event. Like I mentioned earlier, those can be before, after update, creates, or deletes. And then you just specify actions to be triggered. It can be one or more actions that you can trigger on a specific event. Before we jump into a demo, just quickly, briefly, a general kind of rule of thumb when and when don't use actions. So please be aware that even though they might be really handy, general rule of thumb would be use actions when you need to react something, and use policies when you kind of need to enforce rules. And then if you need to orchestrate something, that usually lands in your CI/CD logic. When to keep actions is something to keep in mind is in terms of actions, keep them idempotent. So they might be run multiple times from CLI as well. So make sure that if they're run multiple times, they're not breaking anything down the line. Make sure that you keep them small and explicit. So, watch out for business logic sprawl, which can happen if you kind of start overusing it and kind of abusing it in a way. And make sure that they're observable and that you're using conditions as well. So, for example, if they're executing an external system, make sure that you have observability of when this is executing, and this was intentional or not. And you can control that with the condition within the action block as well. Like I mentioned, avoid business logic sprawl. Make sure that you're not tightly coupling it with implementation specific or execution things. And try to avoid referring to unknown values before apply, because that would fail the action if the value is not known. And also something to keep in mind as well is they are completely stateless. So there would be nothing in the state regarding the action. The state wouldn't track that. Therefore, they can be executed at any time. And you just rely on the current values that come with it. Right. Okay. So let's jump into the demo. So to speak, show me the action. Pun intended here. So let's quickly switch over to. I want to switch over to my terminal very quickly. So really quickly, what do we have here is just a bunch of I have 3 examples here basically. So there's a first example of demonstrating triggering a Lambda function via the action. So what we have here is it's just a basic a Lambda function. We're going to go into detail. What it does is it takes a message and it just outputs the message that it receives. So nothing really fancy. But I want to kind of demonstrate to you that you can define an action like mentioned earlier. We're just going to use AWS Lambda invoke action. We're going to call it a message. To demonstrate, you can run more than one at once. I'm just going to count 2 for this example. And then in the config block, as you can see here, what we're doing is we are specifying, and this is, again, specific to an action implementation, right? So which action you're using. We're going to specify function name because it's a Lambda invoke. So we're going to target a specific function called send a message. Very innovative, right? We're going to change the logging type to tail. What this does is while it's executing an action, it will just stream back the output from action so we can actually see it's being executed and what the output is. And then for the Lambda function, we need to send some payload across. We're just going to JSON encode this because Lambda usually takes this in as a JSON code. So we're just going to send a message in with a value. This is the action payload. Going out of the editor, I'm just going to quickly go and say invoke. As I mentioned earlier, what we can do is we can say Terraform apply, then invoke and specify an action. So we start with an action dot and then the logical label of the action. The action type and then the logical label of the action, which is a message. I'm going to execute that now. Keep in mind you can do Terraform apply or a plan with actions. So if you do a plan, it's just going to stop where we were at this point. But because it's a demo, I just want to go quickly through it. I'm just going to say apply. And it just shows me that there are 2 actions going to be invoked, or so to speak, 1 action 2 times. As you can see in the square brackets, it's going to execute the same thing. And I'm just going to say yes here, go ahead. And as you can see, it went really quickly. It just went and triggered the action. As you can see here, it triggered a Lambda function. And this is actually the output of the Lambda function. So we get a raw output from CloudWatch here. So it says send a message received, and this is the action payload as we've seen before. And again, it triggered it twice because I provided count 2. If I would go down to 1, it would just be once. As I mentioned earlier in the presentation, the status updated as well. So it kind of outputs the usual added, change, destroyed, but it also added actions here. So there are 2 invocations of that specific action. So really quickly, if I go back and say count 1, for example, run it again, you're going to notice that even in the plan stage, just show me 1 action. And when I say yes, it just invokes it once, not twice. So that's kind of the first example showing how to invoke action through the CLI. If we move along, the second example would be actually CloudFront, a cache invalidation. So what I have here is just a typical CloudFront distribution linked to an S3 bucket, which has an index.html as a website. So not that much to see, but what I want to show you very quickly is we're using AWS S3 object to upload the index.html to S3 bucket and then serve that through CloudFront via website. What we have done here is we have hooked up an action to a lifecycle here. And we said in action trigger block, we actually said every time you update an object, so the event is after update, evoke an action. And the action here is actually CloudFront, create invalidation. We called it update in this case. So if we look at here, again, action, we're not providing any any meta arguments, but we're just configuring the CloudFront. Again, it's provider-specific implementation. So the config consists of distribution ID. So we need to provide CloudFront distribution ID in this case. So which one we're going to invalidate. And then it kind of accepts the argument of paths, where we say which paths do we want to invalidate. So for this demo, I'm just going to invalidate the whole, the /*, so all the paths. So it's just going to refresh the whole thing. In all honesty, I only have index.html in, so it's not going to be much more than that. So if I quit here, I'm just going to quickly flip over to show you how the page looks like now. So as you can see, it's a very simple website, which says it works. Hi, HashiTalks 2026. So if I go back to my terminal, what I'm going to do is I'm just going to quickly go to the index.html and say, hi, I'm just going to add from HashiTalks 2026 and add 3 exclamation marks because I'm so excited. So if I say this file, plan again, I'm just going to plan Terraform. I'm not going to execute anything manually, but I'm going to just use auto approve to kind of shorten the wait time here. So just going to go through, detect that my index was changed, and it would upload the new index file, as you can see in the output of plan. And this actually triggers the action because it was updated. So as you can see here, the object was modified, it was updated, which triggered an action, which is currently doing cache invalidation. And as I mentioned before, the Terraform will wait until this completes on the provider. But if I just flip back to my website here, you're going to notice if I refresh page, it already invalidated the cache, even though the action hasn't returned yet. But in the meanwhile, it probably will. So as you can see here, it says, hi, from HashiTalks 2026 now. So obviously that succeeded. As you can imagine, that is a really useful use case where you want to do certain things beyond the usual CRUD model when you, for example, update something in your S3 bucket that needs to invalidate cache. And the third case that I've mentioned is I have an example here of spinning up 2 EC2 instances. What I want to demonstrate here is I'm defining my instances is just basic EC2 instances. I'm calling them web and DB. But what I'm doing here is I'm defining them as part of the local variables. I'm calling them web and DB. I'm specifying different AMI. Oh, sorry, it's the same AMI, but different sizes for those because the database probably needs more resources. And obviously, I'm not doing much. It's just T3 small and micro. But what I want to demonstrate here, as I mentioned earlier, you can actually use for each in actions as well. So not just spinning up resources, you can actually do for each and link actions to corresponding instances. And what we're going to do here is we're actually going to do spin up instances. And because they're test instances, I don't want to spend money just keeping them around until I need them. So we're going to use an action AWS EC2 stop instance and just stop them immediately after they're kind of provisioned. So they're ready to go. So I'm just going to quickly, flip that to true because I've disabled that just to demonstrate that. So if I flip that to true, it's just the enable command to kind of enable that piece of configuration. And if I apply that now, as expected, you're going to see the Terraform runs, it detects it needs to spin up 2 EC2 instances in a bit, as you can see in the plan stage here, and it immediately starts spinning those up. It should just take a couple of seconds. As you can see in the plan, it kind of said, oh, there's going to be 2 actions to invoke as well, because we have those actions linked to these instances. And you can already see that instances were successfully provisioned and immediately triggered an action to terminate, or sorry, not terminate, stop those instances. So they will be, spun up and immediately stopped and just left there for me to use. If I run the Terraform again, it will not do anything again, just because the action is linked to, if we go look at the configuration of all these provisions, you're going to see here, action is actually linked to a lifecycle event, which is after create. So if I run it again, Terraform apply or plan, it's just not going to do anything because instances were already created and there is nothing much more to do for it. So this completed, the instances are up, and again, if up and off. But if I run the Terraform again, as expected, it's just going to say no changes, and it's just going to stop there. There we go. Cool. Right. Let me quickly switch back to my slides. Sorry, I just need to find my slides. Here we go. So to just wrap things up really quickly, today we talked about actions, how they extend the usual or traditional Terraform CRUD traditional operations, so kind of expanding beyond and into the day 2. It has the potential to reduce some of your day 2 complexity, to remove some of those kind of nasty scripting and move them as a first-class citizen into Terraform configuration. It comes with the declarative operations, and you can execute those as either standalone or link them to an event-driven resource lifecycle actions. Something to watch out for: initial action catalog might be limited. I mentioned some of the initial actions that were delivered as part of the AWS provider. But please check your providers for all the actions that are supported. They need implementation, even though Terraform is supporting those out of the box. Also keep in mind at this point, or at, you can't yet depend on action outcomes or results. So if there is a result coming from action, like a Lambda that I showed earlier, you cannot rely or get this output in actions yet. Hopefully that's on the roadmap for the future releases. And for just a warning for people using Terraform Cloud, you need a standard tier HTTP subscription in order to either run it through the CLI or to execute them, or kind of see those actions being run as part of the event-driven lifecycle in your Terraform runs in Terraform Cloud. Thank you for your time. Appreciate joining in. It was really lovely preparing that and spending some time with you. Feel free to connect via the socials or elsewhere. I'll be lingering in the stream afterwards. And with that, I'm going to hand it off back to the studio.
Great talk indeed.
Yeah, really good talk. Thanks for that, Marco. I'm a big fan of the kind of automation processes, and that's my background is all in automation. So very much happy to see those actions demonstrated. 3 really good demos. I think, Karim, you're a particular fan of the cache invalidation.
Yeah.
I know that I've got a website that I manually refresh the cache every time I do it, and or invalidate the cache, and that will be a definite add-on, I think.
Yeah, I've definitely used GitHub Actions to just kick off the AWS action and then go through the hassle of getting credentials out of Vault, and then having GitHub validate to AWS with that, and then invalidate the file. Where it's like, this was so much of a headache, and now it's just in one smooth process, and your Terraform run isn't complete, as far as I'm concerned, until that file is invalidated. So this is great to have.
Yeah, definitely.
But that's one of the more advanced features. Amit in the chat on LinkedIn asked, I want to learn Terraform from scratch. Where do I start? Right? And John, thank you for calling this out. But if you're just following the stream, not reading the chat, if you want to learn about any of our tools, head on over to developer.hashicorp.com/terraform/vault/nomad, whichever one you need, and learn from there. We've got hundreds of tutorials that we keep up to date with everything in there, from different cloud providers to different use cases. There's so much good stuff there. Same goes for prepping for our certifications. Lots and lots of learning material on the developer portal. But with that, who's our next speaker?
Next speaker
would be Eric, I think.
Eric, yes. Did you want to do the announcement that is in the?
I think I was actually looking for you to give a little bit of an insight into that one. But I figure, sometimes it's tricky. This is Sam's first HashiTalk, so if you haven't seen him before, say hello, Sam. Sam is doing very well. HashiTalks can be stressful, but we have an amazing team working behind the scenes.
Yeah. Well, it's just nice that you're not trying to make me laugh on air, because you would never do that, right?
I would never try to do that. I think that would definitely go into overtime, and we don't want to do that, because realistically, we want to be solving identity fragmentation issues, right? And I think the best way to do that is to just listen to our next speaker. So over to you, Eric.
Nice segue.
Hello, and thank you so much for joining me today. I'm going to tell you about a journey of using Nomad to get from 0 to production. And we're going to do this at extremely high speed. Let me give you a little bit about myself first and why I'm somebody who does this kind of work. So I play with what I call infrastructure Legos. In fact, this is how I think of most software that's out there. There's the drawing that's on the side of the box, and you could build that, and that'll be fun. But you could also take the set apart and build other things with it. And that's what I'm doing today here. So some projects you might have seen my work on. I work on a Linux distribution called Void Linux. We're a rolling release distribution. I've also done work on an authentication suite called NetAuth, and a ready-to-use turnkey distribution for booting Nomad directly on the metal called the Resin Stack. When I'm not busy annoying people with my strange uses of their software products, I am a site reliability engineer at a company called Backblaze. We keep far too many hard drives spinning, and if you find yourself on Reddit, we are the people who post the hard drive metrics quarterly. So we're talking about going from 0 to prod. Now, before we can get to prod, we need to define where 0 is. If we don't start all on the same page of where we're going to be building from, it's hard to get to the end. So 0 is going to be defined as our machines are physically racked. We've already got them out of the boxes. If you've never ordered real bare metal servers, you might be surprised how much packaging they come with. So we've already got them out of the box, they're already in the rack, and we're going to say our layer 2 network is up. Now, the layer 2 network here could be as simple as just having a bunch of switches plugged in. We don't need the fancy traffic control plane yet. We don't need the additional routing capability yet. We just need the network up. And finally, we are going to need some way to turn these servers on. Now, this could be an IPMI network. Maybe you're going to use Redfish. Maybe you have some kind of low-level automation. You could also send the intern down to the data center and tell them to push the buttons in the right order. And that's a lot faster and a lot easier to do. Now, we've set our starting conditions. Let's set our ending conditions, because if we don't define the ending conditions, we won't actually finish. I'm sure you've all experienced the project where you hit the last ticket in the milestone and, oh, one more thing. Can we get that in the sprint? So for our purposes, being in production is going to mean 3 things. We're going to be running production applications. This sounds obvious, but I want to define it anyway. We're running an application that is either part of our core software stack or something that we want to be using the cluster for, not just having the cluster for the sake of having the cluster. Second, the cluster is stable. Now, sounds obvious, but when you're bootstrapping a system, that's when things go wrong in spectacular fashion. So the cluster needs to be up, it needs to be stable, and we need to be able to take parts of it down and back up and know that it will work. And finally, we are not going to allow any remaining bootstrap toggles to be set. And a bootstrap toggle is going to be something where you have a non-nominal condition enabled within your fleet. This might be you have default passwords. This might be you haven't enabled TLS yet. But it's something that you would not be willing to long-term go to production with. So we're not going to have any of that still set. Now, I can already feel the smugness. You do everything in the cloud. Why do you need to bootstrap bare metal? Well, there's a couple of reasons for this. First of all, don't forget about your disaster recovery scenarios, because those look shockingly similar to day 0 bootstrapping. If things go sideways enough, in fact, you'll find yourself doing day 0 bootstrapping during your disaster recovery. Similarly, if you want to do cost optimization and you're going to apply a scale through 0 approach, where you're actually going to turn off all of your infrastructure when it's not in use, the bootstrap is kind of how you bring that back up. And of course, as we talk here at HashiConf about the hybrid cloud and the shared estate, where some things are in the public cloud, some things are in the private cloud, don't forget that you may have metal on-prem. Now, if you do already run bare metal, you may wonder why you should change. Why am I telling you something new? And the really big points here are just that, you know this as well as I do. Bootstrapping is annoying, it's time-consuming, and it's easy to break. If you put on your security hat for a moment, bootstrapping is also the perfect time to persistently compromise your fleet. If I can sneak something onto the machine before you baseline it, it may take you a very long time to notice what I've done. This is a good enough reason on its own, but when we talk about processes that are error-prone, it's really good to put the time and effort into standardizing them and making them something you can repeat long-term, because eventually your unchecked growth will lead to a system you can no longer maintain. And if you don't plan the downtime to maintain your system, it will plan it for you. So in order to shield some of the complexity and in order to have everything going, we're going to imply software. We're going to use Nomad as a bootstrap orchestrator. Now, what do I mean by a bootstrap orchestrator? Because we often talk about, shifting things left, shift things left, make it the developer's problem. Well, we're going to shift beyond the left. This is the infrastructure that powers our infrastructure. So we're going to think about this not like the servers that are running our applications, but like tools in a toolbox. If you've never visited a data center before, they're very restrictive about what you can bring in and what you can bring out. So it's often the case that you'll have a special toolbox that you could just dump out for security to see. Bootstrap infrastructure works the same way. It needs to be thin, simple, fast, something that you can look at and not have to think too deeply about. And that kind of brings us to the crux of this talk. What is the bare minimum we need to bring up the fleet? Well, we need it to be streamlined. We need it to be ruggedized. These are the qualities that we need to seek in this technology. We need it to be something that is understood, because you can't say, we'll just do what we did last time. And you can't say, oh, no, that's Joe's problem, because Joe may not be in the company 10 years from now. You have to write it down. You have to have a plan, and you have to test the plan. One of the things, though, that we are going to look for in bootstrapping specifically that you might not do in your day-to-day operations is what is the maximum parallelism we can achieve while executing tasks. In the day-to-day, we may not want to do 100 things all at once because of the risk of if something goes wrong. But during Bootstrap, when there's no customer traffic at risk, there's no data in the system, we can go fast. We can power everything on at once, at least up to the point that the power company calls you and asks you to please not. Now, obviously, you're here in this room, so you already know that Nomad is the answer to this problem. But let's go through why anyway. Bootstrapping is a time where you don't have your normal footprint. So it's low dependency. We have pretty much what you can bring in on a laptop. We need it to also be a light hardware footprint, because we're bootstrapping the real hardware. We haven't got that available yet. And it needs to be technologically bulletproof. This is something that we may need to hand off. And so it needs to be something relatively well understood, something that is easy for people to work with. Nomad really fits the low dependency bill nicely. It is completely self-contained. There is a single statically linked Go binary that you can drop in place and run. It has no external dependencies aside from basic operating system primitives. Now, I'm going to caveat that and say, if your Bootstrap is going to involve you running Docker containers or containers of any vendor, obviously the container runtime is now a dependency and you will need to install that. This is magic, but not that magic. Nomad also comes with a few tools that are nice when we're in the Bootstrap phase. We've got a rudimentary encrypted variable store. This is not nearly as sophisticated as Vault, and in fact, if you are going to use long-term configuration that you need secrets, you definitely should consider installing Vault. Similarly, Nomad has a built-in service catalog, but it is not nearly as sophisticated as Consul's. And if you're going to do service mesh or any kind of data plane routing, you should really consider installing Consul once the cluster is up. Now, we need a light footprint. And we really need this light footprint because of the last point on this slide, that bootstrapping is usually iterative. And if your iteration cycles are too long, it gets really annoying to iterate. And in fact, it gets so annoying that there is a point where you say, why bother? Nomad is very light for this use case. In my benchmarking and in my test clusters, I'm consuming 135 megabytes of resident memory once the system is up and stable with the Bootstrap controller set. Additionally, the CPU for these Bootstrap jobs is fairly minimal. I'm going to say fairly minimal because it's extremely bursty. If you're turning on one machine, that's a much lower load on the Bootstrap controller than if you're turning on 1,000 machines. But remember, you can always play with the variable of time in order to even out your resource utilization. Nomad is passively stable as well, and this is really important when we talk about doing these kinds of bootstraps. If you've ever had to overnight in a data center before because things are going sideways, you will know what I mean when I say you want to put it in place, walk away, and have it still be there when you come back. This is not the time to be figuring out why you have a dozen crash loop back-off errors firing. This is not the time to be figuring out why your orchestrator isn't orchestrating. It's tooling that is supposed to work for you, not the other way round. That sometimes I think we often forget as practitioners that the tools are supposed to help us, The last point on this slide is something I really want to call your attention to. If you don't work in bare metal, you may be unfamiliar with the turn-up process, especially if you're looking at turning up a resource in another country, perhaps a country where you are not authorized to work. Sometimes you will write the plan, you will come up with the workflows, but you are not the IC who will execute. You're going to put all this hardware in a crate, FedEx it to the other side of the world, and pray. So you need these processes to be well documented. You need them to be ready to operationalize. Now, I have thrown a lot of high-level ideas and concepts at you. So let's go through a practical example. Let's make this real, something that's a little easier to work with. So this job listing, this very small job listing, is everything you need to bootstrap a data center of bare metal from cold. This even includes some initial monitoring that allows you to keep an eye on things until perhaps your more complete APM suite is up and running. This can physically boot both machines and VMs, though if you are running VMs, you may prefer to work with a golden image workflow out of a tool like Packer. And these jobs and this listing are where the 135 megabyte number comes from. So you can run this on very small hardware. We've got a low resource footprint. Let's go through what each of these jobs do so that you have a better idea of why they're there and how they've earned their place in the bootstrap. First, we're going to talk about the things that have to happen for the bootstrap itself to even be usable. And you may be surprised to see TLS certificates at the very top of this list. But again, bootstrapping is the ideal time to compromise your environment. So we really should be doing things right from day zero. And that means we need to have certificates and our traffic flows need to be encrypted. We need to have a proxy layer that's going to terminate these encrypted connections, and Traffic works really well for that. It is natively aware of Nomad's service catalog, so we can just plug in. We're then going to have a container registry. This may seem like an odd thing to have in your bootstrap set, but you may be bootstrapping in an environment that does not have your full high-speed connectivity available. I recently assisted with a data center turnup where normally we operate on multiple 400 gigabit per second connections. But during turnup, we had AT&T Uverse in the building. And so on this tiny 1 gig per second pipe, we needed to bring the whole site up. Having containers and mirrored packages for your operating system cached locally is a massive quality of life improvement so that you can just start things and then go to dinner, rather than starting things and having to wait and watch and make sure they ran. The last item on there is TerraState. This is a daemon that is a very, very small Terraform state store using the HTTP backend. The only reason we're using a localized state store rather than relying on HCP Terraform is because of the same reason we have the container registry. We may not have the stable network yet, especially if your architecture calls for large-scale SDN or large-scale dynamic firewalls. We really need to bring everything with us. Now, once we've got this base infrastructure running and we're in a place where we can bring up the rest of our fleet, we're going to need to use some conventional tooling. This is nothing new. If you've been in technology since, well, the 90s, you've probably at some point encountered DHCP and TFTP, the Trivial File Transfer Protocol. DNSMask is a popular low-resource system, and this is capable of sending out what's called a DHCP addendum. And this allows you to not have to send quite the same level of network management into Nomad. We can still have our external system, be it a Palo Alto or an Arista or a Juniper box, that is managing DHCP on our bring-up subnets. This is only going to fill in the pieces that are needed to install the machine. We then have a tool called Shoelaces that's going to automate this so that you can just go running through the aisles pushing power buttons, and it will make sure the machines get the correct images. And finally, we're going to have an on-site mirror. Now, this is how I've bootstrapped my fleet. But there are other ways to do this, and I would encourage you very strongly to look at what your hardware supports. A lot of more modern hardware actually has some of these tools burned into the ROMs, and so you can skip steps here and have it come up even faster. Once the machines are up, though, now we need to add them to the cluster. This is, for me, always the most exciting part, because we go from a room full of computers to a single amorphous blob of compute that bends to our will. I do this with a technology called Ansible. Ansible is going to push to these freshly booted nodes. I'm using a tool called Ara. Ara records Ansible, because aren't recursive acronyms fun? And this is going to put Nomad on the machine and join it. Now, remember, one of our success criteria was that we don't have any bootstrap toggles left at the end of this. So the very last step of pushing this bootstrap is going to delete the user that pushed the bootstrap. There are some considerations when you delete the user you're actively running as, but you can make it work, and it keeps the fleet clean. Once we have the OS on, now we can do some really fun stuff. We can use Nomad to push Ansible. Now, if you've used Ansible for any length of time, you may be aware that its Achilles heel is that its execution speed is linear with the number of hosts in a given playbook. And once you go above about 1,000 hosts, it's painful. There's no way around this. There's tools that can help you with this, things like Ansible Automation Platform, but it's still slow. Now, we can use Nomad to improve this a bit. Once we've brought up our real server nodes, not just our zero-level bootstrap compute, we have a lot more resources at our disposal. And we can use that to do more things with Ansible that we'll get to in a moment. Now, at this point, you do have a choice. You're running, you have your base cluster up. You could detach the bootstrap compute. But consider for a moment, that is self-contained. It does not depend on the rest of your infrastructure. Wouldn't it be nice to keep that connected so that if something goes terribly wrong, you have a lifeboat to flee to where your most critical control plane services can continue to run? It's a lot easier to recover things if they don't go all the way down. Now, I talked about using Ansible for this, and if you've come to HashiConf before or you've seen my past presentations, you may have seen the one where I told you why you should not use Ansible and you should use Nomad instead. So I want to touch briefly on this. Ansible is an extremely widely deployed system configuration tool. It's very popular. It's been around for a long time. It's very stable. It is also really easy to make self-contained. If you're not aware of the larger tools in the Ansible ecosystem, there is actually a first-party tool for building containers that run Ansible and that pack everything up. All your collections, your modules, your files, they're all in that container ready to deploy. And finally, and this is very important for what we're going to do, Ansible is agentless. It connects over SSH or other transports. And this allows us to deploy it in a way that doesn't require us to bake it into the image of the OS at install time. This has security implications. I'm going to show you something very cool, but you have to promise me not to run with scissors. We're going to run Ansible in a container. This is going to allow us to deploy it across our entire fleet simultaneously as a system batch job. You can even run this on a cron job so that your Ansible is being continuously refreshed across the fleet. We're then going to create a bind mount between the host's file system namespace of its root mount point and /host inside of our container. There's no rule that says that the chroot has to be the smaller slice of the machine. So having done this, we can now have Ansible join the host's control namespaces chroot into /host and execute using the chroot connection plugin within Ansible. Now Ansible is running using Python from the container to configure the host. This is an incredibly powerful tool because it means that now by using system batch and the fact that these tasks are scheduling concurrently using Nomad, we are operating Ansible in constant time, regardless of fleet size. This allows you to do a whole lot of really impressive things, such as running your configs on webhooks and having them push almost immediately, having things test for drift detection because you're constantly refreshing your Ansible. It also allows you to not have SSH on your machines. If you are confident enough in your configuration management, you can stop SSHD because you now have another way to push your Ansible to that machine. And once you get to this point where you're able to push Ansible in this way, your bootstrapping and your maintenance are the same thing. Now, this is a huge win. Your bootstrap and your maintenance just became the same thing, which means your bootstrap processes don't go stale, your maintenance is more reliable, and you now have one fewer thing to maintain because you've amortized the effort over the larger process. This is really taking the long view in building out this kind of infrastructure and making sure that you have a long-term capability to maintain a fleet. It's my opinion that we're going to see more data centers in the near future and more bare metal build-out. The cloud is extremely nice to experiment with and play with, but long-term cost optimization is tricky to do when you're just renting the capability. Now, I've shown you how I did this, and I want to give you a little more information about how you can operationalize this knowledge in your own environments, because what you saw is not something that took a limited amount of time to think about. I've been thinking about this for the last decade. Don't worry, you can copy my homework. It will be linked at the end. When we're deploying this kind of bootstrap compute, this needs to be small. We're going to eschew the ideas that this is a rack-mounted piece of hardware from a major vendor. Because if you have never tried to bring a 4U Supermicro through the airport, the Transportation Safety Administration looks at you real funny when that's your carry-on, and the airline gets annoyed when you scratch the plastic on their overhead bins. So we need something small. We need to be really small, because we may be flying internationally with it. And we really are looking at a solution for the problem we have, which is bootstrapping enough compute that we can bring the rest of the data center online. So we're not looking to run all of prod. We're not looking to be high performance. We're looking to solve the problem in front of us, which is powering on just enough compute that we can bring the rest of the data center up with us. Some of you can already see where this is going, but consider the small form factor NUC. These are excellent small devices. They're low cost, so if one gets left at a data center, run over by a server lift, dropped through the baggage carousel at the airport, it's not a big deal. The one I've shown here is a GMK Tech NUC Box 5. Of course, many people make these now. This particular one is small enough to fit in your pocket. This is what the 135 megabyte number from earlier came off of. This is what I've been playing with to build the entire demo set. 12 gigabytes of RAM does not sound like much in this day and age. My corporate laptop has almost 100 gigabytes of RAM because I do a lot of work with VMs, and so 12 sounds small. But 12 gigabytes runs a very respectable number of bootstrap tasks. You can really fit a lot in there, especially when you consider that you can oversubscribe this memory during bootstrap. These are not services handling user-facing traffic. So if they crash and restart, it's no big deal. Wait a minute, they'll come back. Nomad will reschedule them for you. And really, remember that this is not long-term compute. You can leave this connected. I'm not sure I would leave these connected. The power supplies run very hot. But it's not long-term compute. So we can do things here that might make the security people a little uncomfortable. We can do things here that are not the way we operate our standard data centers. But this is still a server. And serverless is so much fun. Is there a way that we can get rid of even the bootstrap server? Can we do this without that box? Well, it turns out, yes, we can. Most large, modern enterprise switches, especially things running at port speeds in excess of 50 gigabit per second, have substantial supervisory controllers. Arista, in particular, makes their supervisory controller available to the end user. It runs Arista EOS, which is a fork of the enterprise Linux ecosystem. It's also GPU accelerated due to the specific system on module they chose, which is always funny to me to see that my switches are GPU accelerated. But this means we now have enough compute that we can run the bare metal bootstrap on the switch. We've got everything we need to bring the data center up with no external hardware now. So where to go from here? Well, please go and build something with this knowledge. If nothing else, what I would ask everyone to do is to document your own processes. Future you will thank you. Have some idea of what depends on what, and think beyond the server about what other tasks in your bootstrapping or onboarding workflows can be automated. And share your work, because bootstrapping is hard. If you'd like to follow any of the example implementation that I have here that I've shown you, you're welcome to go to this link, which has the complete Terraform Ansible and Docker sources to be able to duplicate my bare metal bootstrap. Pause for one moment for people to grab the QR code. And finally, I want to look at how far we've come. We started with a data center that had nothing in it. And then mere hours later, through the power of Nomad and pre-staging some software, we're all the way at a running site that is ready for us to deploy our production applications to and start serving live user traffic. There are people out there who will tell you that it takes months to bring a data center up. I used to be one of them. But with this workflow, I have brought that timeline down to comfortably the point that I can tell you 3 hours. If you've got 3 hours, you can bring the data center from cold and dark to revenue processing. It's just a matter of choosing to build the automation and then streamlining it for your organization. If you have any questions, do please feel free to write to me at maldridge@voidlinux.org. Thank you very much for your time. I'll be hanging around the hub if you have any questions and you're here in San Francisco.
There was definitely some confusion there. I apologize for that. I'm way better at deploying infrastructure than reading the right line in a spreadsheet.
Yeah, so that was Michael Aldridge. He's a HashiCorp ambassador, and he was talking at HashiConf 2025, which leads us nicely to mention our annual user conference this year. So, Kareem, when and where is it?
So next HashiConf is happening in October this year in Atlanta. We'll have registration open soon enough. So follow our channels, make sure you're tied into HashiBits, our newsletter, and don't miss out. You get to see speakers like Michael talk about really, really good stuff. And, you know, just on that note, what did he say? From cold and dark to revenue processing is probably going to be Michael's biography. Michael writes software that matters and builds configurations that just work. And you can learn so much from this. So I definitely recommend you check out his code.
Yeah, there was a lot of cool stuff in his talk that resonated with me. In a previous job, I worked building a 4G data center for a network provider here in the UK, and we bootstrapped literally thousands of physical hosts up over four data centers. You know how legally in the UK, you're a service provider. If you're having like emergency phone calls through your data center, you have to be like on it. And if you can't make a 999 call, emergency call in the UK, the person getting the chop is the person hosting that data center. So it was one of those like high stakes, like very large scale, very high availability, but like so many of the methodologies and that Michael was talking about were things that we used in that project. So yeah, very familiar.
So very low pressure, right?
Yeah, that's it. No pressure at all.
Now I have to ask, you said 4 data centers. Is each data center good for 1G? So when you added 5G, you had to add a 5th data center?
Yeah, that's how it works. It's like when you've got engineers. If you have one engineer and it takes 5 days, well, 5 engineers can do it in 1 day. That's how it works, right?
That is definitely how it works. Though on the topic of actually expanding our knowledge and force multiplying, what really is a force multiplier is when you use Terraform to configure your GitHub organization and start doing stuff there, like repository configurations, branch permissions, and everything just done through code. That is really a force multiplier. The way you can suddenly enforce policies and make sure any code that gets checked in, runs through the same pipelines, is subject to the same restrictions, same dependabot configs, is absolutely amazing. And I'm super excited that Patrick is actually going to be talking about that next up. So with that, Patrick, if you are ready, let's switch over to you.
Thanks a lot, Karim, for the introduction. Thanks a lot for having me. Welcome to my session, Terraform and GitHub, Infrastructure as Code meets GitHub automation and collaboration. What can you expect from that? Before we jump into the topic, I would like to quickly introduce myself. So my name is Patrick Koch. I work as a cloud adoption engineer at AVL. For those who don't know AVL, I will do a quick intro on the next slide. What does a cloud adoption engineer do? What is a cloud adoption engineer doing all the time? So basically, we have a huge set of software applications, and we simply would like to push them towards to the cloud, providing them as a software as a service. So my team and myself, we're having a lot of fun of getting automotive software to the cloud, and there we have a combination out of Azure, GitHub, and Terraform. Feel free to get in touch with me using those channels. Doesn't matter which you choose. I will also be available, of course, during the whole day if you have some questions. According to my company, to give you a bit context, according to the circumstances, so I work for AVL List. It's a company based in Austria, and our business is the automotive industry. Most popular products still are our test beds for verifying cars, respectively combustion or engines, or also electric. And so we are also in some kind of transformation, let's say it like that, which means so we have a huge focus, despite from the traditional automotive topics regarding to electrification, autonomous driving, and of course we also need software. So imagine we put a car on a test bed, we produce data out of it according to the tests, and this data needs to be post-processed. We need the data for autonomous driving simulations, etc., etc. That's why we need software, and we also would like to run to have our software as a service, and therefore I'm heavily dealing with Terraform, GitHub, and Azure, and I would like to provide you a few, let's call it impressions, at least what I'm facing as a Terraform-focused developer when you switch to GitHub. So I would like to talk about a, let's call it, access approach between different GitHub repos. What does that mean? Let's figure out a dev container hosting, the automation according to the GitHub action workflows. Of course, we touch the GitHub provider for Terraform and some AI use cases, which may help you if you are working with Terraform. So let's talk about the access approach between different GitHub repos. So probably quite common use case is that, so I'm switching to my second screen. I hope you still can, you should see now VS Code. Is that true? Hopefully, Karen, can you give me a quick...
I think this looks good.
Thank you so much. First tried it also. That's the production use case. So thanks a lot for the quick feedback. So imagine you have set up your Terraform configuration in one particular GitHub repository, and you are referring to your self-written modules, which are probably not in the same GitHub repository, which are maybe on a different one. So for instance, in something like that, so a completely different GitHub repo, doesn't seem to be a problem at all, you may think, but if you're working with a lot of different people in a company in which you have some policies set, I think you mentioned that also, Karim. Then, and if you think of some other different circumstances, so imagine you would maybe have a lot of different organizations within your GitHub, a company-specific GitHub platform. Imagine you have some fine-grained permissions policies. Imagine you would like also to call the GitHub-related actions outside from GitHub, etc., and also some more security, too much security policies. Then maybe the solution for that, and we talked a lot about that, could be a GitHub app. So what's a GitHub app? In a nutshell, it simply allows you to set a specific access permissions between different repositories, which may be located in different GitHub organizations. So this could definitely help you also if you need some more fine-grained security settings. So we are using that now for years to set the access, and this definitely works properly. How could it then look like? So you set up a GitHub app, and that what I blurred here. So that's a screenshot from my company's GitHub organizations. It's the question: how do you do the setup within GitHub? So we have several different organizations, and therefore a GitHub app can definitely help you to allow the access between the different repos. And in one repo, you probably or maybe have your Terraform module set up. So we, by intention, we also did not choose to push them on a registry. So it's really the intention for us to manage it directly just from a GitHub repository. That about the accesses between different GitHub repositories. I would like to switch to the dev container hosting. What do I mean with that? So on GitHub, and maybe let's switch now to VS Code again. So in GitHub, despite from having set up a dev container in which you put in all the tools which you probably would need. So here in my case, it's the Azure CLI, Terraform lint, and the Terraform CLI. You can host the dev container if you don't have a container runtime installed on your laptop as a so-called code space. So, which means you host the dev container within the cloud. No need to install anything on your laptop. We tried that also quite intensive in my company. To be honest, I tend to use it more if I'm at conferences and if I provide some Terraform related workshops, because it's really great instead of having as first task to install all the different tools which you need for the workshop. You simply tell the people to set up their own GitHub repo, defining a dev container and defining the related JSON file for doing the configuration for your GitHub code space. So which means that you can also get the dedicated extensions which you usually have, and it is for workspace, for workshops, which I do, a huge benefit. So for the daily work, to be honest, I don't need it that often, but for the workshops which I plan and which I do, that's a really great thing. So really recommend, if you don't know it, if you didn't try it yet, it's definitely worth doing it. And in the end, yeah, it looks like that. So each code space gets its specific name. you can define how many cores and how many memory you would like to have. And you can also use it by default with a private personal repository. So it's free to use. I think it's getting stopped after a while, and it's also getting destroyed if you don't use it for a long time. Let's switch to the GitHub Action workflow, so the automation procedure in GitHub. How does that look like? So as a quick, simple example, what I have here is a so-called GitHub Action workflow consisting of several different jobs. So one is named verification, one is dedicated for creating the Terraform plan, the next one would deploy the configuration. What's the interesting stuff here, what you could take care about. So maybe let's run it. So we release now a job from this workflow. So at the verification job, it's not, that's probably not the threading part, where I simply check that whether all the necessary inputs from a Terraform configuration are available. Maybe let's risk also a look into the code while it's running. So the GitHub Action workflows you can define within the directory GitHub and workflows. You define it in YAML. What could be special here? So I'm doing just a simple demo here, which all of you can access. I'm using a public runner, Ubuntu latest, which already has, I guess, Terraform installed, which is quite comfortable. We check out the code, we log into Azure. So the idea of this workflow is to deploy a cognitive deployment on OpenAI service on Azure. You have here some support if you would like to set up Terraform. I run the Terraform linting here, and despite from that, I'm using steps similar as you would do it in a manual way. So the Terraform format, the Terraform init, the validate, the plan, and in the end, we can apply it. So here we run now two jobs, so verification and create plan. As you can see, it was stopped here. That's by intention. Always, of course, implemented in that way that you can inspect the plan. So here we would create a cognitive account, which allows access to different cognitive services, like the cognitive deployment, which in the end would provide you an OpenAI deployment, an OpenAI service, sorry. And here, as you can see, we have some kind of manual approval here. So after reviewing the plan, you can check it and get it into production. So to do the real deployment, quite combined according to setting up a GitHub Action workflow is setting up a proper branch protection rule, and also trying to make the life easier if you collaborate with your team colleagues by also checking pull requests here at the, if you have, for instance, a pull request, you can also provide some more transparency according to the Terraform specific stuff into it. So if you, for instance, do a change in the code on a sub-branch and you raise a pull request, make it as transparent as possible and simply show them that format and style, for instance, from your of your Terraform configuration worked, that the initialization was fine, the validation and the plan. Show also the plan, maybe here in the pull request to again review it, and only if that succeeded and if you have the checks done, allow to get it to the main branch. Also, maybe a bit more thrilling, let's talk about maybe self-healing GitHub action workflows. So let's switch to a different repository. So should be here, I guess. Yeah, so it's a complete different Terraform configuration. And assume I would simply simulate a validation issue here. So let's call it simulate validation issue. Commit that and push it. So I'm trying to make now this Terraform configuration a bit invalid. What would that cause? So this pipeline, for instance, the idea of this pipeline would be that it's getting scheduled respectively. It has a trigger for each push. So I did now something which you should not do, but it's just for a demonstration purpose now. So I'm trying to provide now a validation issue here. We run the very first job, which would now simply detect that issue. And the second job would simply try to fix it. So let's try to have some kind of GitHub action workflow which helps you to quickly get problems detected. So for instance, here in the second job, code agent fix. So hope it's big enough to get it readable. So an uncommented variable was here detected, and this is now getting tried to get fixed. For that, a dedicated pull request is getting created, which you can see here. And let's see what was changed. So the uncommented variable was recognized, and it will be included again. So you can review the pull request, which helps you to speed up, but also related to that, before you can merge into the main, you should run some automated checks, also trying to do the Terraform linting, the Terraform formats, the validation. That would be done here, and then you can merge it, and this should then provide you, when we switch back, if you sync it again, they should provide you the vnet variable back. Right. So GitHub action workflows, you can do quite cool stuff with that. Let's switch back to the presentation. So we have that. What would be next? Right, the GitHub provider for Terraform. So it's really great. You can use Terraform to automate your GitHub infrastructure. So therefore, you can use this provider integrations GitHub. So as a quick example for that, let's see it in the code. A really basic example how easy you can automate, for instance, your GitHub repositories would look like that. So you're having the resource GitHub repository, which allows you to deploy and to manage the GitHub repositories in an automated way. You can also do it with dedicated security groups. Why would you like to do that? So we are having quite a lot of different and a huge amount of different GitHub repositories, and we would like to enforce some policies. Here we would like to have security groups used, so no manual or no single adding of different people should that be allowed. This means you can really force that, and it's also definitely working well. You quickly recognize some manual changes when running the dedicated workflows, which try to set up, which try to get it, the Terraform configurations applied again. And it's definitely a big benefit for us. Maybe last topic, of course, something related to AI. Let me just grab the right configuration again. So what can I tell you according to AI-related thing is really specific to Terraform. So I think I won't need to tell you something about prompting, but what's maybe quite cool, you can create some custom agents in GitHub if you create some folder structure inside your GitHub directory with agents, and then having something like some arbitrary name -agent.md markdown, in which you definitely precisely set the context and some, let's call it, basic structures which you would prefer for your code agent to do. So you can provide a lot of different instructions how your personal agent should deal related to Terraform developments. You can then also, if you do prompting, pick it here. So here in the right lower corner, there is this Terraform agent optional here, which you then can choose for all the things you would like to do, for asking the questions and letting the AI work for you. You can also have, for instance, a second one, which is more, probably now more focusing on GitHub Action workflows. So you can then switch between them and distinguish between them, and having dedicated instructions for that. Right. This already brings me to the end of this session. So I've been working with GitHub, Terraform, and Azure now for several years. During that, we continuously try to evaluate and to try the different new GitHub features, and which we have a strong focus on Terraform. So we try in the end to bring a lot of different applications which we have into the cloud to have it as a software as a service. Terraform helps here a lot. We do all the related automation with GitHub, and it's a lot of fun, a lot of new experiences we make almost each week, and I hope it was a meaningful session for you. If you would like to get connected, here again some channels from me, and I would like to say a huge thank you to my hosts. Yeah, so thanks a lot for having me, and have a great HashiTalks.
Always love seeing how Terraform works with GitHub. It just works. It's beautiful and it's useful.
Yeah, definitely. So it was a bunch of really good info in that session. Lots of useful stuff. I mean, the agents instructions is another really good way of configuring. If you're actually thinking about it, if you want a good set of instructions to start off, you can actually go to the HashiCorp Terraform MCP server GitHub repository, and there is actually a pre-baked set of agent instructions in there that you can then modify and use. So another little tip for you.
That is a good tip. Hey, Sam, I'm noticing you have a very nice shirt on. Does it happen to be the same that I have? It is, right?
It does, yeah. Well, I wasn't going to wear a t-shirt. It's too cold here in the UK, so I needed a jumper, and this is my only HashiCorp official jumper. So there we go. Sticking up.
I can definitely confirm Europe is currently experiencing a lot of cold weather. This is very true. Thank you again, Patrick, for talking about a core infrastructure building technology. I mean, it's infrastructure as code. You kind of have to version that code somewhere. And of course, GitHub being a Microsoft thing. Let's talk about another Microsoft infrastructure technology, Minecraft. Matthias is going to be sharing some thoughts on how to use Terraform to do some stuff with Minecraft.
Well, you have to understand that Minecraft is a critical business infrastructure in my house. If my Minecraft server goes down, I have angry children wanting to know where it is. The SLA on that is more than 5 nines. It is milliseconds of downtime will cause anguish.
It is very much that with my cousins as well. As all of them get older and start playing, we now have, I think, a range of 12 or 13 years all playing together, which is amazing. I love the community building aspect of it. But man, the backend and the SRE expectations there are very, very real. This is not easy.
Yeah. High availability required.
Yes. All right, over to you.
Okay. So
hi. So during the next 30 minutes, I would like to illustrate what developer self-service with HashiCorp Waypoint looks like. And I would like to do this using Minecraft. So before I go any further talking about developer self-service, let's jump straight to the interesting part. Why Minecraft? Well, as many other good inventions, celebrities, and other phenomena, notably the Celsius temperature scale and the music wonder known as ABBA, Minecraft was born in Sweden. So Minecraft is a game based in a world of blocks where you can pursue a number of goals. So what I like about Minecraft are 2 things: mining blocks and building stuff. Mining blocks I do mostly for the therapeutic benefits, but building stuff, that's where I have the most fun. So why use Minecraft with Terraform and Waypoint? Well, as it happens, there is a Minecraft Terraform provider, and the idea of building stuff in Minecraft maps surprisingly well to how we provision, change, and reason about infrastructure as code. So you can manage blocks in the Minecraft world in the same way you would manage your cloud infrastructure in your favorite cloud provider. And frankly, it's just much more fun to see resources created in a Minecraft world compared to resources created in your cloud provider of choice. So you only need to try this once and you will be hooked. So I will return to Minecraft again in a little while. Before I do that, let me just briefly introduce myself. My name is Mattias Fjellström. I work as a cloud architect consultant at Accelerate. I'm based on the west coast of Sweden in Gothenburg. I'm a HashiCorp ambassador, and I run a HashiCorp user group here in Gothenburg. If my name sounds familiar, you might have read my blog. It's available on mattias.engineer, or you might have seen me on stage at HashiConf, or maybe in a previous edition of HashiTalks. All right, so let's talk about developer self-service. And taken literally, developer self-service could mean anything that a developer does on their own, right? But in that sense, the term isn't very interesting. Developer self-service becomes meaningful in the context of an organization where many developers work in unison on real systems and products. Systems that operate under constraints of regulatory requirements, internal rules, and shared standards. So in that type of environment, the challenge is not to enable developer self-service by itself, but the challenge is to provide speed and autonomy without losing control. So this type of developer self-service has grown in importance over the past few years, especially with the rise of platform engineering, with the aim of balancing developer autonomy with speed and control. So the idea of developer self-service is quite simple, and we can think about this in terms of food. So let me illustrate this with 3 different stories. All right, so imagine yourself at home. It is dinner time, and you have been planning to make a classic Swedish korv stroganoff or sausage stroganoff this evening. So earlier this day, you went to the supermarket and you bought the ingredients for the dish. You're now back at home in your kitchen. So you open the fridge door, you find the ingredients you bought previously, and you bring them to the kitchen counter. You fill a pot with water and you bring it to the boiling point. And that's 100 degrees Celsius, by the way. And you measure the correct amount of rice and you add it to the boiling water together with a sprinkle of salt. You heat up oil and butter in a frying pan. You dice the sausage and the onions and you put them into the frying pan. You add salt, pepper, and paprika spice, and you stir around for a few minutes. In a larger pot, you mix cream, tomato paste, minced garlic, and a little dash of hot sauce. You add the fried onions and sausage into the larger pot and you raise the heat and let it simmer for a while. So after a while, the rice and the stroganoff is ready and you prepare a plate for yourself. All right, so the story we just heard, it's akin to a developer who writes all her Terraform configurations by hand. She configures authentication, authorization with target systems by hand. She implements monitoring, backup, recovery procedures, high availability, redundancy, everything by hand. So this developer works autonomously to prepare the meal or prepare the infrastructure and has no real external dependencies to take into account. So while we do get autonomy in this scenario, we don't get much speed due to the fact the developer has to do everything by herself. And we also don't get much control as long as the developer is free to do whatever the developer wants, anything can happen, right? For the next story, imagine that you're visiting a restaurant. You're greeted at the door by a waiter who leads you to your table in one of the corners in the back. So you receive a menu as you sit down, and the waiter pours you a glass of water, and he says he will be back shortly. So the menu has many excellent choices, and the one you settle for is the Swedish korv stroganoff, or sausage stroganoff that we met earlier. After a while, the waiter returns, asking if you're ready to place your order. And you say yes, and a little moment later, the waiter runs off to the kitchen with your order. Tens of minutes pass by. Eventually, you finally see your waiter approach your table again, and this time with your sausage stroganoff in hand. And you enjoy the hot meal with great appetite. So this was a different scenario with the same ending. We ended up with a plate of sausage stroganoff. Is this developer self-service? Well, This scenario is like a traditional ticket-based system, right? So in this type of developer self-service, developers submit tickets to request what they need. These tickets are processed manually or semi-manually by platform teams, security teams, IT operations, etc. So generally, you could gain some speed in this scenario by not having to do everything yourself, but you lose some of your autonomy by introducing dependencies to other teams and to those who need to process your tickets. At the same time, this type of developer self-service has a lot of control because the people in charge of your platform engineers and so on, they have full control of what they are providing to you this way. All right, so for the last story, imagine a different kind of restaurant. So you walk in and you're greeted by a simple sign that says, choose a seat, order using the QR code on the table. You find a table in the back, and you take out your phone and you scan the QR code, and a menu appears on your phone. So you scroll through it, you select an appetizer, a main course, of course the Swedish korv stroganoff, and something to drink. So you place the order and you pay directly on your phone. So a short while later, your food arrives from the kitchen. So once again, you end up with the final reward, a plate of sausage stroganoff. So this scenario closely mirrors what we usually mean by developer self-service in a modern platform engineering context. So you request exactly what you need by yourself using some sort of portal, in this case an online menu, and the request goes directly to the people in the systems that can fulfill the order. In this case, it was the kitchen, but in a platform engineering context, it will be some automation platform in the background that takes care of your request and turns it into a reality. So in platform terms, this is like a developer selecting a cloud infrastructure offering from a catalog of predefined options, providing a small set of required parameters and hitting a submit button. Moments later, the infrastructure is ready for use, delivered through a chain of automation running quietly in the background. So the request flows straight from the developer to the underlying automation platform. There are no intermediaries, no tickets, and no unnecessary waiting. So in this case, we have autonomy, we have a lot of speed, and we have built-in control. Right, so developer self-service is often the central piece of something called an internal developer platform, or IDP. The IDP becomes the central place where developers discover, request, and consume what they need through self-service. So the restaurant menu we met earlier is similar to an IDP. And in what follows, we will see how Waypoint is an IDP. All right, so we now have an idea about what developer self-service is. So let's now talk a little bit about the tools. So HashiCorp Waypoint is an IDP backed by Terraform modules, and you can think of Waypoint as a developer self-service front-end to your Terraform modules. Your organization probably already have a library of Terraform modules available, and you can easily turn these into self-service no-code modules that are compatible with Waypoint by introducing one simple change. So the only requirement is that each module must be a standalone module, which means that you must configure the providers that you use inside of the module instead of in a root module. That's the only change. So once you have done that, you can use your modules together with Waypoint. So the primary components of Waypoint are applications. So an application represents some cloud infrastructure components that your developers have requested. Applications are based on templates, and templates are just a thin layer on top of your Terraform modules. So you can think of a template in Waypoint as sort of a class definition in a programming language. And an object of this class or an instance of the Waypoint template is the application. So developers will select a template and create an application from it. Then there is something called add-ons. So you can extend your application by installing one or more add-ons into it. So an add-on is also an abstraction of a Terraform module, but is designed to extend the functionality of a given application. So this could, for instance, be if you have an application that is a website, and now you would like to add a database to your website to be able to store some data, then you would install the database as an add-on. Finally, you can also perform day 2 operations for your applications in Waypoint by triggering actions. So actions are not based on Terraform modules, and currently there are 3 types of actions. It could be like an HTTP action, an agent-based action, or a GitHub Actions trigger. And the GitHub Actions action is in preview currently. All right, so a typical example of a Waypoint application would be, for instance, a website. So a developer selects the website template and they would create their website application. Then they would extend the application with a database resource installed as an add-on or maybe a Redis cache or something like that. Then they would run actions as a day 2 operations, for instance, to take database backups, releasing new versions of their website, or clearing the Redis cache data. But I promised I would illustrate developer self-service through the lens of Minecraft, so let's do that now. All right, so I will take the role of a developer, perhaps a gamer, who wants to set up a new Minecraft world. So the platform team at my organization has kindly prepared me with access to an internal developer platform, and this platform happens to be HashiCorp Waypoint. All right, so here I am. I'm a developer or a gamer inside of my HCP organization running in Europe. I go to Waypoint. We see that I've connected to HCP Terraform. I created a template, and now I can create an application. So I select the Minecraft template, and I configure it by giving it a name. So this is a fairly simple template, only has one input. So I create my application, and now in the background, Terraform will start working to provision the infrastructure for my Minecraft server. So here, through the magic of editing, my server is now complete. We can see that I can read any outputs that came, or I can just use my developer instructions to copy the address to my server. All right, so let's go to Minecraft and see if we can connect to this Minecraft server. I have no current servers available, so we'll just give my server a name here, Fantasy Island, and I will provide the address that we copied. All right, looks like the server is available, so I can join the world. And here we go. We see the world I've provisioned here is fairly boring. It's completely flat. It's green grass, and there is a few slime blobs jumping around. All right, so let's do something in our world, and we'll do this by installing add-ons, basically. So let's go back to Waypoint and click on add-ons for our application. And here we can browse the available add-ons. So I select the Egyptian pyramid add-on, and I need to configure it with what material it should be. I select the billionaire's building block. I provide an origin, that's a coordinate where I want my pyramid to be. And finally, I provide a width, basically the base width of the pyramid. Then I click on install. All right, it's installed, so now it should soon appear in the world. So let's just wait a moment. Now Terraform is running in the background to create the Minecraft pyramid. There we have it. And of course, billionaire's building block is this gold block, as you can see. All right, so that was installing an add-on, but of course we can install multiple add-ons if we want to. We can even install multiple copies of the same add-on. let's just find a different location here somewhere where I would like to install a house. So back in the available add-ons in Waypoint, I can click install on the modern house add-on, and I provide another origin where basically a coordinate where I want the house to be. And I click on install. All right, it's installed. Now, once again, Terraform is kicking off in the background, and it will provision this house for me. So let's just monitor the situation from up here. And there we have it. All right, so this is a modern house. I made the design here, so I didn't spend too much time on it. This is what a modern house could look like. I even have some lava inside. All right, so that's templates and that's add-ons, but what else can we do in Waypoint? Well, I mentioned day 2 operations in the form of actions. So we see there are a number of available actions. For instance, I could back it up. That's taking a backup of my Minecraft world, or I could do something else. For instance, make it rain. So let's trigger an action to make it rain in the world. So I mentioned that actions are not based on Terraform. So actions is something else. In this case, there is an agent running on the Minecraft server virtual machine. And the agent is constantly looking for if there are any available actions that have been triggered. So it's polling my HCP Waypoint environment to see, should I do something? And in this case, it will discover that there is a make it rain action queued up, and it will do whatever the action is configured to do. And in this case, it's configured to make it rain in the Minecraft world. So there we have it. All right, so we have seen everything you can do in Waypoint. Once you're done, you can just go ahead and uninstall the add-ons that you previously installed, and that will trigger Terraform to run a Terraform destroy in the background. So here I am uninstalling both of my add-ons, and I can also go ahead and delete the application itself. There we go. All right, that's Waypoint. Let's take a look at a few of the details of what goes on in the background here. So I mentioned that modules compatible with Waypoint are basically normal Terraform modules with one major difference. So here we have the repository for my Minecraft server. And as you can see, there are a lot of Terraform files setting up different components of what makes up my Minecraft server. Down here, you can see the README. This is what the Waypoint uses for the deployed application. So this is a placeholder that Waypoint replaces with the application name. So if we take a look in this providers.tf file, we can notice this difference that I mentioned. So here I have included the provider blocks for the Azure provider and the HCP provider. Of course, I don't need to provide static credentials or anything. I can still configure the providers using environment variables. So that's what I'm doing for both of these providers. But there are a few different configuration options that I need to provide here. All right. Let's take a look at inside of my files directory here. I have a few files that has to do with the Waypoint agent. So first of all, the agent is run as a service on this Minecraft server virtual machine. So I configured the service here in this Waypoint.service file. So you can see when the service starts, it just executes a shell script. We can open and take a look at what that does. Basically, it authenticates to my HCP environment, and then it triggers this run command. And the run command takes a configuration file, which we can take a look at. Looks like this. So it's in HCL. you define a group. It's an agent group called Minecraft, and then you have a number of actions. And as you can see, there are a few different types of actions. So for instance, for this message of the day action, I'm triggering a bash script called messageoftheday.sh. And simply what that script does is just it queries the Chuck Norris API and then uses the Archon CLI to communicate to the Minecraft server. Archon CLI is remote connection CLI, specifically for the Minecraft Archon API. Let's go back to the agent file. So we see the next action is the make it rain action, the one we saw in the demo. And here I'm directly using the Archon CLI, and I'm triggering this weather command with the argument of rain for 1 day. All right, then I have a few other actions, but if we scroll down to this action called backup, we see it's a bit more complicated. So this action consists of a number of operations that takes place one after the other. So it begins by running an Archon CLI command and just telling the server that there will be a backup performed in 2 minutes. Then it's sleeping for 60 seconds, followed by another message that the backup will be performed in 1 minute, followed by another sleep of 1 minute. And then I'm using the Archon CLI to actually save the state of the world to disk. And then I trigger a backup script that actually copies the backup to an Azure storage account. Finally, I notify the world that the backup has been completed. Right, so this backup script, we can take a look at it because it's generated when you provision this Minecraft server, but you can find it in the code if you go through it yourself. All right, one important detail here, if we go to my Waypoint environment, I open up Waypoint and I go to agents. You see that I have an agent group named Minecraft. So this name must correspond to the group in the agent configuration file. And if I go to my actions and let's open up the back it up action, we see that it has an identifier called backup in the group called Minecraft. So this must correspond to the same group, and the action must also correspond. All right, so that's how you map between different actions on a given agent. All right, so you assign actions to applications or to templates. So in this case, we don't have an application. So let's go back to our template, our Minecraft server template. And let's, it's over here in actions. You can assign actions to a given template. So whenever you create an application from this template, then these actions will be available to the application. So that's how you connect them together. Right, we have come to the end of this journey of developer self-service through the lens of Minecraft. We did not talk much about the underlying cloud infrastructure, and I didn't even mention Azure or AWS once, except for now. And my demo runs on Microsoft Azure, by the way. So what I hope was clear from the demo was how a developer using Waypoint worked autonomously to provision the required infrastructure. So the developer did not have to wait for approvals or external dependencies. The developer did not have to understand the underlying cloud infrastructure, but could instead focus on the domain of interest, Minecraft. Also, the platform engineering and security teams can build Terraform modules that fulfill any constraints, for instance, compliance requirements, and only expose those configuration options that the user should be allowed to configure. So in the end, do we want our developers to focus on the underlying complexities of the cloud infrastructure and how every component is configured? Or do we want them to focus on what matters to them? For instance, writing beautiful application source code, optimizing SQL queries, or building the best Minecraft world there is. So thank you for listening to my talk, and I hope you learned at least a little bit from it. And I encourage you to check out my GitHub repository where you can find all of the source code to set up the demo that I showed you. So until next time, bye-bye.
Imagine that, Sam. Kicking off a Terraform action to just change your weather. Wouldn't that be nice?
It would definitely be nice here because our Terraform action for the weather got stuck for about 40 days. So it's been rainy, shall we say. I'm just figuring out how I'm going to play pranks on my kids with that as well, because running actions to spawn mobs in their home or other mischief is.
Is it pranks, or are you just chaos engineering?
I like to think that I'm preparing them for the harsh realities of life.
It is very much that, right? I mean, you don't always have nice weather.
Exactly.
But thank you again, Matthias. Great talk. Of course, if you missed parts of this, you could go back on the live stream and rewatch it, but then you're missing the upcoming talks. So don't do that. We'll be sharing all these talks on YouTube in the coming weeks. So if you're just tuning in, or if you missed something, you want to rewatch it, you can catch up later. Just head on over to YouTube and find the HashiCorp channel, which you're hopefully already subscribed to. If not, now's a good time, and get some good content. So our next speaker is somebody who I think has been here for literally all HashiTalks. Not just the HashiTalks, the yearly edition. He's also been here for a lot of the special editions like Build and Deploy. I think even for the Dutch one that we had back in the day. So very excited to welcome back Bram Vogelaar, one of our ambassadors, to talk about agent-to-agent service discovery using HashiCorp Consul.
Everybody, wherever you are in the world, welcome to my talk, Agent-to-Agent Service Discovery using Consul and Build. My name is Bram Vogelaar. I'm currently a principal engineer and head of infrastructure over at Devo Team G-Cloud Netherlands. I've been a HashiStack user since Vegan 032, so been there for a while. I maintain some providers, and I'm the original author of the Prometheus Nomad Service Discovery service. And I run the Amsterdam user hug currently. So I always like to use a character as the main subject of my talks, and today we're going to introduce Bob. Bob is our new platform engineer. Bob's had a couple of job titles, although his day-to-day job hasn't actually changed that much, but currently Bob is our platform engineer, and Bob's going to help other engineers in our company perform their tasks in the most optimal way. Bob's been around for a while, right? Bob's is old enough to have racked and stacked hardware himself way back in the about 20 years ago. The focus was mostly get this hardware in, make sure that the cables are right, the lights are blinking. That didn't particularly feel well for Bob, because a lot of it was stuff being thrown over the fence and on the infra team. So Bob became part of the DevOps culture and movement, where the collaboration moved towards the focus moved towards collaboration between dev and ops, and how can we actually make sure that the applications we're building will actually run, and they're the applications that our users are looking forward to. So there was a shift of making it work to, is it actually working? So we're starting to look at metrics and deployment frequency. How long would it take to actually deploy something? And then that moved into the SRE movement, where there was a stronger focus on metrics. Is it where we use metrics and logs and traces to prove that something is actually working the way it should be working. And then now we're moving into the next phase of our evolutionary phase of a maturity model called platform engineering, where it's all nice and well when there's a lot of services are running. Platforms are getting far more complex. Over the years, we've moved into a shift left focus, where we let product teams run their own infrastructure. That actually put a lot of burden on these individual teams. So we wanted to abstract certain things that they're not supposed to be good at, like basic infrastructure, like racking and stacking, like they need to know about security, but they don't need to be able to produce all the security measures themselves, which makes sense. Because sometimes you do need a specialized role, and that's the focus for platform engineering has been releasing these functionalities, these abstracted functionalities as a self-service platform, where without having to go to a centralized infra team or DevOps team, SRE team, that people can actually use it. This is something we've actually been trying to do since the original traditional infra phase, but infra teams are notoriously terrible at building their own infrastructure, or not infrastructure, they're all, we're not developers. We don't build nice UI, we don't build nice UX, so we've always been struggling to get that going. And then I would like to take a step back. So as infra teams, we're not great at building self-service interfaces. However, for the longest times, there's actually been another focus within our industry towards chat ops. So can we actually use our day-to-day chat tools that we are using in an asynchronous or distributed way already, right? I work with teams that are not in my country. So we have this chat, it's either Slack or Google Chat, or, all the way back to 2011, or what I want to take us is when GitHub introduced Hubot, which was the original chat ops bot, which back then was amazing, but was still hard to use. And then we moved on to Telegram, where Hubot was mainly, you could integrate it into XMPP, like a Jabber service, and then it slowly moved towards Telegram and WhatsApp bots. Telegram being very famous for releasing their Telegram bot father. So you could have a chat bot in your pocket, right? That was on my phone. That slowly moved to Slack, and now we're getting into an age where these chat bots are actually LLM backed, so we can have more natural conversations with these tools. And that was actually quite needed. This is an example of Hubot when it was released in 2011, and it was very 2011. The interface bled directly to the user interface, so you would have to do Hubot verb and then the exact parameters it was expecting. I always got confused by create user. Is it username, email? Is it groups? Are groups separated by commas? Are they separated by spaces? I could never know, because for me the most used Hubot command was actually Hubot help, where it would actually show me what was required of me. It had some other peculiarities, right? You ask for Hubot on call now, so who's on call now? That throws in very unuseful error, because it turns out now needed to be escaped even on the command line. So it was useful, but it was not something I could give to developer teams easily, because it mostly required still a lot of infra knowledge on how to interact with these tools and how to interpret errors. Over the years, it got slightly better. Here we're seeing a screenshot of Slack, where there's a Grafana bot where I can ask in a relatively normal way, who's on call right now for the platform team. And then these tools will be able to parse my question and then give us the right answer back. It almost got useful. Now we can ask things like, can you check if there's were there any issues in the last few hours? Last few hours is, of course, a very flexible principle. It also, there were other issues. So a lot of these things were trained on US language models, whereas I lived in the UK for a long time. So my English will be UK English, which some of these tools weren't particularly familiar with my version of how I would like to ask these questions. And that's where the LLM-based natural language models come in. So that's where we're hoping that our agents are now actually going to help us do these things in a more natural way, the way I would want to talk to these tools. To give away, we're not really talking about Bob, it's Bram, right? It's me. I've described the last 20 years of how I've been trying to unleash these self-service chatbots on people so that they can be empowered to do things. So I'm mega super excited that we're now in the AI age where I can actually can work the way I would like, and then these tools interact with me the way I would like them to. So as I said, things are getting excited. Things are also getting slightly more complex. So today we're going to reference a couple of things. We're going to build an agent in something called the Agent Development Kit, which is basically an SDK that the lovely people at Google have released, so we can naturally incorporate these LLMs without having to do much programming. We also want agents to be able to talk to agents, because I as a platform team, we're going to build some agents that other teams can directly communicate with, or other agents can directly communicate with, so that individual development teams or engineering teams can build their own agent that know about their particular business logic or way of working, then just interact with a bot I've written. And then there's MCP, which people call the USB-C of AI, which is for me the natural translation between agents. Is all about inferring natural language and intent from natural language, where MCP servers actually go out into your infrastructure or your platform and do things on behalf of you. For instance, what we're going to see today, we're going to create some Consul intentions. Let's build ourselves one of these little agents that are going to help. ADK supports 4 languages, but due to space on the screen, I've used Python, since that produces the least amount. You can produce an agent in the least amount of lines of code. You'll need to do 3 things. You need to import the correct package. In this case, as agent. You set up an agent, you reference a model you would like to use, you give it a name, you give it an instructions, and you reference tools that this agent is gonna use to act for you. In this case, naming things is hard. A function called create SRE things that at the moment just always returns success, and that's what we're going to build out today. Talking about A2A, so our original root agent is going to be the engineering team's agent, whereas the SRE agent is going to be the service orchestrator that is going to act on things on behalf of the platform team. For that, you actually need to only include 2 extra lines. You need to import the 2A2A package, and then declare your agent that we've defined previously to be capable of receiving agent-to-agent traffic, and you're going to expose it at a certain port, in this case 8001. And then on the other end, we on our receiving interacting agents, you add 2 more imports, and then you specify where the remote agent or the remote agent that you want to use is where what its name, what its description, and where it lives. A2A has a well-defined way of exposing things. That's why the URL looks a bit complex, but it's a fairly standardized way of dealing with things. So we're going to point it at an IP and a port and a certain URI. And then the extra line that we need to add is, instead of on top of referencing tools, we're going to reference an agent that, and then reference the agent definition that we've had. So now we can actually talk to things. Well, for those that have been around for a while, like I have, you see that although the highlight is just a line too low, but you're going to see here that the actually IP address and port is very static. We've been in a microservices world for a while now, and people have been running those and actually understand this breaks my cloud native principles. We can no longer take this down, bring up a new one at a different location. I cannot bring up more than one unless, of course, you're gonna stick a proxy in between. So we need to actually have a fix on, we need to sort of abstract away where this thing lives. Luckily, the lovely people at HashiCorp have come up with a tool. It's actually been around for quite a while, since 2014, called Consul. It does service discovery and service mesh. So service discovery, it can find things. Service mesh, it can actually protect you from, protect people from using it. It has a built-in KV store, so if you ever need to store distributed information, you can also use Consul for this. And the added benefit for Consul in my world is that it also is able to deal with sort of brownfield, greenfield situations where it also has terminating gateways to switch between your service mesh and, for instance, existing services that been around for a while, so the old infrastructure that need to be accessed. You can mesh two clusters together, which is, if we're having Kubernetes fans in the room, is more difficult to do with existing meshing services within Kubernetes. So I like Consul still very much as a service discovery tool solution for this. Let's build out what service discovery mean. Let's focus on that one a little bit. It's basically several instances of a certain service that announce themselves into, in this case, Consul, and Consul. We can query Consul now. Where are these things located? Consul actually has a super cool DNS server built in, so we can actually query it as it were a DNS service. We can query A records. We can even query SRV records for these servers, so we actually can be told what's the IP, which we always get in an A record, but IP and port if you're querying SRV records. So if you're really writing these implementations in code, you can actually work out where our services live. And Consul can, in this way, also be integrated into your standard DNS services, right? We create a zone for this Consul domain as per default. Consul sets up a Consul domain to actually host these services and queries. In that case, we can just simply use DNS, a standardized DNS, to get to our services. How do I announce a service into Consul? You basically write a simple configuration file that Consul can pick up. It's a service object with a name. You write a port, and then you can also do very cool things like health checks, which in this case we check every second with a 1 second timeout. I show a health endpoint here. ADK as of yet does not have an health endpoint, so you would have to write those yourself, but they're not very hard. It basically needs to respond to an HTTP 200 whenever it's queried. So now we can update the static bits. Here you can actually see we now no longer reference it by IP, but we reference it by DNS name, the service coordinator.service.consul. It's still at the port 8001. So on the platform team, there's still somewhat of a burden to make sure that all these agents, the rapid custody agents, all listen on port 8001. I would love to say here is like, thanks for coming to my HashiTalk and let's be merry. But I've been in a lot of structured and well-regulated situations where the situation that I've just described, a lot of CISOs and enterprise architects basically gonna get scared. It's still very proof of concept because of the following two reasons. In these well-regulated locations, we talk a lot about 4I principles and least principle, the least amount of rights that you need. The thing needs to run with the least amount of rights that it should have, because what we've seen so far is a lot of the agents, they run somewhere in your network with probably never expiring tokens that have a lot of permissions. So we actually need to, in the second half of the talk, we're going to try and work out how we're going to make sure that it is safe to have these agents running in your infrastructure. Because even as we've seen before, if you know the URL to this agent, you can approach it and you could do things, let it do things on behalf of you, even though it may not have, should do these things on behalf of you. Within GCP, my favorite cloud, there would be an easy knee-jerk reaction to do this. Our best practice would say, surround it with a firewall and cloud armor, to not let things in, just create a service perimeter to not let things out, and then have a private access to whatever Google services you would require. This, in the age of agents, is probably not enough, because you're going to have a bunch of them run inside this dome, still with too many privileges and with too much access. So in the next couple of slides, we're going to build up what it is you need to actually set up to make this safe within the dome. In this case, we're going to have Consul Connect, which is the service mesh option within Consul based on Envoy. So for the Q people, it's the same underlying service that Istio uses. It's fairly simple to add to a Consul service. You basically add a connect block, and you have an empty site proxy within the sidecar service. And that's the only thing you need to do to announce a service as connect enabled. How do we then connect to a Consul Connect service? You now do the same thing on the accessing side, but you actually declare what upstreams you would like to use. In this case, we're going to use the SRE coordinator service agent, and then bind it to a local port 8001. And then now I need to explain a little bit more about how the service mesh actually works. What Consul Connect actually does, it runs a sidecar on both sides, binds to a local port, in this case port 5000 in this example on the dashboard, and 9003 on the counting service. And what it does, it creates a tunnel with MTLS, so certificates on both ends, making it a secure tunnel that looks like it is a local connection on both sides. So where you can actually address, even though it's remote, we can address your remote agent on local host port 8001, making it that we fully abstracted away the network in the sense of that people need to know where things live and on what port they're listening on. From now on, you can just approach it as a local host service, and then the MTLS in the tunnel actually transports it to where it needs to be. Some people that have been listening still say, like, hold on, you've actually made things more complex without actually fixing anything. And I would say that's true. Because service mesh has two components. One is abstracting away the network. The other one is limiting the access to these services. For that, Consul has a principle called intentions. In this case, I can create an intention for the SRE agent to be able to connect to the SRE coordinator. I can also blanket deny access to the Consul MCP server. I can list them, I can delete them. So there's a nice CRUD system in there to actually set up these intentions. So now it will be allowed, either allowed or denied, depends on what intentions have been created. And at this point, I would like to introduce Vault, because the people that have been listening carefully also understood that even though I'm creating intentions and I'm blocking traffic, anyone can actually access this console service and create or deny services via intentions. So we need something that actually is going to give us ACLs. Today we're going to use Vault for that. It also has a KV secrets engine, which is something we've seen in AWS and GCP. It can also deal with cloud permissions. So instead of having a long-running token on my system, I can actually have Vault give me a token for GCP or AWS or Azure that is time-bound, automatically cleaned up. It's going to give me the least privileged token that I require. It also does things like identity or IDC. It can also do PKI, so it can actually be a certificate authority for the MTLS certificates that we've been discussing so far. I'm not gonna go there today because it would take too much time. Today we're gonna focus on the Consul ACLs. How can we actually make sure that I can only manipulate the things that I'm supposed to be manipulating? So Consul is built up in engines. So in this case, we're going to enable the Consul secrets engine, and we're going to point our Vault to our particular Consul cluster. I'm going to link those two, and then we're going to bootstrap Consul, having with a super secret initial token, and then that's now means that you need to have a token to be able to manipulate Consul. So please share this. Please don't use super secret as your super secret, but also store it somewhere else so that we can always recover. Then we link the original token, the bootstrap token, and then we actually create a role so that only certain nodes can actually access the cluster. What Consul of Vault calls read. So we're going to actually create a temporary token, in this case, valid for 768 hours, which probably is too long. So it's limited in scope. You can tweak these things yourself. Then we can actually use this token to create these intentions, manipulate these intentions. So we've covered now our last angle. So our Consul is no longer manipulatable by all people. You need to have a token based on a role and a Vault token. So hopefully, in the last 35 slides or so, I've made our CISO say the magic word, I'm a happy bunny. We not only created agents that we can give to people that they can address in natural language, but we've also took into consideration the security implications of having these agents doing things on our behalf, basically in God mode. running unchecked. So we've layered our agents into a certain ACL structure where we can be in control, we can revoke, we can give or reduce the amount of parameters that teams should have access to. That concludes my talk for today. Feel free to reach out on the following email address if you have any questions or comments. Thanks for watching today. See you soon.
That was a great talk.
That was a great talk indeed. Bram always has so much good stuff in there, right?
Yeah, always good to see different products as well being used together and for what they were created.
I love that one of the comments was like, are you still using bind, or was it something else? And it's like, well, like technology doesn't become obsolete just because it's old. It becomes obsolete when it no longer works. And bind works just fine a lot of times.
Yeah.
So yeah.
Actually,
what are we switching to next?
I mentioned that project I worked on before, the NFV one, full-on modern technology in the background, bind.
Of course. Never change a winning team.
Exactly.
I mean, even the ring poem talks about it, like the rings that bind together your services, something like that.
Something like that.
Something. We'll work up better material after this next talk. What's next for us, Sam?
So next we have Leon Kras talking to us about vaulting over compliance, aligning secrets management with European data laws, which is quite an important topic.
Can confirm.
Hello. Perfect. I can see myself now. I hope everyone is able to hear me. If not, just let me know. Otherwise, I'll now start with my talk, vaulting over compliance, aligning secrets management with European data laws. I mean, of course, the topic sounds a little bit dry at first sight, data laws, stuff like that. But actually, it's, as you guys said, it's an important topic that we should be discussing on, and there are actually a couple of cool ways to deal with the requirements of these laws with tech. So let's get into it. First, a few words about myself. My name is Leon Kras. I work as technical leader for HashiCorp Vault at SVA, Systemvertrieb Alexander GmbH, which is the German system integrator. Talking about SVA, we are Germany's biggest owner-operated system integrator and has steady growth with more than 3,700 employees in Germany. And we accompany our customers on a long-term basis throughout the project lifecycle. Yeah, a lot of some of our company objectives, of course, include a motivating environment for employees and partners, as well as quality, integrity, and customer appreciation. To give you an idea of where we work and which industries we are active, we got 28 locations in Germany or all over Germany, and our HQ is located in Wiesbaden. We are active in industries like the automotive, retail, public and healthcare, communications, finance and insurance, you name it. That's it for SVA. So what will you guys be hearing today? We will start off at a pretty high level. So I'm going to explain to you what NIS2 and the GDPR are. This is a little bit high level, but we will get into the interesting stuff later. I will show you how Vault can act as a compliance engine to fulfill requirements that are required by NIS2 and the GDPR. Then we got a small demo where I will show you how you can use Vault in practice to align with the requirements GDPR and NIST are giving us. And in the end, I'll do a little wrap up. So what actually are NIST2 and the GDPR? I thought I'll give you a little overview because not every listener in here might be European. So I'll just thought I'll give you some details on that. So first of all, this is the European Union. Actually, we shouldn't confuse the European Union with Europe. So there might be a little, I wouldn't call it mistake, but the European Union is a subset of Europe, which is made of 27 states. And the goal of the European Union is, one of the goals of the European Union is to regulate and the member states of the EU to protect them and regulate it in a way that all states will have a good time together. In the European Union, we got two different artifacts, let's call them, heuristic artifacts. One of them is called regulation. A regulation is binding, so every EU member needs to stick to that binding, and so the regulation actually is a global law which applies to all states. Actually, there are some kind of clause which is called opening clause, which allows the states to make some differences in details. For example, the amount of violation fees for some kind of violation, which is described within the regulation. So they are a little bit they are a little bit flexible with that. The other thing I want to show you is a directive. A directive is a defined goal by the European Union, which acts as a blueprint for an own implementation of it in national law for all states. So like each state in the EU will have to do its own implementation of the law, and the directive is defining the goals which are set for these laws. That being said, NIS2 is a directive. NIS stands for Network and Information Systems. And this is the second version of this directive. There already has been one in the past, which was like only applying to a smaller subset of industry branches, but NIS2 is a lot broader than NIS1. NIS2 is effective since January 2023, and its implementation was due to October 2024. You can actually check via your local authority if you are impacted. So what does NIS2 do? NIS2 regulates cybersecurity to protect the economy, enforce liability, and strengthen awareness about cybersecurity, which still is, in my opinion, a pretty important topic because, I don't think we are at a point already where the awareness is high enough, but I don't think it can ever be high enough. So NIS2 actually does not give us specific technical implementation requirements, but it is meant to establish a continuous security optimization cycle. If you want to get started with implementing NIS2, you should have a look at ISO 27001. Excuse me, 27001. ISO 27001. So why should you actually care about NIS2? NIS2 is very important if you are operating inside the EU. There might be penalty fees if you violate the goals which are set by NIS2, or if you violate the codes which are enforced by your local law or the local implementation of NIS2 within your state. If you're a CEO, this is very interesting for you because NIS2 actually enforces liability for CEOs. So that means you can personally be made liable if you are violating NIS2. And of course, NIS2 is interesting for your own safety. It will prevent damage, which might happen in case of a cyber attack. Let's look at the GDPR. GDPR stands for General Data Protection Regulation, and it is effective since May 2018. The GDPR regulates personal data handling. It offers a legal basis the GDPR requires a legal basis for data processing. So data must be processed lawfully, fairly, and transparently, and with limitations on purpose and storage. It establishes principles for the processing. As I said, these principles need to stick to those principles. On the part of accountability, if you have a data breach, you are forced to actually notify your customers, and your customers also have something called a right to be forgotten, which are as defined in data subject rights. Just to give you a little overview what the GDPR regulates. The GDPR also implies appropriate technical implication requirements, which are bound to the use case of personal data processing which you are facing. The whole thing is very abstract, actually, but there are a few requirements which are pretty, where you can read the technical requirements from the text. So why should I care about the GDPR? GDPR actually applies to any organization in and outside the EU, as long as personal data of an EU citizen is processed. So if you do business with EU citizen and you don't stick to the GDPR, you could face penalty fees on violation. If you're an EU citizen, you should care about the GDPR because GDPR protects your personal rights, which is a pretty nice thing. So to compare those two, the NIS2 directive and the GDPR regulation, NIS2 is a directive. It is regulating IT security and only applies inside the EU. And GDPR is a regulation which handles personal data handling, or which regulates personal data handling, and it applies in and outside the EU as long as a EU citizen is involved. Which consequences do we have to face from NIS2 and the GDPR? You need to check if you are impacted, of course, and you need to do a risk assessment. So am I impacted? What consequences do I have to face if I violate one of those laws? A possibility to do that is to consult your local authorities. Most of the local authorities, like the German BSI, offer websites where you can just click through some kind of form or something, which will tell you if you are affected. Or you could also consult a company like SVA, which will help you out with that. The next thing is that you need to establish a reporting office. Both NIS2 and the GDPR require you to have a point of contact if you are impacted. So this point of contact, on the one hand, will be used to get contacted by your local authorities for audits and stuff like that. And on the other hand, this reporting office must report data breaches or security incidents to your local authorities. The last thing, and this is where Vault will be joining the game, is that you should prepare for possible audits. So to prove you can fulfill all obligations of NIS2 and the GDPR, you should be prepared. And for that, we will be using Vault as a compliance engine. So what is Vault offering us to comply to NIS2 and the GDPR? I will highlight a few points which are rather abstract and tell you which Vault features can be used to establish those goals. In the demo, we will especially focus on audit trails, which I'll be presenting you. So one thing which we need to think about is data encryption, of course. Data encryption in general means the reversible transformation of readable information into an unreadable form. Vault offers different features for that. For example, we have a cryptographic barrier for Vault's internal data. So all the data stored inside Vault is encrypted properly. Vault can act as encryption as a service provider using the transit engine or the transform engine. And Vault supports transport layer security using the PKI engine. Also, you can have centralized key management for your encryption purposes using the KMIP engine. Also, for advanced cryptography, you can integrate Vault with a hardware security module, which offers you advanced entropy or seal wraps for Vault's seal wrapping mechanism. So to look at NIS2 and the GDPR again, data encryption in terms of, from the perspective of NIS2, data encryption helps you to ensure confidentiality and integrity, which are two of the CIA triad goals of cybersecurity. And data encryption reduces the impact of data breaches significantly because encrypted data, in theory, can be decrypted, but it makes it a lot harder for an attacker to decrypt encrypted data compared to having the plain text. In terms of the GDPR, data encryption enables secure data processing for non-sovereign environments. So, for example, if you are processing your data inside some kind of hyperscaler cloud, you could maybe encrypt it beforehand to store it out in the cloud and keep personal data safe. And another thing is that, the secure storage of sensitive data requires encryption, which is stated by the GDPR. So sensitive data is this, the GDPR categorizes data in different or classifies data into different categories. One of those is personal data, and the other one is sensitive data. And sensitive data usually always needs to be encrypted when stored somewhere, because sensitive data, which includes information like your religion or your gender, your sexual orientation, for example, which is of course very sensitive. It's very good to have that encrypted because people could do bad stuff with it when information like this is leaked. Next thing I want to talk about is secret rotation. So secret rotation means regularly replacing credentials, which includes API tokens, passwords, stuff like that. And Vault offers different mechanisms. We got, of course, dynamic secrets, which we can create for databases, for SSH access. Each major cloud provider is supported to have dynamic credentials created by Vault, and that's one of the biggest advantages of Vault, I'd say. Also, you can rotate root credentials, which means if you are connecting for a database, for example, with Vault, you need to provide some root credentials to Vault, so Vault can generate user accounts, for example. And those credentials can be rotated. They even can be rotated periodically, which in some business areas is also a hard requirement offered by NIST 2. Another thing that you have is key rotation. So we can rotate internal keys within Vault, for example, the encryption key of Vault's database, which also can be a compliance requirement. And key rotation also is possible for the keys we use in Vault's transit engine. The Vault transit engine makes it really easy to have a key rotation process happening. Also, Vault supports certificate rotation if you're using the PKI engine. We can seamlessly migrate to new intermediate certificates. Vault is providing us all tools we need for that. So, yeah, in general, Vault is using leases for this lifecycle management. We also can revoke and rotate our secrets if needed. How does it help with NIST 2 and the GDPR? So for NIST 2, secret rotation drastically minimizes our attack surface. When we're having a shorter lifetime of secrets, secrets are not existing when not used, which this makes brute force very hard, for example. Secret rotation enables zero trust architectures, especially due to the short lifetime of our dynamic secrets. Also, we can stop cyber attacks immediately by just revoking the compromised credentials if we manage to figure out which credentials are compromised. In terms of the GDPR, secret rotation reinforces the security of personal data processing because the overall security is enhanced by secret rotation. Also, root credentials can be hidden from humans or from human. So no one is able to access any personal data using root credentials, which a person could be aware of. If we are able to rotate our root credentials and hide them from any administrator and only store them in Vault, we can be safe that no one is actually able to access personal data with those root credentials. Last thing I want to talk about is audit logging. Audit logging describes the practice of recording who did what, when, and from where. So for this purpose, Vault offers something called Audit Device, which is pretty well aligned to the GDPR NIST 2 because, especially to GDPR, because sensitive data is hashed by default. It is flexible in its integration. We can use multiple interfaces. We can write our audit logs to a file, to syslog, or to a socket. It offers tamper resistance using HMAX, so hash-based message authentication codes. So we can check if each individual audit log entry is actually generated by our Vault instance. Audit logs are pretty handy because they can be further processed in log collectors and CMs, so in security information management systems, which allows us to correlate those information with information from an identity and access management platform, which we will be doing in the demo. In terms of NIST 2, audit logging supports non-repudiation and accountability. Why is that? Because each transaction is logged. When each transaction is logged somewhere, and we can associate those logs with identities, no one is able to no one's able to repudiate their actions. And accountability is enforced that way. Also, investigation on cyber attacks is simplified. When a cyber attack is happening, we will be able to trace which user might be the compromised user. In terms of the GDPR, audit logging helps us to make access to personal data traceable and transparent. So think of an audit, for example. Within an audit, an authority could ask who accessed which personal data when. An audit log is exactly which will give us the evidence here we need. And the transparency we need to prove to the authority that the personal data was accessed in harmony with the objections we have for data processing. Also, we can prove that our data processing is lawfulness, which is pretty much the same thing I've just told you. Okay, next thing is that we will gonna get to the demo. Just let me have a little sip of water here. Actually, we're pretty well on time. Okay, so I'll just show you the architecture of the demo first. In the heart of the demo, we of course got Vault. We will be using Keycloak to authenticate to Vault using OIDC auth. And Vault will create dynamic credentials within the Postgres database. We will collect logs from Keycloak, Vault, and Postgres using Fluentd. So the whole demo setup is running inside a kinds cluster, and Fluentd is installed as a daemon set within this kinds cluster. This kind is a form to deploy Kubernetes cluster. And we collect all those audit logs from Keycloak, Vault, and Postgres with Fluentd to send them to OpenSearch, where we will have a dashboard and a way to correlate the audit logs from each individual system. Let me just switch to the demo setup. We've got a terminal here and a web browser here. So this demo is live. I hope the demo gods are with me today. But let's just give it a try. Let me make sure that I am not logged in. I'm not logged in. I got a demo user here, which is called Alice, as usual. And I got 3 OpenSearch dashboards. This one is for Keycloak, and we got no results currently, as I haven't done anything yet within the last 5 minutes. Here we have another empty dashboard for Vault and another one for Postgres. What I will be doing first is just simply logging in to Vault using OIDC. So as soon as I hit this button, a pop-up should come and I can just log in as Alice. And this action already produces logs within Keycloak, Vault, and not in Postgres yet, but in Keycloak and in Vault. Just have a look at this. Let me just refresh it. And we can already see that we logged in to Keycloak. And the realm we are using here is called demo, which is basically some kind of namespace or tenant within Keycloak. And we are using a client, which is the connection to Vault within Keycloak, which is called Vault. So the application registration, if you want so. For Vault, we see that someone logged in. Here we got the path which got accessed in Vault. So the OIDC callback got triggered, which is part of the authentication mechanism we used here. We got a token lookup because Alice was issued in token on the successful login. And of course, because we use the UI, some UI stuff is happening here. And as I've told you, nothing yet for Postgres. So next thing we're going to do is to use the database engine, which I configured here. Alice is actually a person who has access to the role pgadmin. A pgadmin, this role will dynamically create a database user within the Postgres database, which is able to do read and write operations, as well as create table, delete table, drop tables, all the stuff. So as soon as I hit this button, the credentials will get created. Let's have a look again at the Vault logs. So we see here that Alice requested the database creds pgadmin path. And here in the response Vault sent, we see that a lease was created. And this lease is handling all the information and all the session information for the database access we're having right now. Within Postgres, let me just clear this. Oh no, this is working. We see the Postgres user, which is our root user in this case, created a role with some password, which won't be shown here, of course. And we got a grant here for the created user, which grants all permissions on the public schema to this user. Okay, so the username here is something which we can influence within Vault. I created that way that within this username, we got the display name, or the user ID, if you want so, which is used within Vault for Alice, which is also displayed over here. That way, we can trace all the actions of the user from Keycloak to the database. Also, we see that we've got our lease ID here, which has been displayed within the Vault logs. Okay, let me just use this, and I'll get over here, and I use PSQL, which is the command line interface for Postgres. And I'll just use this username to log in, which won't be doing a lot. Oh, excuse me. I mean, yeah, you can see the password is only working on my local machine. So you won't be able to do anything with that. Oh, well, there we go. The demagogues are not with me today. Let's give this another try. Come on. Okay. Well, I'm very sorry that this is not working. I tried this early on, but let me just try to create another user. So, nope. Actually, we should be able to see those failed logins. Oh no, actually we can't. Well, I'm really sorry that this is not working out. Otherwise, I would have shown you that as soon as we logged in with this user, I would have created a table within the database, and those create table statements would have been logged within this database log. Actually, I did this earlier on, and I didn't delete it. Deleted what I did. So yeah, I just can search for create table here and increase this value because it should give me the logs I used from my in my last execution. Okay, yeah, there we go. So this was the last time I used, I tested this demo. It has been working, and there I logged in with a similar user, which also has the same OIDC ID here, which we can compare to Vault. So within Vault, it is OIDC 5407 and so on. And here we got the same OIDC 5407. And we see that this user, which is Alice, created a table here. And later on, she dropped that table again. So everything she did from the login in Keycloak to log into Vault to her actions within the database is completely traceable. And yeah, if we want to make someone accountable for dropping this table, we can completely trace the actions back to the ID in Keycloak and see that Alice has been doing that. Okay. So that has been the demo. Let's wrap everything up. You can see my slides yet. You can see them now again. So the EU requires compliance with NIS2 and GDPR, and companies and persons can actually benefit from that because it offers better IT security and personal data safety. Vault can support you enabling compliance with NIS2 and the GDPR, and the demo gave you an example how this can work. There are actually many more options available. I thought of also showing you how to encrypt the Postgres database using the KMIP engine in Vault. But as we are on 32 minutes now, I think it's time to end my talk. If you want to do the demo on your own, you can get a copy of the demo by scanning this QR code. The code is fully available on GitHub. And if you have any questions, feel free to contact me here. And also I will stay in the chat a little bit. Yeah, so that's it for my talk. Thank you for listening, and I hope you all will have a great day.
All right.
Amazing talk.
Thank you very much.
It is so hard to talk about anything involving the legalities of the work that we do and the frameworks we have to deal with, right? Especially when it comes to stuff like NIS2, GDPR, all the frameworks, all the deadlines that, have deadlines of this has to be implemented by this time, yet we don't know actually how you should implement it. It's up to your country to decide. Yeah, sorry, we'll let them figure that out for you. Thank you so much, Leon. This was amazing. Thank you for sharing your slides and your GitHub repository. I'm definitely checking this out. There is so much good work in there. I mean, it's a beautiful combination of services and just excited seeing that.
Yeah, definitely. And, it's good to see a live demo that doesn't quite go right and you think on your feet as well. So I enjoyed that. You probably didn't, but I did.
It's a hallmark of a true engineer, right? Just figuring out the problem, solving the problem, going forward, and not losing a step. Well done, Leon. Seriously. All right, HashiTalks. We've got a challenge for you.
Drum roll, please.
Yes. If we could afford the sound effect, we would definitely be playing that right now. But head on over to developer.hashicorp.com in the new tab. Don't do it in this tab because otherwise you won't hear the last part. Find a tutorial you didn't know existed and then drop the name of that tutorial in the chat. The next team of MCs will pick the winning response after the final talk before the break, and you can win a certification voucher.
Nice. I can definitely recommend the Terraform Associate exam. I was part of working on that one, and it's a great exam. I also did the Terraform Associate 003, so the one before, and that was definitely a worthwhile exam to prove that you know what you know.
Thank you, because I worked on that one. It's beautiful. Jokes aside, those exams are worth taking. They help you validate your skills. If you follow our newsletter, the HashiBits newsletter, we'll let you know when our next exam prep certification webinars are happening. I think we've got one happening in April or May, something like that. Just follow us and you'll hear about them. It's a great chance to, one, get the lowdown on what to expect from the certificates, from the certification exam, how to prep for it, how not to prep for it. Basically, like, how do I get through it without wasting my time and making sure I learn something? We're not going to give you brain dumps because that's not what this is about. We're just going to teach you what to learn and how to learn it.
Definitely. You could say you'd be learning what you didn't know you needed to know.
Exactly. It's going to be fun.
Just like in a casual segue to our next speaker, Celestina is talking to us about using Nomad when you don't know you need it.
I already love it. Celestina, over to you.
I am audible. Thank you for having me. It's now looking like this is my third time speaking at HashiTalks, and I'm super excited to be here. So we're gonna do a little something about Nomad and why people think like Kubernetes is the standard. So during this talk, do not think this is like a bash for Kubernetes. I just feel like everything has place in the industry. So a little introduction. I am Celestina. I am a cloud engineer. Oh, I forgot to add. And I'm also the co-organizer for HashiCorp user group, Ibadan. So if you're from Nigeria, from Ibadan, please join our user group. We do fantastic stuff there. I think anyone there can bear us witness. So for today and what we would cover, right? We would cover up looking at the problem and why we need orchestration in the first place. And then we'll do a little introduction for Nomad. We'll do a quick comparison with Nomad and Kubernetes. Then we're gonna do the fun part of doing a little demo, then see how Nomad fits into the HashiCorp tools, and then that's the stack and what you can use moving forward. So before orchestration, like before now, we deploy application by SSHing into servers, copying files, manually restarting services, crossing your fingers and praying that everything goes well, and hoping that no one calls you by 2 a.m. that something is wrong, right? And scaling means you have to create a new server, do the same thing over and over again. So anyone in the team that knows this would know that, okay, this is not the best way to work. And it now brings in the phrase of, this works on my machine. I think we're all familiar with that, right? So you want to make sure that this is what you have, and this is what you deploy everywhere with the same infrastructure. That's where Nomad comes in. So now, okay. So now it's, when you look at the orchestration and what team needs, it's not a complicated thing. You just need to deploy something consistently across platform. It's as simple as that. You don't need, some teams do not need the overall complexity that comes with setting up multiple components, maybe a backend somewhere, and those extra stuff you have to set up for a service to be usable for everybody. And you just need something that would scale easily when traffic spikes. You need something that could scale down. You need something that could recover easily, And some teams do not just need containers. they need services or resources or platform that they can deploy their existing applications before now. Because before container orchestration came to be, we used to use server, and some teams are not just ready for that, right? Nomad gives the option to do that. Now, merely saying all this thing, you would think, oh yeah, Kubernetes solves it. But naturally, when people hear orchestration, they just think Kubernetes. But do you really need that? Is it everyone that needs that kind of complexity to get their work done? Right? Yeah, you want to say it is cloud natives and whatnot, right? But you don't necessarily need that. So now the complexity is like, the initial setup. The initial setup, excuse me, the initial setup, the learning curve, it takes weeks for some team to know what they're even doing, unlike Nomad, where you just have to set it up as simple as you set up a binary, you set it up on your machine, and then it is up and going, right? So like I said, this is not like a bash or say Kubernetes is not good, but I just feel like sometimes you just don't need that much over engineering for something you can do with Nomad, right? And this is not also to say that Nomad cannot be used in large scale organizations. Like at the end of this talk, I would show companies that we know, right, that uses Nomad in their prod environment. Now, and there comes in Nomad. Nomad is simple, it's a flexible scheduler. It's something you can just spin up on your own. It is easy to deploy and manage. And you can do this on-prem, on cloud. When you say the word simple and flexible, it just means that it is something that can work easily and not something you have to set up with multiple resources here and there, right? So the differences between what we currently have, which is Nomad, and the industrial standard in quotes, is that for me, I would say, unlike the other one, this just works not just with Docker or containers that we use. You can use it up for maybe Java application, legacy application, like I mentioned, right? It's not just a container that every time you have to deploy an image. You can also set up little jobs that can do legacy applications for you and standalone jobs. So not just your Docker container. So let me move to the next slide. Okay, yes. So this is the easy to use, easy to install, not just container, fewer moving parts, works everywhere. You can scale from 1 to 10,000 plus nodes as you need. So the installation is single binary. So you can as well just install it on your laptop. If you're using Mac, you could just use a brew. If you're using Windows, you could just use, is it choke? They call it a bit choke. I'm not sure of the exact word right now. A bit choco. Yeah, I think it's something like choco, right? So you can use that to install it on your resources. Very minimal, not too much complexity. It works across the workloads are a lot more than you would have on your natural Kubernetes cluster. And although, yes, everything needs a kind of learning because you just do not know them, but it is the time invested in learning this that now determines which you feel is best. One, you spend weeks, months studying it, and you still do not know enough, right? Why the other one, which is Nomad, you just spend days, 2 days, 3 days, at least you understand the basics, right? So it is okay for any type of team, be it a one-man team, you're just a startup starting up your company, be it an organization that have like more than 1,000 engineers, mixed workload, simple team new to orchestration, and a team that does not know how to use this before, but they are gradually trying to move from the traditional deployment method, which is the SSHing into server, the restarting, then to using a sort of orchestration tool. So that gives us that. Then the Nomad architecture, it is a simple thing that comes in a shell. You have the control plane, the data plane, and then the communication. So this is just the communication part is the IPs that it uses to communicate. So in this now, we have like a leader. The leader is going to be like the server that schedules or that sends information to the client. The client, so let us call this master and slave relationship. So the master is going to be the server, while the slaves are going to be the client. So the client would be using the node to provision the resources, the workload, and be reporting their, sorry, I think I've gone too far. Ooh, my hand just, okay, yeah. So the clients would be reporting the health of the node, and if they have like extra space to take on more tasks or more jobs, as the case may be, onto their node. So this is what I just explained earlier. Run from form of control plane, handles scheduling decision, maintain cluster states. If you want highly available kind of settings, you can have 3, 5. It doesn't mean you cannot have more than this, but it just makes it easier so that once a leader is maybe out of has issues, another one would be elected to be as a leader, so it can serve the clients and schedule jobs on them. So here is the relationship between the job and the task. Okay, so here is the relationship between the job and the task. I'm coming, I think I'm missing something. Okay, so now, yeah, so this is what I was looking for. So the job is the unit you submit to Nomad. It's what defines what's to run, the constraints. I would show you a demo of a code of what I currently have. Then the task group are like a group of little tasks that you want to run. So it makes it easy if you want your task to be in a group that they will be sharing resources. So you want them to be on the same node. You want them to share the same network. So you want them to be able to communicate on the same local host and whatnot without necessarily having to do so much networking. You just use the task group. Then the tasks are now the single process you run. So you want to run a container, you want to run a script, you want to run a binary. That is where the task will be. So in a task group, you can have one or more tasks. Then in a job, you have a group. So that's the diagram I created here. So now, and the type of job we have service, badge, system, and then sys badge. So service is the type of process where you want it to continue running. You use it for your web application or even your portfolio web that you created. You want it to keep on running. You use service because you want it to keep running, right? Batch workloads are like maybe a little process that just you want it to run to completion. It's just checking something. It is running a data processing, just picks up something, calculate what it needs to calculate, and that is all. Then why a system job is it runs on every node. So you can use this for monitoring agents, security agents. So you want it to run on every node that comes up. So it means if you set up a single job in a Nomad cluster, what would happen is, and then you have 1,000 nodes, it would spin up one for every node. So you end up having 1,000 job of that because you put the job type to system. Why the sys batch is also on every node, but unlike the batch job that just run on a single node it is attached to, this runs on every node, but just once. So you're talking about maybe you want to make a security patch, right? You just want it to just run once and then that's all. That's where you bring in this. This is rotating too fast. Okay, so that is where it rotates. Sorry. That is where it works. Then the scheduler now. Nomad creates an execution. This basically requests to figure out what to do. The scheduler now creates a plan. It looks at all the available clients and resources and decide where your workload will be. It creates the allocation, then binds the task group to a client, and then finally provisions your resources. So like I mentioned, there are multiple drivers you can use now. We have Docker, exec, Java, and then these are the list for the drive. So now this is a simple representation of what I've mentioned so far. So there's a job at the top, and then there's a group, and then there's a task. So this job is going to be holding all this. Then the type of it, ooh, what did I do? Okay, the type that we're doing is a service. So this means that for what we are building, we want it to be a type service. So we want it to be continuously running. If I change this to maybe a batch now or system, it means that to just run and stop, right? So if I change, so now the group is something, you just give it a name. So it makes it easier for you to associate it with whatever you are working with. Then the task is also, you give it a name. Now, this driver is here, right? It picks up what you want it to do. So we want to create a Docker container. That is why we are using Docker. Now, it's as simple as, so this Docker container, the only thing here that we're doing here is we're putting this image, right? This image that is created here, and then we're putting an argument which you might want to call a command for it to be written into this our image and then echo it out, and then we see that, oh, it's showing hello HashiTalks, right? So now we are going to do a demo. So give me a little bit of time. Let me just share my slides. Okay. Okay. So this is a little bit mixed. So I'll just explain briefly before I go into it. So because I'll have to be running some things while I keep talking. So here now I have I am using Ansible to set up my Nomad cluster. It doesn't mean that you can't use any other way. I just want to use Ansible for the fun of it. Some teams, or I would recommend, if you want to do this, to use Packer. Use it to create your golden image or the standard image that would have all your Nomad configuration on it, and then you use that in your Terraform and you use it to deploy your resources. But for this demo, I will just be using Ansible for that. So okay, so let me show us this one that I have as sample, because I have this also here. This client is here, playbook. So everything is here, right? But I'll just show us what it looks like here. So for the example, so what I am doing here now is I have created a simple HCL example that would use to deploy this. What it does is it checks the directory, the bind, the IP I want to advertise, everything that needs to join, the retries, the cloud I am using, if I'm using a cloud provider service, and then, Prometheus, if I wanted to have some telemetry and whatnot. So let me show you what it looks like in this place. So here, so if you are going to be working with this, because I currently, I made a mistake when I was doing this. So the repo link there is slightly different, but I would show us at the end of this. So if you want to work with this, all you need to change is going to be this HTTPs, it's going to be these IPs, right? So I am currently using 3 IPs for demo purpose, but you can use as many as you want. Just for test, you can even use 1. And how I'm currently doing this, I am not isolating a particular server that's a particular VM for just server. I am using the 3 VM, they are going to be serving as servers. They are going to be serving as clients. So any one of them can be a leader. But if you want to do it, you want to have like 3 of these just going to be servers. The rest would be like maybe like client and whatnot. So what you need to do if you get this is to change this IP. And of course, this is the private IPs of all these instances, right? And I'm also using like a public IP. Don't mind me, because I'm using Ansible to run this thing. So it just makes it easy for me. So I do not do a lot of networking stuff behind, but only my VPN IP can access this. So It's fine. So then the service, I created a service that would work with this. We wanted to be able to start up the services when it goes. Then this is also the configuration. So are the IPs that would get replaced on each server that is coming up. We want it to be Bootstrap 3. So this is interesting because if for whatever reason it's only 2 of your server that is up, you're going to be having a little bit of issue because it is expecting that 3 servers are up until it's able to pick a leader. So I think I've shown us this. Okay, so this is just Ansible stuff. So inventory, I've showed us this. I've showed us the playbook. So we're not talking about Ansible today. So this is just a basic playbook in which I used to install the configuration. So I would try to install. I'll try to get the code to install this now. Okay. Just praying I do not have the same issue. So, okay, sorry, I didn't SSH into, all right. So why this is setting it up. So before that, I would have shown us this, but why this is setting up, currently the IPs for that are not reachable. You can't, or I can't even reach it because, well, I should be the only one that would reach it due to that. So while this is installing, I will just show us what is in the demo, which is files that get installed when we set this up. Like I said, it is just as easy as this single file. This is your job, this is your type, this is the group, this is the restart if you wanted to restart multiple times so it fails. This is the task that comes with it. So these tasks are, so now this image is different from what we had. Let me remove this so we can't see this. Okay, so this is the process we want to happen. So this is just for a batch job. Like I said, this would just run simple and short, right? It's not going to do a lot thing. You would see it on the console, right? And this is for the sys job that just runs like, a sys batch, and then it just picks it up, runs on every node, and then stops. Why this traffic? I installed this because I was kind of looking for something that I would use to, explain and make it easier for us to understand. So traffic is like Nginx, but slightly different from Nginx, right? It's just to route traffic to your resources. So now this is going to run on every node, right? Because of the system that is there. Then the web app, which will be like the main focus of what we're doing, is going to be a service. So all these configurations, the network, if you have some a particular port you want it to run with, all those informations, you just put it there, it's going to pick it up, and then the service name, any other information. Then this tag is traffic tag. So then think I am kind of trying to wait for this to finish deploying. I would have tried to run it, but I decided to take the risk to run it live. So then these are just me playing with so resources. So literally it is as simple as having a single file of what you want. You don't have to install too much. From this, where is this? Keep mixing this thing up. Okay, from this now, oh yeah, it's done, right? So from this, you can see that you're not installing so much. You just install it, it picks it up, and with this single Ansible scripts that I installed now, I have been able to set up a Nomad cluster, a Nomad resource that we can use to set up our application as we want. And it shows me the leader, right? So it's my node 4. I have 3 nodes. So last 4, 5, 6, that's the server. So it showed me that this is the one that is currently running as the leader, while every other one are like the clients, right? So now let us now do, let me try to see. Let me make a little bit of change so our GitHub action can get triggered. And just put an empty space, save it. Demo. Okay, so that's that. So the next page I'll be showing now would be the GitHub repo, and it's also going to be where the other stuff would be in. So give me 1 minute. Okay. All right. So right now, let me reload this. So yeah, I was supposed to show us this, but yeah, it's even good. So now we have let me be sure you guys can see what I'm currently sharing. Okay, good. Confirmed. So right now you can see that I've been able to deploy Nomad. There's no job running on it, right? So I created my GitHub actions as to when I raise an MR, I get it merged, then it deploys the job. So that is why you're not seeing. So right now I am sharing my repository that I worked with on this. So I made a mistake. I was supposed to change this. So I'll make this public after now. So this is the repo. So I'll just create a simple merge request. So you don't want to merge it yourself in production, right? But yeah, this is a demo. So now this is the dev, right? So you can see that the dev is currently running. And what it would do is it would validate the jobs. This is just installing. This is where it would validate the jobs and see the changes you would be making here. The changes you would be making, it will check that, and then planned jobs. So when you merge, it's when it now deploys it. So you see, this was the second one because I merged really quickly, so I do not waste so much time. So it previews it and then it checks it. I'm wondering why it did not pick that up. Okay. Okay. All right. So from what we can see now, it is deploying the demo, the batch job, it is checking it is deploying the sys job, it is deploying the traffic, you're going to be seeing the differences here. So now we're back at this. So I just went back quickly. So you see that the sys is already done. So you see that it would let this load a bit. It would show. So it's still deploying. So it's still deploying from here. Once this is done, so we can confirm from there. Error, processing complete 1. So I don't know which one is that, but let me check. Processing deadline exceeded. Okay, so it was able to install this, but it took it back. So this is interesting because I worked on this before now. Okay, let me check where it might be coming from, because nothing changed from here except for, let me close this. Okay, pick it. The configurations we have is here, the dashboard, the local. Web. So this is this. So let me just rerun this, right? Could be maybe just something, because I have run this like multiple times, which is interesting, right? From yesterday, I've tested it out. It works really fine. So let's just see what is going to happen again. Okay. This is to Excel. Place 3, healthy, unhealthy. One of that is one. I really will not want to start debugging this here now, right? So one of this is good, one of this is not good. And interesting is not deploying the web app. So I'll just move forward for time's sake, right? So what was supposed to do was to deploy those 3 or 4 services that I have created. Then once it deploys it using that, and then here is just like a conclusion of that. So what I've said, if you need to now make your Nomad much more maybe robust, you may want to add Consul for it, for service discovery, for health checking, service mesh, and whatnot. So, and in the ecosystem as a whole, Nomad sits in between because it's what manages the resources that you create. So Vault can help you secure your secrets that you integrate into Nomad. Terraform can help you provision your infrastructure, while Consul would help you for service discovery. Then, like I mentioned, you want to add more security. I just did this using the IPs. There's no security because it's just a demo. It's just to show you how it works, right? You want to integrate it with Consul for service discovery. Then you also want to add some monitoring Slack. So interestingly, Nomad comes with Prometheus off the hood, so you can reach it that without necessarily doing so much. So like I mentioned, there are companies, organization that uses Nomad. It's not just something that are for small teams, right? So in as much as it is encouraged to use that, but at the same time, there are big companies that use this. So we all know of Cloudflare, right? At least even if you don't know any other one on this list, you should know Cloudflare, and they use that. So if you want to install this on your Mac, you just do like brew install, and it just installs it as simple as that. And if you want to do the whole process, you install it like that. So then there are other resources, to get started. You could just go through these links, and then, and then you could just pick up a little reading here and there, and you practice it, and you realize that you don't really need that over complexity in the work you do. So just a little key takeaway here. It is simple, it is flexible, it scales, and it integrates easily, and it might be what you need before you reach for the Kubernetes cluster. So if you have any questions, please drop them in the message box. I think that would be on YouTube somewhere on your left or right. I'm not sure now. Drop them. I would be available to check them out. And if you still want to reach out to me on LinkedIn, that is my LinkedIn account. So yeah, I mentioned that this is the talk. So you can find it. You can find the talk here, but the one I'm currently running is the one beside this HashiTalks. But this is currently live and public in case you want to pick it up and then work from there and build your own knowledge. Thank you very much. It's so nice being here. It's always interesting doing this, and I hope to see you guys some other time. Do have a lovely day. Bye.
Thank you, Celestina. That was a great talk. Really well done. Really well. I said it before. I love it when live demos go wrong, because it's a live demo and everyone's there rooting for you. And
Right.
It's happened to me so many times. I don't like it when it happens to me, but I do love watching someone troubleshoot live on air, and everyone's rooting for them. So yeah, well done.
I mean, I know with you never make any mistakes, so live demos for you don't fail.
That's not true. I can only aspire to your level of perfection, Kareem.
The trick for that is mine are not live. I just make them look live.
Yeah, well, yes, that's cheating.
Of course. I mean, you never make changes in production live. I mean, raise your hands if you like making changes in production live to show and impress your team during presentations. See, nobody's raising their hand. It's also because we disabled that feature on YouTube and LinkedIn, but that's not the point here. Here's a big thing, though. Celestina is one of our user group leaders, and without those, we wouldn't have the community that we have. So thank you so much for leading a user group. And if you're interested in becoming part of the HashiCorp community, check out hashicorp.com/community and get involved. Now, who's our next speaker, Sam?
So our final speaker for our session, Kareem and I are coming up to the end of our emceeing session. Our final speaker is Surav, and he's another HashiCorp ambassador. Shout out for the ambassadors. And he will be talking to us from chaos to compliance, mastering Terraform's tag policy compliance enforcement. So over to you, Surav.
Welcome everyone. In November 2025, AWS and HashiCorp gave us a new way to enforce tagging. And we could do this right at Terraform Plan. Over the next 25 minutes, I'll show you how to set this up, what to watch out for, and how would you want to roll this out without breaking your team's workflow. My name is Saurav, and I work at AWS as a delivery consultant, helping customers build securely and efficiently on AWS Cloud using modern DevOps tools and processes. I think we've been there, right? We all know about projects or departments where you have the finance or the compliance team asking, who owns this untagged resource that's costing us, X number of dollars every month, or incorrectly tagged resources, right? Now, if you think about this, although we have tagging documents, you have conference pages with what tags to have, what are the right values and things like that. It's the enforcement that is lagging. And if you wonder, why does tagging fail? You think that we've done it all right. We've had elaborate meetings. We have identified with different teams. We've brainstormed. We've found, okay, what are the right values? What are the right tags? We also got it approved. And even after all this, sometimes we're not compliant, right? It's not working in the right direction. Why is that so? Well, we've got different teams that do their own different things. Sometimes, as an afterthought, they say, "Oh no, you know what? I want a different tag value, and I'm going to use it." Right? Then what happens is, there's no enforcement. So there's, and hence there's no compliance. And by the time you discover, untagged resources or even incorrectly tagged resources, this is more of a retroactive cleanup. Now the answer is to shift left. And can we catch this tagging chaos before the resource even exists? If you think about this, over the last several years, organizations have moved towards using Terraform to work with provisioning infrastructure, which is good because now you have a standardized way of deploying your infrastructure across different environments accounts. Can we use this same logic and identify if we can extend it to tagging as well? Right? Because we are tagging the same resources that we are trying to provision using the same ISE tool, right? So this was November last year when AWS launched the reporting for required tags in organizations. And Terraform added the native support with tag policy compliance provider argument. And I'll show that in a bit where to add what and things like that. The idea here is quite simple, right? You define your tagging policies in the organization, AWS organization management account, right? Once you've done that, you could then say, I want this to be implemented in, these many OUs, these many AWS accounts, these Terraform workspaces. You could also go down to which HCP Terraform project to apply them to, right? And you can catch them at the plan step, right? And at the apply step, both steps. We see that in a bit. So how does this thing work? So in your organization, AWS organization, you would define your tagging policy. What tags are required? What are their default values? Right. So in this case, you could say, I want an environment tag, and these are the values I'm going to allow. You could have a cost center. You could have department. You could specify which all tags you want. You could also specify on which resources to apply them, right? And then once that's done, in your provider block, right? So now you're going into your workload account, right, where you deploy your environments. You would use Terraform for doing that. Here inside your provider block, you add another property, which is tag policy compliance. I'll show you which provider version would work, because if you are in the older version, this might not work. Now, when you run Terraform plan, the provider calls the list required tags API to fetch your policy. Where does it fetch it from? The organization. And it checks your resources against it and blocks the plan if it is missing. You also have 3 enforcement modes. One is disabled, which is status quo, which is where we are right now, right? The other one is warning, which is a step up, which it won't block the project teams, but it'll tell them that, hey, you've got these many resources that are not compliant. And the highest level is error, which is to say that I will not allow you to provision any cloud resources specified in your tag policy that do not meet the tagging requirements, right? So this is where we are right now. This is where we would want to go as step 1. This is where eventually we would want to stay. And another thing is that we have 2 enforcement layers, the plan and the apply. During plan, Terraform just checks whether the key exists or not, right? So it's not going to check whether you have the right value or things like that. It's not going to check that. That would be checked at the apply step. Right? Let's go to the next one. And this is your typical tag policy. This is how it's going to look like on your in your organization. So you would have your tag key, what values. So say, for example, you've got a project team that in the workload account that implements the environment tag, but they have the value as stage. On this resource, it'll fail. It'll say that these are the 3 values that I'm going to allow. Similarly, you could also have the project code tag. Say, for example, I do not know all the values up front, right? What if we have subsequent newer project starting? You could have a tag which is set up as with the prefix. So anything with PRJ dash, you could even start, alpha, and then so you could make it really specific. Now you see over here we've got the report required tags and enforced, same for both of them. This gets checked at plan. This gets checked at apply. And this is my demo. So let us get started. So here, if you see, I've got 3 folders, right? 01, 02, 03. 01 is where, I think I should pause. 01 is where I have the tag policy setup, is where I have the infrastructure being provisioned in the organization. The organization means this is going to the management account, right? And then the demo error mode is to show you how the compliance would fail the plan and apply, and then what changes you have to do so that that thing passes. I am also using the version as 6.22, but maybe we'll get to it a little later. But this is where the policy is. Now, this code gets applied to your management account, right? You have that specific resource. The type is tag policy, and this is the JSON for the tag. Here we are defining 3 different tags. One is environment. We specify the key and the values. The values are, I think, prod, test, and dev. I think I'm a little bit ahead. Yeah, there you go. And then you specify that. So this is for plan, and it's going to check for only the CloudWatch log at the plan step. And the other one, the enforce for, this is for the apply step. Right. Similarly in cost center, now if you see here, we don't have specific values. So any value, so cost center, it's going to accept any value. You probably do not want this. You want this to be tied to, something, so that we do not have junk values in tags. And in project code, you could again have the prefix, which says that I am going to accept any project with this value. Here also we are applying it to CloudWatch logs group. This is again, just for the demo purpose, but there's a long list of resources that you could include there. Here, this is how you attach the policy. Now in this case, I've just attached this to my AWS account. It's just a sandbox that I spun up, but you could also, just to comment, that's what it's showing. You could also implement this at the OU level. Now we are on the right folder, 01, and we are trying to run this. Looks good. Let's now bring up the AWS console and then check the, yep. So this is where your policy is gonna stay inside AWS organizations. So you have to go to policies. Before you do that, go to policies and then enable that tag policy. You'll have to enable this thing. That is a one-time thing that you would do from your management account. After that, you go into tag policies. You see this is the one that we just created, right? Required tags demo. If you scroll up a little bit, you'll see that that's the same name that we gave to that resource. So that's our tag policy. And then those are the values, the ones that we just specified. So there's the cost center, and then your environment. I think it sorts it on the alphabetically, and then your project code, the values that it will allow. Now, where is this targeting? I think the target is, as of now, the sandbox. So it's just this throwaway account, and so we have set that thing up correctly. Now let's go to the second account. The second repository. This is, and before I let me just show you what's happening here. We've got this version, right? So remember that I think maybe I should pause here for a bit. So this version over here, anything 6.22 and beyond is supported, right? So if you are trying to implement this solution, check that your provider version is newer than 620, newer or equal to 622. Let us continue. Yes, here I have set this up to error, which means that any resource using this provider, if the tag compliance is not met, it'll error out, right? Which are the resources? Here are all the resources that currently it supports. I'll show you, I'll share the link later. Now let us go back and start provisioning the resources in this folder. So if you see over here, I have commented this out. This is to show that how the compliance sync works. For now, we'll not enable this. And this is our resource, right? We also have one more resource, SSM parameter. If you remember, we had just the CloudWatch, logs group there, right? We did not have SSM parameter. So what will happen is that if I provision this code for SSM parameter, even though the tags are not attached, the right tags, will still provision. It should, right? Because we are not, the block in the compliance doesn't check for that. So here, I think I just forgot to comment out the CloudWatch log group. Should have done that, right? So now it's throwing that error that, hey, your compliance is not met. So I just commented that out. And now I will run the command once again, and you will see that the SSM parameter would be created, right? So here it's asking, basically telling that, you're missing these tags. Okay, so now that's commented out, and this part is enabled. So we will run Terraform, apply once again, and you'll see that the resource would be provisioned, right? Although we do not have the tags. That's because we are just capturing log scope. If I say yes, there you go, the resource is created, right? This is expected behavior. Now, for the next test, I will maybe I think I should go. Yeah, I think it's still okay. As of now, I'm just removing it. Do not do this. Auto approve is very dangerous. You can do this only on a sandbox environment. And here, now I've added, you see what I've done? I've added the policy to have to basically consider not only for logs but also for SM parameter, right? And now I've done an apply there, which means that the policy code has been updated, right? Let's quickly take a look. And if you go to the console and bring up, yep, SSM parameters there, which means SSM parameter is going to get tracked. Now let's cd into the folder, and when we try to provision, right? Now see, policy has been updated. Now when we try to provision, this thing should fail. And if you just say yes now, see what happens. There you go, right? So here this thing failed because I directly went into the apply step, and if I had gone to the plan step, this would have failed there as well. So this is pretty much what it's doing. Now let me go forward a little bit, or maybe here. Yeah, I think. Okay. So now I'm going to show you how to provision, basically correct the resource and then redeploy. So this is just an extension of what we did previously. So even plan is failing because we didn't meet the required criteria. Now I will disable the comment. So the default is enabled, right? So all of these resources being provisioned using that provider would have that tag. And this time, both these resources, you see the plan passed because, both the resources are getting the tags from the default provider. And this is apply, and there you go. So apply also works, and the resources are provisioned. So what just happened over here is that we were able to, let's see, maybe I should pause this and go to the next slide. So what just happened over here, there was, we saw a complete example of how using policies, compliance policies, you could first enable that in the AWS account, and then subsequently you could go to your workload accounts and test that solution out. So after you've gone through this, you'd be like, okay, this is good. I would want to implement this. How do I roll this out? So the first thing that you do is, and I don't have it in the slide, is check the provider version. Right? You would want to make sure that your provider versions are for across all your projects. It's newer than 6.22 6.22. So that's step one. We want to make sure that we are using the newer provider version. The other thing, and when I say provider, I mean the AWS Terraform provider. The second thing is check the IAM role. Usually, you would have a CI/CD mechanism that would be deploying your IAC into an AWS account. Ensure that that entity has the list required tags permission. The second step is to enable warning mode. We didn't see this in the demo, but I'll just quickly show how that thing works. You would want to, for warning, you would want to run this command, which is you set the logs to warn, and then you run the Terraform plan. That is how your warning is going to be effective. It will not stop you from provisioning resources, but it will tell you that these are your non-compliant resources. So that is going to tell you how to get started, right? And this is where you would want to iterate and fix those compliance. For week 2, this is for phase 2, this is your remediation. The easiest and the best way to get this done is default tags. Use default tags. You put it once in your provider. You don't have to find all 50, 60 resources that are getting provisioned using that provider. In that project, find that provider block, add the default tags. That's the quickest way of fixing this. Then in phase 3, you switch to so from earlier you had it at warning, switch it to error now. And if you are using HCP Terraform, this is how you manage the environment variable. You could do it at the workspace at the project level, so that all workspaces in that project have the compliance mode set to error. A few quick wins. How would you? Okay, Saurabh, this is good. Can you tell me how do I get started with this really fast? Default tags. That is how you quickly get this done. Now, of course, your first one is, like I said, AWS provider version 622. Add that specific permission to your IAM policy, and then default tags. So those would be done at the IAM policy would be at the organization level, right? Before that, you would also want to enable the tags that we saw in that AWS organization. Then after your default tags are done, identify one tag. Okay, there's no point going after all the tags together. Identify one tag, say for example the environment tag. Get that working across all your resources, and then iteratively add more. And the third is use warning mode during transition. So start with warning, give your project teams the headway to start working on implementing, so that you do not block their critical deployments while we are still figuring this thing out. A few things that I would want you to watch out for is ensure that the IAM role, and like I have said, you need this permission, otherwise this thing it'll just skip it, right? So if you see it skipping IAM role, check whether this permission policy is there. Second thing is enable the compliance to set to warning for the plan. For that, you'll have to update the TF log to warn, and then set the Terraform plan. This will work. You can go to error, but let's be gradual in this. And once you have assessed and remediated, flip the switch to error. You could do this at the provider, or you could do this through the environment. This is how you set it at the environment, but you could also do it at the provider, like we saw. Now, to wrap this up, if we have to say, okay, what did we learn today, right? So AWS tags policy and Terraform implementation, right? Now what we are able to do is we are able to ensure these tagging compliances are set right when we are provisioning resources, right? We have 3 modes. This is status quo. This is where everybody is right now. But eventually, subsequently you would want to go to warning, but eventually to error mode, right? There are 2 layers. We have the plan and apply, which is, again, stage. You would want the project teams to be aware of the resources that are not compliant, and default tags. This is your best bet. Apply this, you're good. I told you about the blog and the documentation. So this is where you could, you could take a photograph of these QR codes. The first one, this is for the blog. AWS has, AWS employees, colleagues have done a fantastic job of writing a pretty detailed blog here. I would highly recommend that you read this. And then you could go through the AWS Terraform provider documentation. This will walk you through the implementation. Really helpful guide. And thirdly, if you have any questions, feel free to reach out. I am quite responsive on LinkedIn, so I will, if you have any questions, I'll be very happy to help you. And that's about it. You could also use the comment section here. I'll stick around for a bit if you have any questions. But whatever works. Back to the hosts.
Tiny.
Thank you, Saurabh.
Thank you very much.
That was absolutely lovely. Tagging is hard, and doing tagging things well. Sorry, my brain was formulating that sentence. Tagging things well is incredibly beneficial downstream, because it just gives you so much more insight into who's doing what, how they're doing it, and how it is being used. Default tags obviously is a very solid start. Saurabh is still taking questions in the chat. But meanwhile, Sam, to echo Saurabh's question, what did we learn today in the first part of HashiTalks 2026 in the past 4 hours?
Wow, 4 hours. Has it been that? It doesn't feel like it's been that long, actually.
Right.
Definitely some really, really good tips. There were lots of, I think, automation is always, anything automation is always very high on my like list. I think it was good to hear some Nomad talks as well. I mean, I have not spent that much time with Nomad, but getting used to running your workloads with Nomad. Obviously, big fan of Minecraft stuff for the kids, so that was also great. I mean, there's so much stuff you could talk for ages on it. I
guess we'll just have to watch the live stream recordings once they hit YouTube, so we can actually enjoy them even more.
Exactly.
With that, I think we're going to hop into a quick 10-minute break. Remember our giveaway for the certificates. Head on over to developer.hashicorp.com, find your favorite tutorial that you think nobody else might know about, and post the name of it in the comments. And Sam, once again, congrats on kicking off your first HashiTalks, and excellent choice in attire today.
I was going to say, I mean, we made the right decision, obviously.
Clearly.
Yeah, this has been fun. Thanks, everyone, for listening. And you'll be joined. Who's joining you after? Is it Richard and Peter?
Yes.
Perfect.
So stay tuned. You've got 10 minutes. Refresh your drinks, stretch your legs, unload your brain, and come back refreshed. We'll see you soon.
Good morning.
Hello.
Good
morning.
afternoon,
Yeah,
everyone.
welcome to the second block of the HashiTalks 24-hour live stream. Peter and I are gonna be your MCs for the next 4 hours. So if you can tolerate looking at us for about 5 minutes every 30 minutes, everything will be great. My name's Richard Boyd. I'm a developer advocate here at HashiCorp IBM company. Peter, would you like to introduce yourself?
Sure. Peter Nightingale. I'm here with IBM. I've worked for IBM for a number of years in the past, sort of 4 or 5 years. I've worked mostly with user groups and the advocacy team, and just wonderful to, hear about Hashi user groups or hugs, and then hearing about this, the HashiTalks 24-hour marathon. I'm proud to be a part of this. So great to join. I'm coming live from Ottawa, Canada, where the temperature has just gone above freezing today. So that's a good day. It's a banner day here in Ottawa. So happy to be a part of this event. So ready to kick this off.
Great.
Anything else?
Yeah, I forgot to mention I'm coming from broadcasting from Boston, Massachusetts. It's a warm day today. It's supposed to get up into the 40s Fahrenheit, not Celsius. That would be wild for February. And everyone who's watching kind of on the live stream, just drop in the chat like where you're watching from. I'm curious to see where everybody's dialing in from. And then that's all I had, Peter.
Okay. Well, I get to introduce the first person here for this next session, or for our block here. So it's an honor to do that. But just to remind everybody, if you have any questions or comments, we'd love to hear from you, interact with you, in the chat. So as you do, please keep in mind our code of conduct in this virtual space, right? And basically, be welcoming, inclusive, friendly, patient. Be considerate, be respectful, be professional, right? You can always review our code of conduct at hashicorp.com/community guidelines, and we should be hopefully pasting that shortly. So, well, let's get things started. So our first speaker, Mahendran, is about to give us his talk, HashiCorp Ambassador, which is great. And the first session I get to introduce is Terraform Beyond CRUD, bringing day 2 operations into code. Take it away.
You muted, Mahendran. Can I get you to start over again? You left your mic on mute. I'm sorry.
Can you hear me? Sorry. Welcome to my session, HashiTalks 2026. So I am Mahendran Selvakumar. I work Cloud and DevSecOps Engineer at Tata Consultancy Services. And I'm a HashiCorp Ambassador and also a West Midland HashiCorp User Group Leader and also AWS Community Builder and also that AWS Ambassador. In the today's session, we will see about the Terraform Beyond CRUD. So how we can bring the data operations into code. So usually Terraform works with the day 0 activities, correct? Like that creating, reading, and updating and deletion. So in this today's session, so I will show about how we can use that to measure things in the code. So like the Terraform search and Terraform actions. So in the things, what are the why these features are exist? Because we have created that infrastructure that outside that IAC, like that we have created the environment manually and we have created the legacy environment. We have used other tools, correct? So but the thing is, so while managing all the things will be risky and we can't able to onboard all the things into the code, correct? So the thing is Terraform search comes into the picture, and the thing is that once Terraform search comes into the picture, so we can able to manage all the environment in that code. And after that, so we are using some other tools like Ansible and other tools to invoke that runbooks and validate that configuration and run the maintenance, and all the things will be in the across the environment, okay? Then all the things will be configured in the data operations, correct? In the data operations also we will be doing in that separate tools and separate configuration, separate runbook. So and both the things will be comes under the Terraform. So that's what we all the workflows and governance and RE logs will be configured in the Terraform search and Terraform access. So what is Terraform search? So Terraform search, we can able to declare our cloud resources in cloud resources and cloud accounts in that query format. Using that query formats, we can able to get all the details of the resources from that existing infrastructure, which is not managed by the Terraform, and which is not managed by that Terraform, and which is not included in the configuration scope. So we can use the tf.query.hcl file. So using that file, we can able to run the command Terraform query. Using the Terraform query, it will list what are the resources will be matching on what are the resources not managed in the Terraform. So based on that list blocks, we can able to get all the details. Once we got all the details, we can able to bring all the resources into the Terraform management. So it's in that things, so all the resources will be under the control of Terraform. Where Terraform search helps, the thing is, so because we have that existing environments like the brownfield infrastructure. So in the brownfield infrastructure, we have created that infrastructure we have manually, but the thing is, it's not managed by the Terraform, correct? So if we comes with that Terraform, so we can able to manage that, and then we can able to find out that unmanaged resources like the ClickUps resources, where we created manually, and we can't able to control, and we can't able to manage those things. If those things will be able to manage using the Terraform search, because and we can able to input multiple resources, the bulk resources. For example, so if you need to import one or two resources, we can able to do it quickly, and we can able to do it. For example, if we have the n number of resources we need to onboard, so it should be risky, correct? It should be slower the process. So in that case, we can able to use that bulk discovery using the Terraform search commands and the Terraform search query commands, and also we can able to do that migration and standardizations across that environment. So like that dev to prod and prod to pre-prod to prod, and those things we can able to do with the Terraform search. How the Terraform search is working? So in that first we need to define the queries. Once we define the queries with that tf-query.hcl formats, once we define the queries with that one, we need to run the queries. Once we run the queries, what it will be, it will provide the result of what are the resources matched to the Terraform. So what are the resources we can able to import. So once we get the results, we can able to review the result, because it will provide all the details, correct? For example, so we are creating EC2 instance, and it will using the Terraform query, we got the results of what EC2 instance, but it has the details of IPv6 as well, because we use only in that IPv4. In this case, what we can able to do, we can review that, we can able to run that Terraform format command, and we can remove unwanted codes in that one. After that, so once reviewed, so we can able to generate the codes. Once the code generated, what we can able to apply the configuration. So once we like the using the Terraform apply command, if you use the Terraform apply command, you can able to get all the resources in that imported to the Terraform manager. How the Terraform search output will be. So see, usually the Terraform search output will be the two blocks. One is that import block, another one is that resource block. In that import block, so it will match that. So what resource will be going to import, and what is that resources, and what are the providers, so whether it should be AWS or the Azure. So it will provide which region, which account ID, and all the details will be in the import block. And the resource block, we can get all the details of the resources, like that which AMI, which EC2 instance, what is the type of EC2 instance, what are the IPv4, what is the IP address, and all the things will be get in the resource block. Using that both the blocks, we can able to import the resources. So in this first demo, I will show how we can use the Terraform search in HashiCorp Terraform. So using the HashiCorp Terraform, we can able to import the resources. So already I have created that workspaces in the HashiCorp Terraform. So my workspace configured with that VCS mode. So here I have integrated with my GitHub repo. So I have created the GitHub repo for this demo. So in the demo, so the particular repository was configured, and the repository have the two type of files. So this is my repository. In this repository, I have the two files. One is that main.tf. In that main.tf, I have only the provider detail, and also that what are the providers need. So, and after that, I have another file. In that file, I have that such.tf query.hcl. So as I said earlier, we need to have that tf query.hcl file, correct, in that format. So here I have mentioned, so what are the things we need to list out? So first I try to list out that AWS EC2 instance. In that AWS EC2 instance, so it will filter out that name tags as well. So we can if we need, we can filter out as well. So because whether it should be particular tag. So for example, I have the dev environment and pre-prod environment, so I need to import only the pre-prod environments. I can able to add that tags like the pre-prod, and I can able to do that one. And based on that one, so here I have mentioned in that AWS EC2 instance, and with that HashiTalks demo EC2 instance, with based on that I have filtered out that which are the instance have that HashiTalks 2006 demo. So based on that instance will be added. And the same thing I have that S3 bucket. So the S3 bucket also listed. Here I have mentioned that region as the EU West 1, correct? So the EC2 instance which are available in that EU West 1, it will be filtered out based on the tag. And also some of the resources available in that S3 bucket. So EU West 2, the London region. So the resource also will be listed out. So see, here I have that AWS portal. In that AWS portal, I have created the 2 EC2 instances. See, and one more thing is that I have another VM like that dev VM. So I have created 3 VMs manually in that in that AWS Consul. So but I have listed out only 2 filters, correct? So because which are the instance started with that HashiTalks 2026 demo, so it will filter out. So what I'm going to do, so because in the HashiCorp Terraform, so we have the options called search and import. So once you created all the files, you can able to run that query in that search and import. So if you go to the search and import, you can able to see the options new query. So when you run that new query, it will try to find out, so what are the resources it's not managed. So when we able to see that the particular resource is not managed, so we can able to run that query, and we can able to manage that one. So it will take on a few seconds. So once it's identify that resources, we can able to get it. See, based on that query, it will listed out that resources like that S3 bucket, and that's also the EC2 instance. So if you see here, so it will list out so only the resources tagged with that HashiTalks 2026 demo. So on that instance 1 and instance 2, but we have the 3 instances, correct? But the particular dev VM instance also, but that particular dev VM instance is not available because it's not matched with the filters. So and also it will filter out that S3 bucket also, and using that query, we can able to get that resources, correct? What are the resources available? And after that, what we can able to do, we can able to create the starter configuration. Using in the starter configuration have the import and resource block. So if I in that case, I will choose only that S3 bucket. I will choose the generate starter. See, if you see here, it will have the 2 blocks. See, for example, so import and resource and import and resource. See, if you how we can import the resources. If you click here, see, I will copy that code, and I will copy the code and create that file called s3.tf. So in that s3.tf, what I am going to do, so I'm going to apply that particular s3.tf files in that. See here, if you see here, the particular 2 S3 buckets will be imported. So once saved, so what I'm going to run, so I'm going to run so I will just push that particular code into my GitHub repository. Once I push to that code into that my GitHub repository, so I can able to see that. See, if you see refresh that page, you can able to see that s3.tf file also available in my GitHub repository. So in the GitHub repository, it has that import block and the resource blocks. Now what I'm going to do, now I'm going to run that new run in that HashiCorp Terraform. So if you run that new run, it will try to plan, and once plan executed, so we can able to get that Terraform apply. So based on the Terraform apply, we can able to get that detail. See, the plan is running. So once plan runs, so we can able to get the details. It will take few seconds. So once plan completed, so we will get that. So what are the resources going to be? See, if you see here, so the one 2 resources will be added. So see, 2 resources will be changing. See, if you see here, see that S3 bucket HashiTalks demo S30 and also the S3 bucket, because we have added in that only that S3 related, because we haven't chosen that EC2 instances, correct? So based on that, the particular plan will be loading. So once the plan will be completed and Sentinel policies will be completed, we can able to apply that changes. So once applied, we can able to import the resources to the Terraform. So then a particular S3 bucket will be managed via the Terraform. It will take a few seconds. So once we completed, so we'll go through that. So what are the resources will be, so because the particular two resources will be getting imported to that so once applied, so what we can able to do, we can able to run that search and import again, and we can able to run that query again. So once run that query again, so what we can able to do, we can able to apply the we can able to get the resources. The particular S3 bucket will be managed via the Terraform. So it will take some time. So the next thing is that the next thing is that Terraform action. So what is Terraform action? So as I said earlier, so using that Terraform, so we can able to manage only that day zero activities, correct? Like that create, read, and update and delete, correct? Using that Terraform actions, what we can able to do, we can extend that day two operation as well. In the day two operation, we can able to run that playbook, and we can able to validate that server configuration, and we can able to check all the things with that. And the Terraform actions only works so provider defined operation. So because in that case, so if, for example, if we are using that AWS, we are using AWS or Azure, so the particular provider needs to provide that operation. So based on that one, so some of the AWS resources have the provider's details, and it will be run along with the Terraform run. So when you run the Terraform, so it won't change that Terraform state file, because so if the actions will be running, so it won't change the Terraform actions. And where it will be running, so it will be running in that after provisioning. So after provisioning, we can able to validate where the particular configuration, we can able to trigger that workflows and all the things we can able. And using the Terraform actions, what we can able to, we can standardize the task as well, because even in using the Terraform search, we can manage all the resources, correct? With along with the Terraform action, we can standardize that day two activities as well. So like that, manage the executions as well. So how to define the Terraform action? So in the Terraform actions, we can define with the actions block. In the actions block, we can have the AWS Lambda. So here I have chosen it that AWS Lambda. So in the AWS Lambda invoke, and we can choose that config function, and in the config function, and the config block, we can able to provide that provide a specific input. So because what are the specific resources, and what are based on the resources, we need to provide that input. And how to invoke the action? So because basically we can invoke the actions with the two methods. One is that manually, and another one is automatically. Because in that manually, so using that invoke command, we can able to run that invoke actions. So along with the Terraform plan or apply, we can able to invoke. So because while invoke the particular actions, we can able to run only one actions in that one. So we will see in that demo. So if you see in that first image, so it will be, so the particular Terraform apply will be shows in that invoke actions only for the Lambda functions. So if you see in that in the automatic instance, so in the automatic, it will be run with the lifecycle trigger. So in that lifecycle trigger, it's automatically create an create or update after that one. So because once provision, it will be create or update after that one. So because in that life cycles, we can able to invoke that things, and it will be run while running that Terraform plan or apply. So what are the AWS providers supported in the Terraform actions nowadays? So because some of the AWS providers supported for the Terraform actions, see these actions we can able to do with the Terraform actions, like the Lambda invocations and EC2 stop instance and the DynamoDB create backup, and also the SNS publish, and also that CloudFront create invalidation, and also code build start build, and also that SF and I mean step function execution, and so that put events, and so that send email. So these things we can able to do with the Terraform actions. So the next demo I will show with that, so how we can run the Terraform actions with the Terraform. So before that I will show that code. See, before that I will show, so because our Terraform plan also completed. If you see here, I just click apply for the Terraform search activity. So if you once applied, so what it will be running, it will be running that sorry for that things, because it takes some time. So once it's applied, what we can able to, we can able to run that query again, and we can able to, so once it's finished, we can able to, we will see that Terraform actions demo. See, if you see here, so the only two resources got updated. See, so S3 bucket 0 and also the S3 bucket 1, the both HashiTalks demo S3 buckets will be updated in that update. So if you see, once it's finished, so now the things is updated. So now if I am going to run that new query again, so it will run the query again. It will analyze the resources. So what are the resources managed, what are the resources not managed using that Terraform search. So it will take a few seconds. See, if you see here, so the particular S3 buckets we applied got managed. So now both the S3 bucket managed by the Terraform, but as EC2 instance not managed by the Terraform, because so we imported only in that S3 bucket using that Terraform search query file. So and we run that search and import. So this is a demo for that Terraform search. So now we have another repo. So now we are going to do the Terraform actions demo. So in the actions demo, I have the repository called Terraform actions demo. So here I have created that action.tf, main.tf, and output.tf, and variable.tf, and versions.tf. So now what I'm going to do, so I will change it to the repository. See, see, if you see here, so this is the repository. So in that repository, I have created that Lambda functions, and also that it has, I have defined 3 actions in that demo. So because one is that, so it creates that on-demand DynamoDB backup. So once it's created, so it will trigger that particular notification, so the SNS notification, and also it will write that. So another actions I have mentioned is that Lambda functions. In the Lambda function invocation, it will write the logs to the CloudWatch. Okay, so and also, so I have mentioned that particular DynamoDB creation. So these are the things will be created for creating the Lambda function, creating the SNS topic, and creating that IAM role policy. And other thing is that, so I have mentioned that variable. So here what I have used that SSM parameter store. In the SSM parameter store, we need to update that code. Based on that code, it will be update that trigger. So these are the things I have used. That so only the main thing is that, so our Terraform version should be the provided version should be the more than 6, and also the required version should be more than 1.14. So, and one more thing I have mentioned in that action. So I have mentioned that manual action as well, because as I said earlier, we can able to run both the things correct. So the whether automatic or manual. So the both the things I can able to do. See, what I'm going to do, I will going to run the Terraform apply. So while apply the Terraform, it will read the thing. See here you can able to see that. So 6 resources will be ordered, and 3 actions will be invoked. So I'm just giving yes. So once I'm giving this, the particular resources will be created, and also that what are the actions I have mentioned in that life cycle. So it's automatically invoking. Because why the manual things is not invoking, because I have mentioned as that manual one, it is not updated with the life cycle. See now the Lambda functions will be created, and once the Lambda function created, it will be creating that SNS topic, and also it will be created that CloudWatch log group. So all the things will be created. See, if you see here, you can able to see that. So because the 6 resources will be added and the 3 actions will be invoked. So if you see here, the resource will be invoked by the triggered by the parameter. So because why it shows like that, because see in that parameter soul, I have given that lifecycle as that actions. So in the action, so it will be fetch all the resources like the DynamoDB creation, and also that SNS publish, and also the Lambda invocation. So now what I'm going to do, so because now I'm going to change that London region, and we can validate that resource creations and the invocation. So see, if you go to the DynamoDB, so the particular DynamoDB table was created, and also you can able to see that, so but the backup will be created. See, if you see here, so the HashiTalks TF actions demo v1, so the particular backup will be created, and the same thing we can able to check in that CloudWatch. So if you go to that CloudWatch, you can able to see that particular metrics for SNS topics, and also that, see here you can able to see that SNS. In that SNS topic, you can able to see that topic metric as well. Why we are not getting that message published? Because the SNS topic publish will be triggered with that manually, correct? So we'll trigger that, and also we can able to see that log management. So if you see the log management, the particular log group will be invoked by the Lambda. See, if you see here, the I have written in that code. See, this log entry is created via the Terraform action for HashiTalks 2006 demo for the Lambda invocation. These are the things will be configured with that automatic invocation. So see, if you see here, I have derived all the things will be in that one. So now what I'm going to do, so because now I'm going to upgrade the version of the release version. See, as I said earlier, so because I have used the Terraform, I mean SSM parameter, now I'm going to update that SSM parameter version, so the release version. Once I update the release version, what it will be do, so it will update the version, and again that Lambda actions will be invocating, but it is not updated the state file, because the Lambda actions will be invoked, but it's not updating the state file. See, if you change that, if you check again, so that all the things will be created. For example, if you go to the DynamoDB, so you can able to see that, so other backups will be initiated. See, if you see here, the one more backup, so the particular version 2 will be initiated. So the things will be applied with the Terraform plan apply. So now what I'm going to do with that other one, so we can able to run the manual one. So because as I said earlier, we can able to run that manual things with that invoke function, correct? So I have the code. See, because the manual things will be invoked via the while apply and the plan. So here I have mentioned that SNS publish notify as the manual. So if I run that one, so it will be run only for the action. See, you can able to see that one, the particular actions will be running. If you see, click. So see, if you see the particular one actions will be invoked, because the particular actions invoked by the manually. So if you go to that CloudWatch, you can able to see that metrics. So in that metrics, you can able to see that, so the particular invoked SNS publish. See, if you see here, so the in the SNS, in the topic metric, if you click that on hour, so if you choose that particular tower, see, if you see here, so the number of messages published, so the message will be published. So how the message will be published, the message published will the manual invocation. Where we can able to achieve these things will that manual things as well. So these are the things will be in that one. So we can use the Terraform search and Terraform actions using that both futures. We can able to achieve that all the resources will be in that Terraform management in that code, and also that all the execution will be in the Terraform management code. So I have shared that particular Terraform repository. So both the repositories available in my GitHub repository. So you can able, if you want to try with that in your end, so you can clone that particular repository. You can able to try, so how the Terraform actions will be working, and how the Terraform search will be working. So you can able to do all the things with the things. So thank you all. So thank you for the opportunity for HashiTalks, and thank you Jasmine and other team for hosting the event. And if you want to connect connected. If you have any queries, you can reach me out the LinkedIn. So you can reach me anytime with that LinkedIn, and I'm happy to hear. So if you have any questions, so just let me know.
Perfect. Thank you, Mahendran, for that. I always remember just how, how much pressure there is to present and do a live demo, and that was fantastic. That was perfect. Richard, I'll hand things over to you.
Thanks, Mahendran. I am going to move forward a little bit quicker. We're slightly behind schedule. I think we can make up for it. I'm going to introduce Cedric with the next session on Brainiac, AI-powered infrastructure as code from natural language to production-ready Terraform. Once again, thank you, Mahendran, and let's see what Cedric has for us.
Hello, everyone. Can you hear me? It's okay. Yeah. So thank you for joining this HashiTalks session. Today, I would like to talk about how AI can change the way we build and deploy infrastructure. For this purpose, I have created a new framework. It is called Brainiac, and it is powered by AI agents. My name is Cedric. I'm a solution architect and HashiCorp ambassador. So first of all, what is Brainiac? I may disappoint comic book fans in this session, because in our case, Brainiac is not Superman's famous enemy. In fact, Brainiac is a contraction of brain and IAC to designate a kind of intelligent infrastructure as code solution. Brainiac is a framework for spec-driven infrastructure. It is directly inspired by GitHub SpecKit, a revolutionary toolkit for AI-based software development workflows, commonly known as spec-driven development. So the concept behind Brainiac is simple: specify what you want and let AI agents understand it and execute it automatically. So to continue, let me be more precise about what we mean by spec-driven infrastructure. It's a new approach I have developed where specifications become the foundation of the entire infrastructure lifecycle process. Compared to the traditional infrastructure provisioning approach, where code is often written first, documentation comes later, and specification become quickly outdated or ignored. With spec-driven infrastructure, detailed specifications are created first, then code is generated to match them exactly. There are four core principles, main principles. 1, specification first. Define the complete contract before writing any code. 2, machine readable. Specifications are structured so both humans and AI can understand them. 3, there is an inversion, sorry. Single source of truth. The spec governs everything, code, test, and documentation. And the last 4, continuous validation. Code is constantly validated against the specification. So the specification becomes an executable intent. That's the transformation we are talking about. So it is a fundamental, I would say, paradigm shift from code first to spec first. Instead of writing code, you define a specification contract for your infrastructure before any code exists. This gives you, for example, infrastructure intents as your single source of truth, multi-cloud consistency, auto-generated infrastructure as code and documentation, and policy compliance from day one. So let's deep dive in the workflow, in the AI-powered workflow behind Brainiac, supported by Brainiac. So it is the main workflow, but the workflow in reality can vary if your infrastructure project is different. But step 1 is constitution. In this phase, you establish the foundational principles, constraints, and architectural guidelines that will govern the entire infrastructure project. Step 2, specify. The engineer defines the what and the why, not the how, the what and the why, in a high-level structured specification. The AI help flesh this out into in detail, machine-readable plain. This is the collaboration paint. Plain. Step 3. The AI agent take the spec and create a comprehensive strategic plane. Identify the dependencies, risk, and resource requirement for the entire infrastructure project. This is where the agent shows its intelligence. Step 4, task. It is simple. The AI agent breaks down the plane into specific actionable tasks with clear deliverables, priorities, and acceptance criteria. Each task is independently executable. So it is a task, it is an important step, it is an important phase, because the tasks are, I would say, the result, the transformation, the translation of the specification into something executable by AI agents. And the final step is implement. Here, the AI agent executes the task, writing, refactoring, and structuring the code to perfectly match the specification using the constitutional framework. So notice here that the human-AI collaboration is real. Humans provide intent, strategy, and constraints. AI provide execution, consistency, and scale. So let's continue with a demonstration to explain what we can do with Brainiac. For this purpose, I have recorded a video from a previous demo I made internally with HashiCorp folk. So I'm very grateful for their interest into Brainiac. But before launching the video, just a few words about how to set up Brainiac. So, of course, you have to install it on your laptop, for example. inside the project directory, you have just to type Brainiac init -- here. From that directory, Brainiac will install all the necessary file to set up your project. In this screen, you can see that you can choose to work with Brainiac your GenAI stack solution. So Brainiac support Copilot, Claude Gemini, and other GenAI solution. And after that, Brainiac will download from the internet all the file to set up the project. So between this file, we have some agent definition, we have some template that will be used by the agent to work, and so on. And if we look deeper in the project structure, it is, for example, on this slide, a project that will be set up with Brainiac and GitHub Copilot. We have in the .github directory some agent definitions. So there is not only one agent, but multiple agents that will support the AI-powered workflow for infrastructure provisioning. So we can recognize some agents that support a specific step in the workflow. For example, we can see brainiac.constitution.agent.md file. This file is the agent definition for the constitution step. Same example on the screen, the brainiac.specify.agent.md file define the agent that will support the specified step of our workflow. There is also some PowerShell script that will be used by the agents to work. Note that Brainiac support also Linux shell script, and there is also template files. These templates are used by agent to ensure that the output, the deliverables are well formatted with the right content as expected by the engineer. Okay, now I will launch the video. So just okay. So as I said previously, the first step is to call Brainiac constitution agent to define the constraints, the governance rule for the project infrastructure. Here, I precise that I want to deploy on Azure only and infrastructure because, for example, I'm GDPR, I must be GDPR compliance. And I precise also that I will be using PaaS services on priority. Okay, so I call the agent from the Copilot chat with a / command and pass the constraint in as arguments. So the agent will use the constitution.md file models that we can see in the screen. So it is a template and the agent will modify, is going to modify this model to format the governance rule for my project. If we are okay with the modification, we keep. Okay, so it is very important after each phase, each step of the workflow to review the output, the deliverables generated by the agent to be sure everything is okay. It is really, I insist, a collaboration between human and AI. So in the output, in the constitution file, we can see the core principle, the security and compliance principle, and so on, the architectural guidelines. So next, step 2, we call the specify agent, and we want, for example, deploy a cloud native web application with containerized services, managed database, load balancer, auto-scaling, etc., etc. So once again, the right agent will be called to do this work, and the agent will use, for example, the spec template to provide a specification as an output of the step. So as you can see here, the template mentioned that requirement will be mandatory, acceptance criteria will be mandatory. So the agent will use this template to generate a new deliverable in the spec.imd file. So now we can see the result. If I am okay with the file generated, I can keep. So notice that the spec file is generated inside a new directory that is called name spec in the directory. And the agent create also a new Git branch to store, to implement the specification. So this is the result, but as you may see, some open questions need clarification. So there is also optional step. So for example, here we can see the clarify agent that can be called. It's not mandatory. That can be called to provide additional clarification if the spec is not precise. So need clarifications is each time we need some clarification, a tag is added to the specification. This tag is needs clarification. So here I can say, for example, to be very, very flexible, I indicate to the agent to suggest some clarification. In reality, we have to take each point, analyze it, and provide some clarification. That's okay. Okay, keep. And after clarification, we are going to jump to pass to the next step, that is plain. So just one moment. Okay, so I call the slash command, /brainiac.plain. And here I can specify the how. In the spec, you specify the what and the why. In the plain, you specify the how. And now we can say, for example, that we will use Azure Container Apps to host containerized services, not, for example, EKS, Azure Kubernetes Services, but Azure Container Apps, and use, for example, because there are some data that need to be stored, I use Azure SQL database. So you can remark here, I use manage pass services. And it's okay because in the Constitution, I mentioned previously that I want to use pass services in priority. So if there is a mismatch, a contradiction between the governance rule and what I want to define in my plan, the agent probably will throw an exception to say, okay, but in your plan, you don't respect the governance rule in the Constitution. So after a few minutes of iterations, for example, the agent here generates some multiple files. So for example, there is an infrastructure model where we can see a representation of the architecture for my solution, for my project. Other files also are generated, such for example, a deployment.md file and research.md file. The next step is the task step. So here, as I mentioned it previously, the plane is taken by the agent and is transformed into an executable file of task, as you can see on the screen. So it's really important because this step provide the granularity needed by the agents to work in a right way. So once again, you have to review the output, and the last phase, the last step, is implement. So in this step, the agent will take the task, and each task, 61 in this example, will be executed to generate in a Terraform directory the Terraform code for my project. So once again, after a few minutes of iteration, we get a Terraform project with modules. We can recognize main.tf file, outputs.tf file, variables.tf file, and so on. So it's very amazing to see how we can generate quickly production-ready Terraform code with this new framework. Of course, it's not dedicated to Terraform especially. It can work with Bicep, CloudFormation if you want in the future. So now I will close the demonstration and back to my slide. So now it's time for conclude. As a conclusion, I would say that the future is specified. So by combining the structure clarity of spec-driven infrastructure with the executional power of AI agents, we are unlocking a new area in infrastructure as code generation. One, this is faster, more reliable, and more aligned with human intent than ever before. So the key principles are simple. Think like an architect. So design the vision with clarity. Specify with precision. This is important to have a good result. So your spec becomes executable. And finally, let's AI build and scale your impact exponentially. So this is not about, of course, replacing engineers. It's about elevating them. It's about spending time on problems that really matter. So thank you for your attention and see you soon. Bye.
Yeah, that was a great talk from Cedric on using Brainiac and using natural language models to produce infrastructure, production-ready Terraform for infrastructure as code. I do like the direction the industry is going with this, where when LLMs first started, it was like you'd have like the perfect prompt, and there's a lot of talk about prompt engineering and stuffing as much stuff into context of if you could just line up the LLM just right, hit enter, you'll get the right result at the end. And with this development of things like this constitution, similar to what Anthropic is announced recently, you can say, well, here are like some guidelines, do a few steps and like let me know how it goes, and then we can like tweak it as we go, which feels more agile software development and less waterfall software development. So I'm really excited to see the developments that are being made in that space. So yeah, next Peter's going to introduce our next speaker.
Yeah, we have actually, this is a tandem. We have a couple of people presenting this next one. This is Ramon and Lewis presenting Architecting Terraform Enterprise in OpenShift Container Platform. Go ahead.
Hello, thank you very much for having us here. I am Ramon. I'm a principal solution architect here in Red Hat.
And my name is Luis Bobeta, and I am a specialist solution architect.
Yeah, so today we are going to talk about how to deploy Terraform Enterprise in OpenShift Container Platform. This is the agenda that we will follow, and overview. Luis, why we have this situation, let's say?
Yes, in my daily basis, when I have to work and integrate things with Ansible, that is the product I am a specialist solution architect, I need to integrate many things. And one of the things that my customers ask me to integrate in this infrastructure as code basis is Terraform. No, so when we try to do some of the integrations and we wanted to deploy Terraform Enterprise to do this integration with AAP, we started playing around, and we wanted to do it in an on-premise infrastructure, so we can test it out, everything that we need to do. So we decided to deploy it in OpenShift environment that we have. So we started up building the solution, and this is mostly the main structure that we made. Okay, so to do this kind of infrastructure, we need to meet some prerequisites that we are gonna see right now. Ramon, please, the next one. Next.
Yeah.
And the next one. Yeah. So first of all, we need a database, where Terraform Enterprise will store all the information about the application data, all the settings that we configure in the platform, for workspaces, organizations, user information, what kind of running jobs are there. So we need a PostgreSQL database. So we deployed it in our OpenShift. Okay, it can be whether an OpenShift or external, but we decided for the main reason to have everything is isolated in our on-premise. We put it into OpenShift. It can be a simple configuration or high availability, but we decided to do it very small, everything, not to complicate things. So we used the database PostgreSQL. And we have a disclaimer that where we can rotate the credentials for Postgre into Vault. This is optional, so we could just connect it to Vault and rotate that passwords. So the next thing we have to bear in mind is the cache. So we decided to put a cache in Redis. So we have this. It is a requirement when we have an active operational mode. Okay, but we decided to do it only for optimizing the solution to be more efficient. So we used Redis also in OpenShift. Everything that we made is in OpenShift. So and as the same as Postgre, we can rotate the credentials with Vault, and we could use it an external or internal. Okay, and inactive or whatever you want. But again, we make things simple. But when we go to a production statement, we will see what is our recommendation to do these kind of things. Okay. Next thing is the storage. Terraform Enterprise needs S3 compatible storage. So we use the embedded Theft installation that we have in OpenShift that provides this kind of storage service. it is also in that OpenShift, but it can be wherever we need to be. Okay. And the last thing, and this thing is very optional. Okay, we didn't put it into our demo because we wanted to get the thing small. Okay, we didn't want to do everything very complicated, but we could use HashiCorp to do all these kind of things that we do. Okay, this could be also deployed in OpenShift, like an operator there. And we didn't do it because it's mainly we had to do a lot of integrations there. But in the future, we will start using it. Okay, because it is one integration that we wanted to integrate also with AAP and OpenShift. So this is a great starting point to start doing these kind of things. So Ramon?
Yeah, so then with all this infrastructure and deploying the Terraform OpenShift there, we have all the control plane right now to be able to create new organizations, define all the infrastructure that we are supposed to do. But we need the agents that has to execute the jobs. So one of the main issues that people get with when working with OpenShift is that OpenShift by default requires less permissions than in a usual Kubernetes installation. So it is more restricted, and you cannot run, or you should not run containers as a root or as a defined user. So in the Terraform documentation for creating agents for OpenShift, it says that you have to do some little tweaks just to the Terraform to use a standard folder that is not restricted by these kind of constraints. And then we did the complete deployment. So apart from the Postgres, the Redis data cache, the possible Vault and the S3, we have also to deploy some certificates for connecting externally to the UI. We decided to go with Search Manager to create those certificates. We have also deployed some monitoring objects in the Prometheus internal user workload instance, so we can create nice dashboards when we can see what is happening at the Terraform infrastructure, and we will see it in the it seems like something is flicking. So we will see in the demo these nice dashboards that we have created with all the metrics that are exported by the Terraform control plane. Also, we have created an ingress route to access the instance from outside, so we can connect from our laptop and see what is happening and admin everything. So this is something that we have to bear in mind. Otherwise, it will only be usable internally. And that we will see that infrastructure when we show the demo. But what happens if we want to expand it or make it more production ready? So there are some challenges that we have not addressed at the moment because we think it was enough for our development and testing. But if a customer or if a company needs to deploy it in a production ready environment, that will be addressed for sure. So first of all, we have to have everything with high availability and with different replicas. So if any node or any container is killed or is down, there will not be any kind of issue with service, and it would not be any kind of service interruption. So we have to have in with different replicas the PostgreSQL you know that probably you will have active passive or something like, or sharding for that kind of configuration. You may want Redis to be in the same situation, and there are some operators that can handle different replicas and even have auto-scaling if needed. And the Terraform Enterprise Controller, that is for sure. If you want to integrate with an external vault, that is also recommended for production. You have to bear in mind also that this HashiCorp Vault instance has to be with different replicas to avoid any kind of disruption. Next one is what happens in case of a disaster recovery or any kind of bad situation when we need to restore everything from a definite point of view. So you have to, or it should be backup the PostgreSQL, the HashiCorp Vault, and the S3 storage. As Redis is a in-memory cache, it should not need to be backup, but the other parts are definitely worth to have this in mind. The other thing that we have to bear in mind is that the security posture. So we have to address having user and passwords with a Vault, for example. That is a very good solution. And also have certificates rotated, update, and integrated with the Vault. So everything related with security is handled by this external Vault with all the quality that it has. Another point that is worth mentioning is that the agents will run in a standalone namespace. That brings up the possibility to tell or give quotas to this namespace, so these agents cannot grow indefinitely and get all the resources that the cluster have. And you can give a definite small amount of resources for this kind of agents. And the final one is that we have sample dashboards, but any kind of alerting to kind of communicate if anything is wrong and try to circumvent what is happening or raising any kind of with your integrated alert system is something very important to have in mind. And now the demo, where we are showing this is the OpenShift cluster that we have running. So it has, as you can see, it has 4 containers, 4 pods running in the namespace. One of these is for the PostgreSQL. The next one is the Redis, and there are 2 different replicas of Terraform Enterprise, just to have to be sure that everything is okay. And if one of the pods is down, you have the other one that is getting the jobs. The topology that we can see here is quite simple. So you can see here more or less what we have seen in the presentation. And you can have a look where is the information and where are the containers that are backing each service. So you can see here, for example, we have 2 different replicas for the Terraform Enterprise. And then here we have our Terraform Enterprise instance running on OpenShift. As you can see, it's the similar one as you have seen in other kind of on-prem deployments, where you have all the organizations, the workspaces, the runs, etc. So now we have up and running this Terraform Enterprise, and you can see all the runs that we have execute. So we can just, for example, create here a sample Terraform plan. it will start, and then, sorry, something's happening. Okay, so now we have here that the plan is the Terraform run is planned. So we can just go here and approve the plan, and then it will be running on another job inside OpenShift that is applying the plan. So it will be easier. You can see here everything related with the logs, what is happening in the Terraform plan, and so on and so forth. And then in our Grafana dashboard, we can see that this run has executed. We have seen here the breakdown per organization, what are the number of jobs processed, and everything related with the controller running those jobs. So you have a full 360 view of what is happening here and a full administration here, everything running in containers. And that's all. So thank you very much for your time. And if there are any questions, we can answer them in the chat.
Excellent. Thank you so much, Ramon and Lewis. That was great. Yes, as they said, if anybody has any questions or want to talk, just jump into the chat and fire away. Richard.
Yeah, thanks, Peter. Thank you, Lewis and Ramon. I just want to take this opportunity to, I'll say remind. I think we mentioned it before, but like our annual user conference, which is coming to Atlanta this year. I believe they call it Hot Atlanta for some reason. It's warm down there. October 26th to 28th, registration is coming soon. So just mark the day on your calendar, put in the PTO at work, tell your family you have a very important business meeting that you can't possibly miss. Whatever excuse you need to make to come to Atlanta this year, I'll be your alibi if anyone asks you any questions. Also, in the chat, feel free to drop a comment on like what you've learned so far, what you're kind of still hoping to learn from sessions that are upcoming. I'm curious to see how people are thinking about today's HashiTalks. And with that being said, let's introduce our next speaker, Marcelo Zambrana, who is a HashiCorp ambassador. We'll be discussing building the bridge, turning the American Cancer Society knowledge into instant answers. I'm very excited to see a very concrete, like hands-on example of some of the stuff that we've been talking about so far.
Hello, everyone. Good morning, good afternoon, good evening. My name is Marcelo Zambrana. I hope you are enjoying HashiTalks 2026 and all the amazing content and presentations. Happy to be here another year, sharing some of my experience and learnings with everyone. I am a software engineer at Microsoft. I focus on cloud technologies, infrastructure, and automation. I am passionate about DevOps, infrastructure as code, and open source, of course. Today, I want to share my experience working on a project with the American Cancer Society and how we used AI to build a bridge between knowledge and people. But before we get technical, I want to start with a quick exercise. This is usually better in person, but let's try anyways. So please raise your hand if you know someone or if you yourself have been affected by cancer. Now, keep your hand up for just a moment. Imagine that hand isn't just raised. It is reaching out for help, reaching for support. and there is no one there to grab it. It gets you, doesn't it? That's the reality the American Cancer Society works to prevent every single day by making sure no one has to face this alone. We all know the American Cancer Society, ACS, is leading the fight against cancer. But what many people don't realize is that volunteers and donations are what make most of that possible. When ACS talk to us, they share some very real challenges they are facing. Planning events and signing for volunteers is often tedious. Onboarding new staff and volunteers takes too long, it's time-consuming. And while the information exists, it is scattered across many systems and is really hard to access. And this matters because without donations, research doesn't happen. Without volunteers, services and events simply don't exist. And to put the scale into perspective, these numbers may be slightly dated, but they tell the story. About 25% of ACS's operating budget depends on this ecosystem. Nearly 80 million people are reached. 47,000 rides to medical appointments, and over 500,000 nights of free lodging for patients and their families. And all of this depends on volunteers having the right information and the right time. So the question we asked of ourselves was simple. How can technology help remove friction and help more people reach out and actually get help? For ACS, a lack of information isn't the problem. They actually have a lot of information. They have data on donations, volunteer events, fundraising activities, everything. The real challenge is access. With so much information spread across systems, it is really hard, especially for new volunteers and new employees, to know where to start. People run into the same questions over and over, but finding clear, trusted answers isn't easy. And that matters because volunteers are the lifeblood of the American Cancer Society. Yet, many of them don't have simple, fast access to the guidance they need to be effective. Without easy access to training and institutional knowledge, volunteers struggle to find proven fundraising for best practices, effective donor engagement and strategies, and when help is needed the most right now. So the problem isn't too little information. It is turning all that information into usable, actionable knowledge at the right time. The challenge wasn't a lack of answers. It was how to surface them at the right time. ACS needed a way to ingest tens of terabytes of content spread across multiple systems and turn that information into immediate actionable guidance for staff and volunteers. So our goal was to build a bridge. A simple, scalable way to connect staff and volunteers directly with trusted answers, without forcing them to search through massive content libraries, right, like SharePoint. So, how does a system need to look like to make that possible, to make this possible? In order to do that, let's talk about the architecture. From day one, we designed the solution around 5 core objectives. Those are, it need to be automated, security, flexibility, scalability, and accessibility, of course. Everything you see in this diagram ties back to one or more of those goals. We start with automation, of course. All the infrastructure is deployed using infrastructure as code with Terraform. We use Terraform and Terraform Cloud to define, deploy, and track the state of the entire environment, which is awesome. The full deployment lifecycle for both infra and application code, it is automated using GitHub Actions. We enforce pull requests, rules, reviews, and control merges, so nothing gets deployed without validation, and that gets applied for both infra and application. secrets and credentials are managed securely using GitHub Secrets, allowing our pipelines to deploy directly into the target cloud subscription without hard-coding credentials, which is awesome, which is great. No more leaking credentials or hard-coded passwords. This approach gives us a few key advantages. We can deploy the same architecture to any tenant, any subscription. We support multiple environments, development, staging, production, you name it, with minimal configuration changes. Scaling up or down is a simple configuration change. We don't need to redesign anything. And also, distributed teams can work on different parts of the system at the same time. Infra, application, front-end, back-end, you name it. And once changes are reviewed and approved, merging into the main branch automatically triggers deployment. No manual steps required. We even have some triggers that when you deploy the infrastructure, it automatically deploys the application, which we are going to see in code. And as you can see on this slide, especially on this side, when we see all the cloud resources that are deployed, all cloud resources are deployed through the same automation pipeline. And two things to highlight is we rely on managed identities for authentication, no embedded secrets or credentials, so service can communicate using those managed identities. We are leveraging newer AI agent services, and APIs are still in preview. And to mitigate this risk, we isolated these components with limited permissions, and we designed the architecture so previous services can be swapped or upgraded without impacting the rest of the system. And we're going to see in the code. A good example is how we use the Azure RM provider and the AC API for these preview APIs. With this foundation in place, we were able to focus less on managing the infrastructure and more on delivering trusted AI-driven answers. But at the end, Terraform allows us to treat the entire platform, AI, security, networking, as a single version system, which was awesome. But to see it all in action, let's see a demo. Let's see everything working together. Okay, so demo time. Let's see if this works. Is that big enough? Hopefully, maybe one more. Okay. So this is, let's see the project. So we have some folders here. This is for the workflows in GitHub. The infrastructure is here. And the Python code for the application that we're going to deploy is here under source. So let's look at the Terraform code first. A couple of things to highlight here. It is, of course, I'm using Terraform Cloud and to track the state. And we have these providers. We are using the Azure RM provider for most of the services, and we use AC API for the previous service that we're going to see. Here we deploy everything that is related to the AI service, AI services itself, the Foundry Hub, the project, and here we're using the API resource. As you can see, it's in preview, that allows us to have the connectivity with the AI services and our Foundry Hub. We also have some role assignments for the managed identities. This is for the we use the Azure AI developer and its access so we can work on those APIs. We also have here we deploy the model we're going to use. We can see that here in this example we're going to use GPT-4o mini, but you can always change or deploy more models if you want. We're going to be using this version. I think there's a newer one. And yeah. Moving on to the application itself, this is a Python application using Flask for the front end. Here we are importing everything that we need. And I want you to take a look at a couple of things. We are using some environment variables. This is the Azure AI endpoint that we're going to use to talk to our backend. And this environment variable is set during our web app deployment. As part of the app settings configuration, this environment variable gets set, and it just sets the endpoint based on our deployment of our AI service. So in order to communicate with backend, we need that endpoint, and this is the endpoint we get set for our application. So as soon as infrastructure is deployed, everything is configured, and we just can deploy the application and should be able to talk to our backend. And again, we use that endpoint, and we use default Azure credential, which is we are using the identity of the web application. And as you can see here, we have we assign the Azure AI developer role to this web app, so it can connect to our backend. And moving on to the automation and orchestration using GitHub Actions. As you can see here, this is our Terraform workflow. We have some rules for pull requests. Main branch is the one we're going to use. And we use environment variables in GitHub secrets to set authentication. To be honest, we could have used OpenAI, OpenConnect ID to connect to our Azure subscription, but I just wanted to showcase the GitHub secrets. On the application automation, here we have, this is a Python application, and we have this rule here. So whenever the Terraform workflow completes, we also trigger this one. Mostly because there might have been some changes in the infrastructure that need to be refreshed, and new endpoints, things like that. So that's why we deployed the application again. So we have the latest. Otherwise, the application gets skipped, and it only gets triggered when we make changes to the source folder. And now, if you want to see everything deployed, I just did one deployment. It deploys everything in a resource group. Everything is encapsulated, properly tagged. And as you can see here, all the resources get deployed here. We have some the app services here, the app service plan. We have application insights to get metrics from our application. The hub, the project, the Foundry service itself, the key vault to manage secrets and certificates for connectivity. Longlist workspace, so we can track logs for all front and back end. And a storage, so we can have some vector storage, so we can upload documents if we need it, and we're going to see that. So everything is here. So at this point, we should be able to just go to our web app, and at the same time, since we are using Terraform Cloud, I can do a Terraform output, and we should be able to get the same information from the output. Here is the URL that I'm going to target, and we can just click here. And as you can see here, this is the website that gets deployed. This is the Python application. And if we go to the Foundry portal, here you can see this is the project that we have. This is the agents, which are in preview. And these are some of the agents that we have been using. Again, this is the model we have deployed, right? And if we want to, for example, we can create just a new chat. Here is the new chat. We have some predefined questions that is here. We can ask what are the best price for donor engagement, for example, right? This is going to make a call to our backend. Since the web application is configured to have access to our backend, it's going to connect to it. It's going to look for answers based on the internal documentation, and there you have it. We have the response. And actually, we should be able to see these here. Let's see. Here are all the calls that I've been doing to the backend, and you should be able to see the same code here as well, that we get some opportunities. This was probably a previous chat, and yeah, you should be able to see the same calls that you get. Some best price for donor engagement. This is the latest we did, right? So we should be able to see that this is the response from the backend, and gets pushed to the front end and gets displayed for the user to see. Right, so all that ties together, right? The authentication for the application, it is done using managed identities, and again, everything is secure. And if we wanted to, we should be able to deploy more models and things like that for different use cases. Another thing I wanted to show is that right now for this POC, you have here's where you add knowledge. Right now for this test, I only added some files, sample data. But in production, you should be able to add multiple other sources, even SharePoint if you wanted to, right? So instead of going to SharePoint, crawl through multiple sites, you just have the connection to your SharePoint site, and the agent should be able to go through all that and provide answers for you. And this is GitHub. This is the GitHub Actions. This is for the Python application for the infrastructure. I even have one for Terraform Destroy just to clean everything from here, so that I don't have to do it through the CLI, even though I do like it. But again, all of this is done with this code. Everything is going to be open source and in this package, right? So in case we wanted to support different more users, for example, we can easily change this queue and we can scale up. Or if there is a dev environment I want to create, we just get a smaller queue. And it's pretty much the same for the models. If we want to test a new model, for example, we can change the variable to a different model for production or for development, right? We can test multiple models and see which one is better for us. We could deploy different subscriptions or tenants if needed. Okay, I think this is a good time to go back to slides. I think that's everything I want to show. Everything is going to be open source again. So going back to slides. So let's go back to slides. Let's go see if this works. That's good. Okay, so that was the demo. Hope you guys like it. And yeah, so some key takeaways. As you saw, AI can turn scattered institutional knowledge into timely, actionable guidance. And especially here, the problem is on lack of data. It was just access to that huge amount of information that they have. But at the same time, start with automation, not AI. As you saw, infrastructure as code and CI/CD enable us a lot of things: security, scalability, repeatability, everything from day one. So please start with automation. Also, you need to think about how you can enable trust. Governance, managed identities, secure pipelines are critical for reliable AI systems nowadays. So please, architecture also enables trust. And you need to also think about change. Isolating AI components allows you to safely adopt previous services like we saw using API, which these are evolving APIs, right? But we wanna test and wanna use them. And once they are GA, we can switch to the GA ones. But yeah, you need to design for change, especially nowadays when everything moves faster. And another thing is, it is good when you tie the solutions to real outcomes. In our case, like onboarding speed, volunteer effectiveness, fundraising engagement. AI impact needs to be measurable somehow, right? How we are helping. And remember, when knowledge flows easily, people can focus on helping others, not searching just for answers. Technology allows us to amplify the mission. And also it's good to remember that good architecture doesn't just scale systems, it also scales the impact. Something to think about. Moving on, here are some resources and I want to leave you with. All the code is going to be on GitHub, don't worry about that. But if you want to learn more about AI agents, I recommend checking out the Azure AI Agent Service documentation and the AI Agent Framework. They're really easy to use. They have APIs for Python, C#, Node, and yeah, really nice documentation and get you started really fast. If you want to learn more about infrastructure as code and automation, I strongly recommend checking out the Terraform documentation, the Azure RM, the AC API that we saw, and of course GitHub Actions if you want to learn how to orchestrate all these pieces in your design. Lastly, but not least, if you want to learn more about American Cancer Society and how you can help, I strongly recommend you checking out their website and consider volunteering. The repo is going to be open source. Might leave the application up and running for a couple of weeks. I don't know, we'll see. But again, you can easily just clone it, fork it, and deploy yourself. And you should be able to have one for your own. So I guess with that, I just want to say this project with them has been amazing. I know questions and answers are not the end goal. The real goal here is enabling something better, helping people get support when they need it the most, basically. But with that, I just want to say thank you for tuning in. I hope you enjoyed this presentation. I really enjoyed working with them, try to help somehow this organization. It was amazing. Again, all the code I showed today is going to be available in my GitHub account. So please feel free to contact me if you have any questions, comments, or if you just want to say hello. You can add me on LinkedIn, follow me on GitHub. Yeah, please do. Finally, thanks to HashiCorp and the whole team for this amazing opportunity. Every year I'm looking forward to this opportunity to share what I've learned. Thanks everyone. Until the next time, gracias totales. Ciao.
Awesome. Thank you, Marcelo, for the session on the American Cancer Society and how they're streamlining the process of getting information to the people who need it. Sorry, 1 second. So Peter and I coordinated ahead of time to make sure we don't step on each other's lines for these interstitial times. And then I completely forgot which ones are mine. So Peter, are you doing the next announcement? Or
yeah, I'll cover the next one. Sure.
Okay, you
sounds
do
good.
The next one, and then introduce the let's take a very short break from strictly follow. Let's go off script as they will, or as
sure.
Somebody once said, "Forget it, we'll do it live." Right. So Peter, I'm curious, like what's been your biggest takeaway so far today? Like what have you liked so far about HashiTalks?
I'm kind of new to, I wasn't a part of the HashiTalks last year, but I just love this. Everybody, it's similar to user groups. I work with user groups, and what I love about user groups, people just give their time, they give their experiences, right? So we're hearing these great talks about here's how I'm using it, and here's how I'm using it with this group, right? And it's just so impressive, and it always blows my mind that people are willing to take this time and put together these great presentations and give. That's what it is. You're just giving to everybody that's interested and wants to learn. It's great to be a part of this environment. That's what I'm taking away from it so far. Yeah.
Awesome. Yeah, there was a session this morning on using Terraform with Minecraft to programmatically provision infrastructure, and I was talking to the speaker about it a while back. And when he had casually mentioned it, I thought he meant provisioning infrastructure, provisioning the server, the Minecraft server, the real world stuff. And then he's like, no, it does this. And it blew my mind. I was like, that is so cool. My little brother played Roblox when he was growing up, and he would always ask me oh, you know how to code? Can you help me do this programming in Roblox? Help me learn how to code. I think
right.
They use Lua, I believe, is the programming language they use for the custom extensions. And it's really great to see games that aren't built for maybe learning for their own sake, and seeing the way people use those and build learning platforms and learning systems on top of it. I think it's super exciting. But speaking of a session that we had earlier this morning, if anyone missed that session, how would they be able to how do they see that? Like what happens? Is that gone forever, or is there some way for people who missed the session to be able to see that?
No, I think so. Absolutely, yeah. HashiTalks. I love it that it's going for 24 hours, right, across all time zones. It's about 1 o'clock in the afternoon here in Ottawa, but maybe it's getting late where you are. So I plan to try and, we have our little block here where we're emceeing, but I'm going to keep trying to touch back in to see how all the sessions are going. But when I was younger, staying up late, staying up all night, 24 hours, no problem. But that's not the case now. I usually fall asleep about 9 p.m. in front of the TV. So that may, I have a tougher time. My decline from when I was younger to now is frankly embarrassing. So I'll do my best, but you're right. If you can't stay up and you can't, you have to step away and do something else. Everything is basically going to be published on our official YouTube channel. So every session that is already run, everything that's to come will be published there in the coming weeks, right? So you'll be able to, catch up on demand for anybody that has to step away or have to take a nap, whatever it is you have to do. No worries. Everything will be published over the coming weeks. Yeah. So why don't we get on to the next, sorry.
We got a couple minutes and we have a question from, I'm gonna say it's from the chat, but it's actually from Jasmine who put most of this together. She's asking, Peter, can you tell us more about IBM user groups? Like a lot of people here today, they come from like Hugs, Hashi user groups, and I guess what's front of mind for them is like, is an IBM user group just a Hashi user group with like a sticker put over the word Hashi with IBM, or is there what's unique about an IBM user group?
I think, user groups, if you don't know about user groups in general, just this, ability to, as I said, it's similar as people are basically taking their experiences with all our products, throughout the entire IBM catalog and HashiCorp, and basically sharing, what they've learned. And people that come out to these user group sessions, maybe you're a beginner, maybe you're an expert. It's a great chance to network. It's a great chance to, get to know everyone and just learn the product and network and learn, how everybody is using the products in a day in, day out basis. It's a great opportunity. It's sort of probably the best, most engaging way to learn and educate yourself about different products. So, and again, it's just now it's you have the HashiCorp user groups, the Hugs. I deal with acronyms, too many acronyms on a daily basis. Hugs is now my all-time favorite acronym, but basically, yeah, again, we get to expand this portfolio of products that people can use and join in with HashiCorp and now all the other IBM products as well.
Cool. And can anyone attend an IBM user group, or do you have to own a 3-piece like business suit? How does someone? No. Are there any requirements? You just show up and say, "I want to learn."
Just show up. Yeah, exactly. We have, you can go and find a session, a user group event maybe that's near you, or join a group online and stay connected that way. But yes, absolutely, everybody is welcome. As I say, don't be shy. I don't know anything about the product. I need to learn about the product before I go to a user group session. It's like, no, that's what you're there for. You're there to learn. You're there to hear about it. And, you'd be surprised who you meet. And we often find that those, that are joined for the first time and check it out, they end up being a speaker 2 or 3 sessions later because they have more knowledge than they're aware of, right? We learn every day and everybody's learning and using the product in different ways. So it's a great opportunity to share, just like we're going to be doing here in the next 24 hours.
Awesome. Yep. And I know if I ask you what your favorite hug is, everyone's going to get mad if they're not picked. So I'm going to ask you, IBM user group. What's your second favorite IBM user group?
My second favorite IBM user group, I'd have to, I can't even say that because there's so many great ones. I certainly don't want to say one over the other, but I guess
it's a 200-way tie for second.
Yeah, that's right. Yeah. Okay, and they're all just, it's always different. I've been to ones that, there's 15 people, and we're eating pizza and drinking pop. And then I've been to other ones where it's like 120 people and, it's, it's a bigger meal or whatever. It lasts 2 days. There's all sorts of levels of which, you can engage and whatever time you have to commit to these user groups, it's there for you. There's something out there. Yeah.
Okay. You said drinking pop. I assume that's the Canadian version of soda or cola.
Yeah. True. Yes, that's right. I've caught myself saying that before. Yeah. Soda and pizza. Yeah.
Cool. Awesome. I think people are tired of seeing the two of us now. So let's introduce our next speakers.
Okay. So next up, Hisham Murad. The session manage secrets and protect sensitive data across hybrid cloud environments. take it away.
Everybody, and welcome to the HashiTalks session, Manage Secrets and Protect Sensitive Data Across Hybrid Cloud Environments. My name is Matthew Packer. I'm a product marketing manager with the Ansible business unit in Red Hat, and I'm joined by my colleague Hisham.
Thank you, Matthew. My name is Hisham Murad. I'm a technical marketing manager with the Ansible business unit here at Red Hat, and it's our pleasure to spend some time with you today.
Awesome, thank you. And we're here to talk to you today about how Red Hat Ansible Automation Platform and HashiCorp Vault can deliver that secrets management for you in your hybrid cloud environment. So let's break it down here. What are the benefits of Red Hat Ansible Automation Platform and HashiCorp Vault individually and then together? And then we'll get into kind of some of the more technical details and use cases. So on your left, you have Ansible Automation Platform, right? That's hybrid cloud automation, right? Ansible is going to allow you to automate your systems and services and maximize all the efficiencies across your hybrid cloud, being able to automate things like from infrastructure to cloud services to networking devices to edge devices to security device, really any kind of piece of technology in the IT stack, Ansible can automate that equipment or piece of software, right? And that really leads to achieving those business outcomes, right? So when you can employ automation across your hybrid cloud, you get the scale and you eliminate manual toil and you get all these great business outcomes by doing so. Time savings, money savings, quicker innovation, right? All these business outcomes you reach with automation across your hybrid cloud, right? And this brings consistency across your hybrid cloud, right? So when you're automating all the different facets of your hybrid cloud, you're getting consistency throughout that cloud. That means every switch is going to be configured the same, every EC2 instance, every Azure VM, every Google Cloud Compute instance, right? Whenever you do the deployment with your configuration as code, you are going to get the same result and consistency across your hybrid cloud. So that's the Ansible side of it, right? That leading automation platform. So what does it bring with HashiCorp Vault? The leading comprehensive secret management platform, right? And really you get those protected secrets and data, right? So the number one thing, right, is identity-based security. Vault is that leading solution for that as being the identity broker and trusted identity connections between your users and your servers. Now leads to the next one, right? That it is really about enforcing, providing, and making sure that people and machines are who they say they are, and they only get access to what they need access to and nothing else. And what it really brings is that single centralized record of access all in one place, right? No longer secret sprawl across many different platforms and different storage, secret storage software or platforms or devices, or writing them down on Notepad, right? HashiCorp Vault brings it all into one single centralized place. So what do you get when you combine those together? You get end-to-end trusted automation. And the number one thing is you get secure automation, right? So now instead of secret sprawl and having to have secrets stored in Ansible, stored in Vault, stored in another location, right? You get that secure automation for your hybrid cloud by Ansible using Vault as that secret store, and Vault providing that time-bound access and secret rotation that is required for modern IT systems and security. Along with that, you get centralized access. So, right, for managing secrets for your cloud surfaces, your VMs, your network, your databases, right? All these edge points, all these things I talked about Ansible being able to automate, you don't have to store those secrets all over the place. They can all be stored securely in Vault, which is amazing. And then finally, you get to automate secret management. So you can use Ansible to go ahead and rotate secrets on endpoints that maybe Vault Agent can't run on. And also you can have Ansible assist in deploying Vault Agent to be able to control and rotate secrets on an existing infrastructure there. So you can do a lot of automation around that. So you bring those together, you get that end-to-end trusted automation across your network, your operating system, Windows, Linux, you get cloud virtualization, AI ops, application delivery, right? All those places where your hybrid cloud automation plays. With Vault, you get that secure end-to-end trusted automation. On to the next slide, please. Perfect. So what does this look like from a lifecycle management perspective? So you've probably heard us talk about, or people talk about Terraform and Ansible together, doing that day 0 to day 2 infrastructure lifecycle management. What does Vault bring to that picture? Well, that brings an extra level of secrets management at scale and securing that lifecycle management. So at day 0, when Terraform is doing the provisioning of that infrastructure, it is doing the automated privilege and secrets deployment as part of that. And then on day 1, when Ansible is going in and configuring that infrastructure, right, it's going to use Vault for secrets management, for access to secrets, to be able to access that infrastructure that Vault just deployed. Or it may be going and configuring Vault Agent on that infrastructure that was deployed. And then finally on day 2, as Ansible's doing your day 2 operational management, things like patching and updates and orchestration and configuring networking switches and infrastructure, Ansible is going to be able to use Vault to get those secrets for access to automation. If you're automating anything, you need a secret to access it, and that's where Vault really comes in there. And as well, we'll rotate those secrets, right? Keep it all secure, and together the three of them make that secure, unified lifecycle management. Next slide, please. Perfect. So just from a high level, and I got into this a bit, but there's really kind of two, and Hisham's going to dig in deeper on this, but there's kind of 2 pillars of automation or integration, I should say, with Ansible and Vault. The first pillar is that secured automation. So Ansible using Vault as the secret store to go and access systems to do automation. So whether it's getting certificates to access Windows servers, or credentials for a RHEL server or an SSH key, or it's keys for a network device, or it's access for an edge device, right? Ansible can use Vault to get those secrets. You don't have that secret sprawl. You don't have to recreate secrets in Ansible itself and have to rotate them there. All that can be done in Vault directly. The second kind of pillar is around automating the security. So this is what we talked about. If you're adopting Vault throughout your hybrid cloud, you can use Ansible to go and deploy Vault Agent to all your existing systems and configure it and make sure that it can call home. But it can also go do rotate secrets on platforms that just don't support Vault Agents. So say network switches or an edge device that can't run Vault Agent, Ansible can go and rotate secrets there. So those are the kind of 2 main pillars of that integrations. Next slide, please. So you may be asking yourself, okay, that is great. How does it actually work from a low integration perspective? And this is the answer here. We have Red Hat has the HashiCorp.Vault certified collection for AAP. This allows you to deploy, configure, and operate HashiCorp Vault, and as well have secure dynamic secrets access in Vault from AAP playbooks and AAP workflows. So this is really the bread and butter there, right? This is the no longer do you have to do one-to-one mapping of secrets in Vault and Ansible, or secrets in Ansible that are also managed elsewhere. If you manage all those secrets in Vault, Ansible can dynamically in a playbook be able to access Vault for secrets. So if it needs to go patch a group of servers, it can access Vault to get the credentials, the secrets for accessing that set of servers. So really will simplify automation and management of them. Next slide, please. And these are just extra ones we want to touch on, right? I talked about Ansible and Terraform and Vault together in your kind of holistic infrastructure lifecycle management from day 0 to day 2. How you integrate with Terraform is the same thing. We have a certified collection, HashiCorp.Terraform, so Ansible is able to call Terraform directly to be able to deploy infrastructure. Next slide, please. And finally, to reverse that, if Terraform is your starting point and you want to be able to call Ansible automation platform from Terraform after Terraform deploys infrastructure, to call Ansible to go configure it, the Terraform, the certified provider for Ansible automation platform for Terraform is how you would do that. Again, all of these are fully supported by Red Hat, fully supported by HashiCorp together, right? We're under the same family now. We support both these libraries, the collections providers together, as well. We support both for this. These collections support both Terraform Enterprise and Terraform Cloud. So just noting that. Next slide, please. And I think I'm going to hand it to Hisham now to dig into some of these use cases.
Awesome. Thank you so much, Matthew. So I'm going to jump in and talk about some of the common use cases that we have today through the integration of Ansible Automation Platform and HashiCorp Vault. So we'll discuss the existing use case, and I want to highlight some additional use cases that are also coming as we continue to enhance this relationship and as we continue to enhance the collection that Matthew discussed, which was the HashiCorp Vault certified collection as well. So first of all, often organizations need to be able to quickly deploy the Vault agent, right? So a great use case for Ansible Automation Platform obviously is application deployment, right? A Vault agent is nothing but another, little app that you're going to deploy on the different targets, right? And so one of the use cases here is that, being able to leverage Ansible Automation Platform to capture, right, that, Vault configuration and installation setup, and be able to deploy that, to the targets, right? So how do we make that happen, right? Again, this is all happening through the certified collection that Matthew mentioned. So if we get into that same use case, but now into a little bit more detail, right, we'll highlight this a little bit more. So here, for example, Ansible Automation Platform is going to authenticate to Vault. Now, let me just pause for a moment. So typically the way to configure this, right, is in Vault, you would configure something called an app role. Once you have the app role defined, you're going to have an app role ID, a role ID, and you're going to have a secret ID for that app role. That is going to be then configured inside of Ansible Automation Platform, and that's how Ansible Automation Platform authenticates to HashiCorp Vault, right? So in this case, what's going to happen, it can actually reach out to Vault. It can capture the agent configuration that is required for the installation, and then it's going to go ahead and install the Vault agent on the different targets. And as you can see here, the different targets could be things like, VMs, physical servers, containers, network devices. So different type of infrastructure that is, common in your hybrid cloud environment. We can install that Vault agent, and then lastly, HashiCorp Vault can also make sure and validate, right, that agent is set up properly. So this is one use case here, again, just to help you accelerate the deployment of the agent, so you can actually a lot quicker start to leverage the HashiCorp Vault capabilities. Now, one of the most common use cases that is leveraged today is really all around secrets management, right? And so Vault is an incredible secrets management tool. As Matthew mentioned, that's where organizations want to securely store their credentials, right, for different types of devices and infrastructure within their organization. So that's awesome, right? So now what we're doing, the use case here is really just leveraging Ansible. Anytime Ansible needs to perform any automation, whether that is spinning up any infrastructure, deploying applications, patching resources, updating network configurations, whatever the targets may be, right? It needs to capture those credentials. Those credentials are not stored in Ansible Automation Platform. They're stored securely where they need to be in Vault, right, in HashiCorp Vault. And so Ansible can go out and capture and grab those credentials, those secrets, so it can actually perform the ongoing automation operations against those, target Vault secured infrastructure. So here's just a little bit more detail, if you will, around that specific use case. So you can see here, for example, Ansible, again, is going to authenticate to Vault. It's going to request the secret from HashiCorp Vault. Vault will return the requested secret, so that will come back to Ansible, and Ansible is now able to leverage that and basically authenticate against the the target. Again, that could be a physical server, it could be a VM, it could be a network device, it could be a, a containerized cloud native application. And then it can go out and perform the automation that is desired against any of those target types. So really simplifying this and keeping the security and the secrets management to Vault where it should be. Right, so great use case. This is commonly used today. So this is leveraged today, as I mentioned, through most Ansible automation platform customers today. Again, just to reiterate how they do this, is there's an app role defined in Vault that the app role credentials, the role secret ID and the role ID are both stored in Ansible automation platform. So Ansible can just reach out to Vault to request those secrets and then perform that ongoing operations. By far the most commonly used use case today. But we want to further enhance this use case and further provide additional security and enhancements to this as well. And this is where we get into the next use case. Now, the two use cases I have already discussed there, those are use cases that are in place today, so you can take advantage of those today. Now, this use case here is planned, okay? This use case is around Ansible Automation Platform as an OIDC authentication provider for HashiCorp Vault. OIDC is OpenID Connect authentication. And so the idea here, right, is we want to, again, further enhance and secure these secrets access by leveraging OpenIDC authentication. Okay, so this again strengthens that security with leveraging time-limited credentials. So not necessarily having credentials that may not, expire, but these are time-limited credentials to further secure the automation access to performing automation against that Vault secured infrastructure. So let's take a look at that in a little bit more detail, right? So the same use case here. How do we do this? So this is really in more detail here, right? So again, you have to configure OpenIDC authentication between Ansible Automation Platform and HashiCorp Vault. That's one of the prerequisites, obviously, to take advantage of this. Remember, this use case is not something you can do today. This is coming. So as you see here, it's planned. It won't be too long. We'll hear more details about this, but it is coming. So what's going to happen here is you've configured the OIDC authentication, again, between AAP and Vault. And so now, let's say somebody leveraging Ansible Automation Platform wants to perform automation against a resource. But they don't have the credentials, so they need to actually get those credentials, right? That's Vault secured infrastructure. I need to, go ahead and request those secrets. So Ansible will authenticate via OIDC, leveraging an Ansible a JSON web token to HashiCorp Vault, right? And then Vault is going to come back and return this short-lived token for secret retrieval. Okay, so now Ansible has that short-lived token. Leveraging that token, it is now able to go ahead and retrieve the elevated secret or the secrets for the Vault managed infrastructure that it wants to automate against. And then Ansible Automation Platform, now that it's retrieved the actual secrets that are necessary to perform the automation, it can then continue on and run the automation with those secrets that it's retrieved. Again, this is applicable to any of the Vault secured infrastructure. So this is coming soon, so you'll hear a lot more details about this. And that's it for the use cases, and I just wanted to highlight some additional resources for you. So again, we have a web page that discusses the HashiCorp and Red Hat integration, both around HashiCorp Vault as well as HashiCorp Terraform. We wanted to highlight here the certified collection. So we have a certified collection for both HashiCorp Terraform. Again, this collection applies to both Terraform Enterprise and HCP Terraform, formerly known as Terraform Cloud, right? We also have the Vault certified collection, and so that is called HashiCorp.Vault. And then for anyone wanting to all Ansible from Terraform. There's also a Terraform provider for Ansible automation platform, and we've linked it here so you can actually go and get some additional details around that. We do have a self-paced lab. This really highlights the integration between Ansible automation platform and HashiCorp Terraform. So if you wanted to see what that is like, you can take a look at that. And then we have some blogs both on the HashiCorp Terraform and on HashiCorp Vault. So Matthew, thank you so much. And thank you everybody for attending the session. We hope you enjoyed it, and we hope you do follow up with some of these resources. And thank you so much for your time. It was great having you. Thank you.
Thank you, everybody.
Thank you very much, Hisham. That was great. In case anybody, Hisham is in the chat, so if anybody was just a little while ago, so if you have any questions, go ahead and again, jump into the chat and ask away. Hand it back over to you, Richard.
Awesome. Yeah. Thanks, Peter. And thank you, Hisham and Matt, for that session. Just remind everybody, this isn't just a live stream. It's what's called global conversation. So if you're in the chat right now, in addition to asking Hisham and Matt about the session that just ran, like, tell us where you're tuning in from. Tell us where you'd like to be tuning in from. Share what your biggest takeaways are. Share what you'd like your biggest takeaways to be if we had a session for the exact topic you wanted covered. And feel free to talk to other people in the chat. Like, it's I don't want to say hundreds or thousands. I'm gonna tell everyone there are millions of people in the chat. Just ask whatever questions you want. Maybe you'll make some new friends. Hang on 1 second, Peter. Okay. Yeah. Okay. So I just heard from one of our producers. We have an exclusive bonus video just for the people who tuned in to our section today. So we are actually going to share exclusive content never before seen, and it is dynamic secrets with the Azure provider. This wasn't on the schedule. Nobody knows about it. So if you're tuned in now watching, you're getting something no one else is getting. And so with that, let's see this bonus video they got for us.
My name's David Wright. I'm a solution engineer here that works on the Microsoft team. And today we're going to talk about dynamic secrets and using the Azure provider and why you should be using it in your configurations. So let's dive in. If you're familiar with deploying Terraform into Azure, then you would be very familiar with this code snippet. This is defining that we're going to use the Azure RM provider, and it's then dividing within that provider, defining how we authenticate into the Azure platform to allow for configuration to happen against that API. This snippet is taken from the Microsoft Learn pages, and we have a well-documented partnership with them around how to deploy specific resources. But this code snippet in itself opens up one of the challenges and highlights one of those challenges around using static secrets in that component. Now, you can use service principals, you can also use workload identity within that provider, but fundamentally you are now hard coding these into your code component. And so having hard coded credentials within your Terraform is obviously creating a security risk. This risk is obviously highlighted with the amount of committed secrets that have gone into GitHub. I think there's now over about 10 million there. Obviously, each one of those was probably not meant to be there and was a mistake. Obviously, trying to understand where those secrets are being used, particularly in a large environment with lots of devs running that have all statically configured their access principles. And then how do you manage those? So individuals to rotate those secrets? How do you actually invalidate them if you need to? How do you control and put some operational control around that environment, as well as then meeting compliance? So how do you audit that? How do you see who was doing what when? And how do you define what that least privilege enforcement is for each one of those users? So by exposing those credentials in real life to users, obviously increases this risk, increases leakage, mishandling, or even potentially unauthorized access. So really and truthfully, using hard-coded secrets within that workflow is something that we obviously want to try and avoid. And because of that, we have introduced the dynamic provided credentials to authenticate directly into Azure. So fundamentally, it uses a OIDC JWT token that authenticates against the Azure platform. Within your Terraform cloud, you only need to define a few simple variables, environment variables. Now, whether you do that dynamically as code, so because we're using Terraform HashiCorp cloud platform, we can actually build within the HashiCorp platform using code. So you can create a workspace dynamically. Within that workspace, you can create these variables dynamically and define them within that workspace for use. Or you could create them as a variable set that is then consumed by different workspaces across your environment. But fundamentally, we're defining the TFC Azure provider auth, which is then defined as true to say that you want to authenticate dynamically against your Azure platform, the state of your last client run, and which subscription and which tenant this is specifically wants to be authed against for that workflow. So these simple environment variables are then defined and allow you to actually start when we fundamentally look under the hood around what is happening. What we have done is we establish a trust relationship between Azure and Terraform Cloud. That trust allows us to communicate and generate our OIDC compliant workload identity token. So that token is an interchange between those two platforms. The token, when needed, is sent to Azure, which then authenticates it, and if valid, sends a fresh set of credentials back to Terraform Cloud to actually run against that particular action. Now, because we can create different federation components, this means that we can actually define who is asking for what against a particular action. So if this is a plan, we can set least privileges and send that token back with the least privileges to allow that plan to happen. And then this could be distinguished between a security audit group and maybe a platform team deploying, where the platform deploying the application need to do the Terraform apply. When they run a Terraform apply, a new set of credentials are then issued, and they have the set of privileges identified for them to actually deploy the resources within the Azure platform. So again, not only are we creating credentials dynamically, but also defining them with the least set of privileges that they need to do the tasks that they actually need to perform. And then once that task has been completed, so the run is then actually completed, those credentials are then immediately revoked. This means that even if there is any leakage, or if there is any misuse of them, or if users get to see them, then they are immediately revoked after that run and now become completely useless for anything to be used or misused. Right. So now that we understand what's happening, let's take a physical look at some examples of this. Let's take a look at how we configure this. Let's take a look at how we could use code to set up our workspace. Let's have a look at how we can actually then retrieve our credentials and deploy our resource in our Azure environment. So let's take a look in detail about what we're going to build. So in our code, we have two components. We have the Azure component that we need to obviously build and set up. And because we're HashiCorp, we're going to create our Terraform workspace using code too. So let's take a look at those two elements. So first, if we take a look at our Azure component, what we're going to do is obviously leverage the Azure RM provider and actually leverage the Azure AD or Entra provider, we just haven't changed the name, and create some construct. So we're going to look at what our current subscription is, we're going to look at what our client config is, and we're going to actually then define an application registration within our Active Directory. So we define our application and give it a name. So here I've just randomized the name so that we could use this multiple times. We then create a service principal to actually give and create our client ID and some authentication to this. We then define our role. So we're establishing our policy and our scope within the context of our service principal. We then create our federated identity. So this is so that our OIDC connection can federate to it. And in this subject, we're actually defining and creating that federation const string that we need to talk. And in this, we have defined our organization. So this is our HashiCorp Terraform Cloud organization. So if you have different OUs, you could segment that into different elements, and we'll take a look at that a little bit later. The specific project within that category, the workspace, and then whether this is applying to a plan or apply. And as I said, because we can create different federations against that plan and apply, we can create different permissions, if we wanted to, against those two strings to give different access rates to it. And here, this is the apply version of that. And so now when we think about applying that to our workspace, what we're doing is we're defining our workspace. And in this construct, we're giving it our workspace name from our variable. So it's a fixed variable that I know my workspace name. I know my workspace organization that I want to go into this. And then one of the other parts that we're going to do is actually define where that project name comes in. So I also know where my project is and define that. So we're just using the default one in this case. And so that's a variable that we're inputting into this as well. We're defining some of those necessary attributes. So in our variable, we're actually creating our Azure provider auth. So this is the workload identity that we're actually defining to say we need to go and use OIDC federation. This is our client ID. So this is a client ID run to run against. So to make sure that we're getting the actual right client application to federate against. And then one of the things I've done is just to make this simple to automate and define our workspace, I've actually added the ARM subscription ID and the tenant ID automatically into this. You could create this as a variable set and apply the variable set to our workspace. But in this case, I've just done it this way for speed and ease to see all of these things. So if we do a Terraform apply here, this will now go out and build all of those resources, set up our federation, and build our construct. Once this is built, we will then go and add and have a look at the Terraform cloud to have a look at what it looks like there. We'll also have a quick look within our Azure subscription so that we can see the federation components that we've actually built. So just wait for a moment for this to build. It's pretty fast. Waiting. And done. And here you can see that claim that we've built. So we've built and defined our claim. This is our client ID run that we're actually building in, and this is our tenant and sub IDs. So when we go and look at our Azure portal, you can see here we have no resource groups defined. This is important for later. If we look at our Entra ID, if we go to our application registration, you can see that we've actually built our app. Within that app, we have defined our component parts. And if we go in and have a look at our federation, you can see that we've built out our federation in this component using our defined string and our endpoint of Terraform Cloud and the API as Azure AD token exchange. So now in our workspace, if we go into our Terraform Cloud, this is our Terraform Cloud environment, you can see that I'm in my organization. So I'm in my APJ organization, as we saw in that definition earlier. I'm in in the workspace that I was looking for, which we built dynamically, which is our dynamic creds, and that's in our default project. So we've defined all those parameters and built out our workspace. So this effectively is our workspace. You can see now that we have all of the variables defined. So our auth, our client ID, our tenant ID, our subscription ID, all ready to go. All we need to do is actually now attach this to a set of code. Now I'm going to connect this to my my GitHub and actually bring in the code from my GitHub. I know that I have a bulk creation of resource groups that we can use. Hence, that importance to show that resource group that we that there were no resource groups there before. And now, if we go and take a look at our workspace, you can see that we have a plan queued. So let's have a look at this, and you should see that this is now going away and asking for our to federate to Azure to get that plan approved. And hopefully this will now come back with our plan running and let us know that we are going to actually deploy on what we're going to build against that resource group GitHub code that I have associated with this run. And there we're going to create these 3 resources, unique pods for 1, 2, 3 across specific regions. So you can see we're going to have like separate locations with separate pod names. And so now this is applied a cost estimation to this. So it's not going to cost us any money. And we have apply appended. So I'm just going to apply this and say for its testing. Just so we have that, again, that audit trail of who and what is doing anything to what is being applied. And so now we have that audit trail and insight into what is happening as we build. Again, adding that value into why to use Terraform Cloud. And so now we can see our resources are being built and created. So this one's been created, and you can see that builds out really quickly. There's our 3 subscriptions in our 3. There's the subscriptions that have been built against, and our 3 pods in our 3 different locations. If we now look against our resource groups, you can see that we have built those resource groups. And so very easily you can see that we've not only established our workspace, we quickly and easily set our workspace to bring code in from our single source of truth, so our Git repository. We associated those 2, and then the code can run and only draws in credentials for that specific time that the run or the plan or the apply is being run through Terraform Cloud. Once that is finished, those credentials are then obviously ditched immediately and therefore not used. So let's go back to the presentation and finish with a few thoughts and closing statements. So now we've seen this in real life, let's just go over some of those key elements. So we can get audit, login, and traceability for who's doing what where within our HCP platform. We've eliminated our hard-coded secrets, thus reducing any potential leaks or human errors. We've automated our credentials to make it easy to rotate and also integrate into any workflows. This includes creating temporary credentials within our CI/CD pipelines and deployments. We can have the right and least privileges for users to actually deploy to, and we know that our credentials are immediately expired once they have been used. So solving a lot of the big challenges that are defined by having and risks by having those static secrets. So just to close out, please go and get yourself a HCP Terraform Cloud login. Try to run through the dynamic credentials developer guide. There's a great example of this with the link here provided. And remember, at all times, stay calm and drink tea. Thank you for listening, and I hope to see you again soon, where we go into another interesting topic in more depth.
Awesome, that's an awesome bonus talk that nobody will ever be able to see again if they didn't see it live today. Actually, I do think it will be on YouTube later. I don't want anyone to freak out. Yeah.
Until we post it to our official YouTube channel in the next coming weeks. Yeah.
Exactly. And put it on the internet where everything stays forever. It's for me, I come from like an AWS background, like building a lot on AWS, seeing the different constructs that other cloud providers use for how they package up resources. Like AWS is this very strong like accounts-based thing, and GCP is more on like projects, and a person can move between projects. And seeing the way Azure also bundles resources is it's always interesting to me. Of like, I'm curious to see what problems that solves and new problems that introduces by choosing that particular abstraction. So awesome. Our next speaker is Pablo Diaz, who will be talking about managing Ansible automation platform credentials at scale with Vault.
Hi, everyone. Welcome to my session today, where I'm going to be discussing how to manage Ansible automation platform credentials at scale. We're going to be looking at Vault SSH CA engine. We're going to do a demo with Terraform actions and how that integrates and automate this pattern end to end. So yeah, pretty excited about this session. I hope you enjoy. So first, let's talk about me. So I'm Pablo Diaz. I am a staff resident solutions architect within the professional services team. I have been in Hashi for about 2 years now. And yeah, I live in Spain, in Valencia. I've just put some links there to my blogs and to also my GitHub, where you can find the repos of the couple of demos I'm going to be showing today, and also some other repos that you can just clone and play around. But the idea is that after this session, you can just go there, look for the repo related to this talk, and try to replicate it in your own environment if you feel like it, right? So let's go through an agenda. First, we're going to be looking at SSH key management challenges, right? The traditional SSH key management challenges, and then how we map them out to moving those challenges or management into a platform like Ansible, right? How do you manage traditionally SSH at scale with that? Then we're going to explore the Vault SSH engine, what it does, how it helps to this use case, what sort of endpoints we have there, and what can provide them, what those endpoints can provide, actually. On the other side, we have the AIP credentials plugin. So that's how Ansible manage authentication to external systems. And before the demos, I like to show you a better together story where I show a pattern with AIP and Vault SSHCA, but also being triggered by Terraform. So you get an end-to-end automation with ephemeral keys. So that will be one of my demos. And there is another one that is using a specific credential type I'm going to be talking as well. So let's get started, right? So why this is important, right? Why this really matters to talk about today? Because when you look at the traditional SSH challenges, when it comes to authentication, usually it's all about a key pair, right? So you have a private key and a public key. And that key distribution and management, it's a tedious process, relies heavily on administrators. So they are always the responsible party to make sure those keys are distributed and landed on the right host. They might be responsible for maybe rotating them if something happens, but it's not a scalable way of operating, right? So you find in organizations two kind of patterns. One is one different key pair per host, meaning multiple hosts to manage, or you might also find the other side, which is like one shared private key for all the hosts, which actually is also another red flag, because it means that there will be probably a public key that is shared across the organization and will allow you to authenticate to the machines by just presenting that public key. And yeah, obviously this is a problem because the keys are usually static and they never expire, and they're not rotated unless something happens and someone has to go and rotate them manually over thousands of hosts, right? So when automation platforms like Ansible comes into play, what we also see is that in most of these implementations, the platform is actually already using one single private key to connect to these target VMs. What that means is that you have the ability in Ansible to store a private key in one of the credentials types. So you store the private key there, and the corresponding public key is basically configured on the Linux targets. So that's static forever, if you will like. But it also means that any developer that might have access to AIP can deploy to a VM by just presenting that shared public key. And that key generation and provisioning is usually also manual, right? So it's not an evolution from the traditional SSH, but it's more like, well, we still have to rely on maybe Ansible administrators to make sure those keys are provisioned and distributed. And that the blast radius is massive because, yeah, it might be that the same key is used across multiple environments. So there is no segregation of keys at all. Before we talk about SSH engine in particular, I would like to just do a sort of a refresher of how Vault works as a solution, right? As a product. So this is like Vault technical overview. Vault is just a control plane, and the way it works, it's always the same, right? So you have a client that could be a human or a machine that will provide some credentials to Vault and request access. So once Vault can validate the authentication through, I don't know, maybe plugins or trusted third-party resources, LDAP, GitHub, Vault will actually send a token back. And that token will actually be tied to policies that are associated with this client's identity. So that policy will specify what that person or client can actually do. For instance, could be retrieve a specific type of secrets from a specific path. And when it comes to the use case that we're going to be talking today, Vault can actually tell a platform like Ansible, yes, you are allowed to request signing keys from me, right? Because you are authorized to do that. So you actually configure that in a policy, and the token gives you the access to that. So the other good advantage of this when you implement it in platforms like Ansible is that everything will be logged, right? So there will be logs from who attempted to request this secret, at what time, from where. So everything will be just there for monitoring and compliance in the future. So Vault SSH CA engine. So when I say CA, I refer to certificate authority, which means that Vault will be acting as a certificate authority for issuing SSH certificates, right? So you have two options here. You can either use the issue API endpoint from Vault, which means that you ask Vault to issue a private key and a public key just for the duration of maybe a job execution, but you just call that endpoint, and Vault provides what you see here on the right. So you get a a signed key and a private key. But you can also say, well, I do have my keeper, I want to keep them, but I just want Vault to sign these keys. What that means is you have to call a different endpoint for signing, but what it means is that you will provide Vault with a private key and a public key, but Vault will return a signed public key, which means that you will have to use that signed public key that you have full control over in terms of policies and what is allowed to do and for how long with TTLs, with the private key to SSH to a machine. So and that's what one of the patterns I'm going to show you in one of my demos, right? So when it comes to AAP, what they use there for authenticating to external systems is credentials. So there are credentials plugins and there are credentials types. So before a playbook runs, the credentials must be retrieved and inject. So the playbook can actually execute. So, and most of these deployments rely on a credential type called machine, right? The machine actually use static SSH keys. And yeah, like I said before, these are most of the times long-lived and hard to rotate. So there will be a private key stored there with a public key. And Ansible will just call that machine credentials, use the same keys for SSH, and that's it. So there is a credential plugin type that is out of the box in Ansible called HashiCorp Vault SSH sign credentials type. What that allows you to do is tell Ansible, go to Vault and request that my public key is signed, and wait for Vault to return that key, and then use those two, inject it into the before the playbook execute, and then use that to configure and execute the playbook on the target VMs. So when you look at the pattern of this, what I just explained, let's assume that you have a user or machine on the top here. So this is in green. So there is a job that is triggered. And Ansible, for this particular overview here on the automation workflow, we're going to assume that you have existing keys that you want Vault to sign, right? So we're not going to ask Vault for ephemeral. We're going to be using AppRole for authentication. That's machine-to-machine authentication auth method in Vault, meaning that you need a secret ID and a role ID. And with that, we're going to call Vault, and Vault will return a token, and that token will tell Ansible, yes, you now have a token to request the signing of keys. So the flow works like this. You have the two keys, the private key stored in Ansible and the public key there as well. And then this plugin will allow to just automatically send that public key from signing. So when a job is triggered, the first thing that Ansible will do after getting the token is, okay, I'm going to send you this public key to Vault. Vault, can you actually sign it? So Vault will return a signed public key, which is key. You see the difference in color, right? So over this key, we already have applied all the policies that we want from Vault perspective. We can say this key is going to be only valid for, I don't know, 5 minutes, half an hour. We're going to have host sign-in or maybe segregation by username, so we can configure the valid principals and say it's going to be only the rel user for Red Hat or any other username that you want there to be allowed. And that particular username maybe can also be segregated in how many VMs that user can access, right, or SSH too. So the playbook will actually have the private key that we already have stored in Ansible automation platform, plus the sign key from Vault. And with these two, the playbook will effectively run on the target VMs. You need to configure the VMs with CA. It's a CA parameter that you need to configure on the SSHD config file. I'm going to show you that later in my blog, but this is why this line is referred here, because we need to tell SSH you're not going to be using any more username and password. You just need to start trusting a certificate authority for SSH, and in this case will be Vault. So what happens when you want to expand this solution and use something like Terraform Actions, right? So Terraform Actions allows you to trigger Ansible automation platform jobs, and it's been released in Terraform 1.14, so it's quite recent. And yeah, the cool thing about it is, well, you can trigger what we call day 2 operations from providers, and obviously this means that you're going to have a provider now for Ansible automation platform, and then we just invoke an Ansible workflow, and let's, for the sake of how the demo is going to go, just put this example, right? So we're going to provision a new VM, and that VM will be provisioned in GCP, for instance, in Google Cloud. It could be anywhere, but Terraform will know the IP after its provision. But once it has set the IP, it will just send it to Ansible and say, well, this is the machine I want you to run your playbook on for day 2. But of course, Ansible is also saying, well, but I need credentials to log into the target VMs. And for that, I've configured in my repo, and this is the cool thing that you can start doing is, well, Terraform is also going to configure Vault SSH CA agent with the proper policies, roles, and parameters needed for SSH engine to work. So when Ansible gets there, it knows that it needs to go to Vault SSH engine and get ephemeral keys. So in this pattern, I'm also providing ephemeral private key and public key to Ansible. So it's just gonna, those 2 keys will only last for the duration of the job execution, right? So this is an end-to-end pattern. I'm gonna also show you a demo of that. But the cool thing is that you can now trigger that from Terraform, get all the information that Ansible needs. Ansible will go here, fetch the machine credentials, inject that into the platform, and then run the job execution with those ephemeral keys. When the job is done, the keys are gone. And then you have the return prompt to Terraform that will give you the output. So that's how this will work now in my demo. So let's go to that. The first thing I want to show you is, if you're not familiar with the interface, I'm just going to log in again here. And this is the interface of Ansible automation platform. The first thing I would like to show you is the credentials I was talking about, right? So the first demo is just using the UI with the credentials type HashiCorp Vault Sign SSH. So in here, you need to provide a server URL, an app role, because we're going to be using auth method. So sorry, app role method for authentication. Then you have a secret ID that is encrypted. And if you're using the Vault Enterprise, you can also provide a namespace name here. I'm going to be using admin just for the POC, but if you have namespace segregation or more, you can actually also configure that to be specific to a specific SSH CA. So you can have segregation on both sides, multiple CAs and also different namespaces. This is the first thing. So here we're just configuring this credential type, but then we need the other one that is called the machine type. The difference to the traditional SSH configuration for IAP is now that instead of just having the SSH private key here and the public key here, and just present that, choose, this will be, without the other credential type, this will be like SSH -I, the private, the public, go to the host and log in, right? So what we're doing here is using the private key will be encrypted in the platform, but for the sign-in, we are going to be telling this credential, just go and call my other SSH sign credentials type. So it means that it will know how to go to Vault and request the sign-in of this public key. You see, I'm providing some details, like this is the path, and this is the only user that is allowed. This is optional. I'm just putting there for enforcing the fact that you can create multiple users or segregation by username as well. This will be the role, and this is the app role. So authentication method and the role that I created in SSH for this to work. So the first demo is showing you how, I'm just going to bring the console back here. So the first demo is I have a machine on the other side with this IP, doesn't have Vault in it. So what I will do with this template is install Vault in a target VM. So this is going to be a manual process. Then I'm going to show you the Terraform one. So I go here, install Vault AAP. You can find all these playbooks in my repo. I'm going to launch the template. So the first thing that you will do, you will see is that on the right, Ansible is going to start logging into the machine. So that's now, and it's logging with this username that I provided before. And it's going to start running the playbook. But at the very top of the execution of this template, of this job, what you can notice is that there is a SSH key data, and then there is a SSH data cert.path coming from Vault, which means that Ansible already went to Vault, got the certificate sign, or the public key sign in the form of certificate, and injected in here before the playbook can actually run. So with these two, it will actually SSH to it, right? So, and once that's done, we get some information that Vault has been installed, and this is the version of Vault. So if I just stop this, go back, Vault -version, now I have Vault installed here, right? So I can use it. So this is the first demo, cool stuff, but it's when you want to keep the private key stored in Ansible and using that credential plugin. The other option is not using the credentials plugin and just call the other endpoint from SSHCA to provide ephemeral keys. For showing you that, I will use a template that will install just an application on a target VM that is going to be provisioned by Terraform. So what's going to happen here is that I'm going to create this VM in GCP. It could be in any cloud provider, even local, doesn't matter for the demo purpose. So it's going to start provisioning this VM, right? At some point, there will be a trigger from Terraform to Ansible, and a new job will start. That job, it's basically is a playbook written for installing a software called Streamlit. It's just a UI that sits on usually used for LLMs. So it's just going to sit there and in a specific port, so we can test that it works, right? So while this is creating, I'm also going to show you that on the Vault side, you can see secrets engine here. This is how you see it from the inside, right? So you have SSH, as a secret engine, specific roles, and there is a configuration on the engine itself. This key is the one that you need to copy to the target VMs. Part of this configuration. It's explained in my blog. I'm going to put a link at the end of the slide deck. So here you can follow along and just configure the roles, the policies, and everything that you need to get this environment working, right? This is also a playbook there for installing Vault. So everything's in here, and also there is a section where it tells you what you need to configure on the SSH CA. So this will be the part that you need to configure on the target VMs. So as you see now, there was a AAP job launch configure VM. So this is just a trigger from Terraform to Ansible, and it's not waiting for the completion because there is a flag that you can configure either to false or true to wait for this to finish before coming back. But I wanted to show you for the demo that Terraform already provides me with an IP address here and a port, and just returns and doesn't wait for Ansible. Ansible is already doing the job, right? So it gets the same IP from Terraform dynamically, and then starts working on installing this application. So if I click in here, nothing happens, right? So there is no application yet running, and Ansible continues to install, and then at some point, I'm just going to get a UI. Yeah, perfect. So now works. So it means that Ansible just got a dynamic IP, so there is no inventories or anything that you need to configure previously. And it's also, if you look at the top, it's getting credentials for SSH. So it goes to Vault via AppRole and just gets the proper token to call Vault again and say, hey, can you actually provide me with the keys that I need, SSH to it, install the softwares, and finish. On this side, we have all the information from the Terraform output where it says, well, this was the IP and the specific machine types and configurations that we had. So we can do this multiple times for multiple VMs. This is a nice flow. And this action that you can call from Terraform will also have I have also a link in my slide deck. You can just go there and read about it, what you can do in terms of how to call this and the options that you have in there. But yeah, again, this is the way that you can call it from here, automate the full path, and get it completely automated. So going back to my slide deck for a minute, like I said, there are useful links here. This is how the AAP provider works. So there is information on that, how to use it, and yeah, examples. This is an amazing blog where there is more information and a deep dive into Terraform actions with AAP, but also including other stuff like Packer for baking those SSH configurations into an image. So yeah, I highly recommend you just read that one. Then there is information on Ansible automation platform credentials, so how they are configured, how many you have, options there, because you can use the ones that we discussed today, but also you can play around, like there's another one, Vault lookup secret, that you might be able to use as well for similar use cases, but not specifically to SSH, but it could be handy for AppRole, for instance, right? So how you also handle the secret ID there. And the last two, well, this is a blog that I wrote about SSH credentials at scale, focusing specifically on the configurations that you need to do on the SSH side, creating the role, the policies, and using the SSH sign credentials type. So in my first demo, it's basically covering blog, but in the blog you can find way more information about how to configure each of the parameters on all sites, including the VMs, Ansible, and Vault. And here is information on the Vault SSH-CA agent, the 2 endpoints that we discussed, and other options that you have to use it. How you can maybe create segregation of environments and segregation of CAs. So you can limit it also the blast radius there. Yeah, and that's it. Thank you so much for joining me today. I hope you enjoyed the session. Yeah, you can just ask me any questions, and I hope to see you again soon. Have a nice day.
Awesome. That was a great talk, Pablo. I always like seeing these talks that cover the integration between the various Ansible products and the HashiCorp products, as we're all coming together as one big happy family. I think better together is the official description for it. So I wanted to, Peter, I wanted to get back to you on the user groups that we were discussing before, I guess a couple of sessions back. When was the first time you attended a user group? Like, do you remember like the first user group like meetup that you attended, and did anything that stands out from that to you?
I do. The first one was actually before I was part of an advocacy team, and we ventured. There was a Toronto. It's called the Toronto User Group, down in Toronto. Obviously, they deal more with power, but basically, we just went to do surveys or some other reason. But it was the first one I went to before I joined the user group team, and it was great. Again, everybody walks up to you. It's a very open, engaging environment. Again, people that have been working with the product. That user group is one of the oldest in Canada, actually. And that one, again, you're talking to people that have worked with products for 20, 30 years, and then people that are brand new. So that was one of the best ones, or one of the first ones that I went to, and I was amazed out of the gate. Went to another one. It was in New York, and again, I sort of met someone that he had no idea what they were about. He was coming down from Syracuse, and just was like, I have to replace somebody. He's here with us for 6 more months, and then I'm replacing him. And this older gentleman had said, hey, go to this user group. They'll teach you, and he sat there for 2 days and took everything in, and was just like amazed that these user groups are out there. So yeah, it was a wonderful experience for myself, for all these events that I get to attend. That's the thing. Before, I had a job where I used to be an escalation manager. So I used to deal with, issues that would happen with the product. So to go from this stressful, intense, situation of an escalation, which great, there's some great wins, some great victories when dealing with escalations, to go from that environment to, everybody loves the product, they're using it, they're sharing how they use it, they're getting help. It was a wonderful, sort of refreshing take on getting to know these user groups and working with them. So yeah, it's been great.
Nice. And is there, when you talk about like user group leaders, I mean, they're the true unsung heroes of this. People who
Absolutely
volunteer their time to set up these events and coordinate it. I know on the HashiCorp side, we like take like a somewhat hands-off approach of like, let the user group leaders like decide what they want to do with the group, and then we will sponsor as needed. It's usually like food or small amounts of swag.
Yeah.
I'm curious to like, of the successful user groups that you've seen, like what do they have in common? Like what's a good trait for a successful user group? Like what have you seen?
I think it's just to get as many people to help as possible, right? There's always people that just need to jump in, and even you think you're doing something small and you're just, I'm just going to take care of registration. It's huge, right? So anytime you can volunteer or help a user group in any way, the most successful ones are the ones that have, a good collective of people. But at the same time, it's just determination. I've seen it run with a couple people. And I think what makes them most successful is you want to engage with other people. That's all that matters. And if it's 10 people, that's fine. As I say, if it's 100, that's wonderful as well. But both are valuable reasons to get together. And exactly, our group, we help with, we help with some light catering. We send swag, some things just to help the events along, just to go a little smoother, right? If you're going to come out and spend a few hours learning, it's always nice to have a refreshment or two and take a little item with you, when you return home. But that's how we try to help groups, and we try to put them in contact with speakers. But exactly, user groups, do whatever you want, whatever you think is most valuable to you and your members, and what education you want to focus on. And we're here to help in any way we can. Yeah.
Awesome. And I think that's it. My more questions I have for you until after this next session. Would you like to introduce our next speaker?
Yes, of course. Yeah, so up next we have Manu, who also another HashiCorp ambassador. So this session, one of my favorite titles, Steer Your Way Out of Terraform Hallucination. So thank you, Manu. Go ahead.
Good morning, good afternoon, or good evening for wherever you're joining us from. Welcome to HashiTalks. I'm assuming you're working with some form of a coding agent, whether it's through your IDE or a CLI, which helps you with your daily process, daily tasks, whether it's to create code, whether it's to write documentation, something of that nature. Now, how often have you found that results from these are inconsistent, even when you have given more than enough information? I've seen that in numerous occasions as I try to optimize my own conversations with the agent to get the best out of it, to make sure that I'm able to retrieve the information or the responses that I'm expecting to give me. I am Manish Chandrasekhar. I'm a senior delivery consultant with AWS. I'm here to talk to you about a few things that might be contributing to that lose of effectiveness from the AI side or the AI model side. Before we get into the details of these things, let's put some definitions to these things. Context. So if you've worked with an AI agent or a model, context is something which you've heard again and again. Think of context as any information that is provided to the model to make a decision or help complete a task. It could be your prompts. It could be all those required documents that you feel the model needs to go through, or any sort of APIs it needs to have access to, or any tools per se. Now, towards the end of 2024, Model Context Protocol was introduced. And if I may say so, 2025 was the year of agents and MCP. MCP blew up or exploded last year, and you could find every developer having at least access to 10 to 15 MCP servers running on their local machines. Whether you're reading AWS documentation or you are working with an API external or working with an integration system that you have, you might be having an MCP server out there. Whether you want to create Terraform configurations, you have a Terraform MCP server. All of these MCP servers hold some information in their definitions themselves, with which the model is able to accurately determine or use them when a specific task is assigned to that model. So when I'm asking for Terraform configurations, it's obviously picking up the Terraform MCP server. Keep that in mind, because all those tool definitions are going into the context that the model has access to. Is that a good thing? Maybe. Now, I've been guilty of this. I feel there isn't enough information, or there is more information that I can provide the agent to make it better. But it seems like that's not the case. A recent research done by the Chroma research team identified a core problem with the way context and agent responses are related. They introduced two concepts there. One is agent blot, or the context blot, and the context rot. What they did, or what they described in the article and the YouTube video alongside it, is this needle and a haystack problem, where they are trying to get the model or the agent to gather the right responses which are embedded in documents of relatively different sizes. So they see varying degrees of accuracies or inefficiencies or efficiencies from the model as the context size grows. Now, blot can be classified as any unnecessary, noisy, or unneeded data that is required for the task at hand, but you feel it is necessary for most of the tasks. Whereas rot is something which leads to the ineffectiveness of or brings down the efficiency of the AI agent to respond back in the manner that you would expect it to, leading it to move away from the desired result that you're expecting it to give. If you have not read this research paper, I highly recommend taking a look at it. It's a beautifully written, well-crafted, note on how they analyzed it and how they are at the conclusions. Let's take a look at an example of my interaction with Hero CLI, which is my daily driver, with some MCP servers loaded. I'm not using any custom agents here. I'm using the default Hero agent, which has access to some documentation by default because they are placed in a global structure. I have Terraform, Terraform, GitHub, and AWS Labs, AWS documentation MCP servers being loaded. And you can already see that the context usage is at 29%. And all of it is attributed to the documentation that most of it is actually attributed to the documentation that I've made available in this case. There are some estimated context usage from the tools, which are the 3 MCP servers that I have in this case, and maybe some other which are already built in from the application, from the agent standpoint. You can already see that the context is around 29% usage, out of which 19 to 20% is used by the context files that are made available. And I used to feel these are necessary for my agents to work with. In this case, mostly Terraform-based documentation, stacks, deployment blocks, actions, parallel execution, test execution references, and things of the nature. Now, I'm not going to use a simple example, a generic example of creating Terraform configurations. I think we're way past that point where models are really, really good at creating Terraform configurations because of the training data that they've had and the amount of information that has been slowly fed into it over the course of training time. And even some of the information that we have in your own documentation usually helps it to create those. So let's take another scenario. Let's take another scenario, which is very common in case of consultancies. Most of the organizations may have some existing resources, whether it's your resources in a cloud platform or any other platform that you're interacting with, and they want to bring that under Terraform management. How would you do that? Terraform has progressively given us tools in terms of the import statements and the config-driven imports, and even the recent Terraform search to help us do this. But let's see with how my model and how my agent reacts to or behaves with just the normal documentation that are provided with respect to query and with the Terraform MCP server. All I want to do is import 2 things. Import all the IAM roles that I have in my account and any S3 buckets in the US Eastern region. Great that it started off with the plan. Hero gives you that to-do list. It generates a plan, but right out of the bat, I see some red flags. Well, in the sense that it's probably because of the documentation out there, it's probably getting confused. It started with AWS CLI commands. Not a bad idea, but not what I'm looking for. It's trying to find the IAM roles and S3 buckets using the AWS CLI. And the context is already at 58% usage. We haven't done much yet. Some execution failures because some responses are not what the tool is expecting, or maybe the CLI commands are wrong. Again, it goes through the motion of trying to figure out what roles and what buckets remain in my account or exist in my account. These models seem to be very interested in writing scripts for everything. So once it identifies the S3 buckets I have in my region and the IAM roles, I believe it starts looking at writing the import statements. Yep, the S3 buckets are out there. It's slowly trying to find all those ones that are in the US vCEN region. Give it a few seconds. Great. Now it identified those resources. Now it goes to the next item in the task, which is to create a Terraform configuration. Now, I know for a fact, again, it has gone through the stage of using AWS CLI. It's definitely not using list resources, which I wanted to. So it's using Terraform Provider 5, which means it's not using the list resources anyway. Now, what the challenge here is it's trying to import resources in a way where it's not accurately reflecting the total number that I was expecting. I know I have like 100 IAM roles and around 41 buckets. And it seems like it has not identified them all. So even though it ran the Terraform import workflow, it only imported around 23 or 43 resources. And it gave me some information regarding how it arrived there and what has been done. Now, this is one thing which Kiro, we'll talk about later, but one of the mechanisms that Kiro tries to help you with summarizing the conversations if you have a longer task or a complex task. It's called the compaction mechanism or compression. Kiro is already identifying that this conversation is getting lengthy and it's reaching 87% of the context usage. Now you may ask, what is leading to this 87%? Your prompts, tool usage, the documentation, and all the results that were accumulated while the process is running. The agent was trying to capture the details around S3 buckets, the documentation that it wrote, and any results that it used from the interim runs to go to the next step. So all that amounted to 87% of the context usage, which is almost like reaching the end of the context window. You could compact and continue, providing additional directions to get where it needs to be. And I'm going to leave it there. So let's take a step back and look at how we can help provide more clarity, or better help models and the agents that we work with without exhausting their context windows or not exhausting so easily. The research papers that I earlier mentioned talk about the science of managing context, called as context engineering, similar to the prompt engineering aspects we have become familiar with. So how do we fix this? Obviously minimize tokens, but still provide relevant information to get those maximum signals out of the model that you're working with. So be precise, not really verbose. Structure matters because you want to make sure that it's actually reading through the right set of documents in the right order. You want to set some prerequisites and guardrails also. If you can dynamically curate and provide those documents on demand, there's no better way to do it. Helps you to provide the right relevant document for the task at hand, rather than giving it all the 14 documents like I did in this case. And keep in mind, context is precious because, think of it like GPUs or RAM. You have limited space or limited availability. Use it wisely. Now, one of the terms that I've heard or come across a lot in the past year, or even towards this year, is around progressive disclosure. What does it really mean? Progressive disclosure essentially means that don't tell your model or don't, let's say Claude, or in this case, I'm using Claude Sonnet. Don't tell Claude Sonnet all the information you could possibly say, but give it ways to identify the information that is required for the task at hand. How do we do it? They specify some mechanisms, and there are implementations of it later, which we'll talk about. The idea is you may want to have universal context that is relevant for a several bit of tasks. On demand, yes. You want to make sure that the resources or the documentation or the information that is available for the model is based on the task it needs. Only specific information. And let the system be able to decide what documents need to read. So start small and add on more information as relevant as needed based on the task at hand. Let's dive into a little bit deeper. So you want to make sure that you're filtering the context with respect to, let's say, whatever information you've given in such a manner that you're being selective. You're focusing the context on that immediate task. So you don't want to give information about every possible Terraform commands when you're only looking for Terraform query. Another one is something which you've already seen in the demo. It's called compressing or summarization of the information or interaction that you already had. Essentially trim down the conversation you had in case you are having a long or a complex task so that you're able to continue with the conversation, but at the same time provided enough information based on the conversation till now. It could be called as compaction, compression, anything which helps you to keep only what matters. The other piece of it is around using the tools that we already have, whether it's a Terraform binary or linters or formatters that you have access to, test suits, anything which can give feedback in a deterministic manner, rather than having the agent do some of these things and try to figure out those. So there are scripts, if there are things which can be run outside of like markdown documents, use it. These AI agents should focus on the logic and not essentially the mechanical tasks. Now, I'm working with Kiro at this point. So let's see how some of these expectations are managed, how they can be managed, how the context can be effectively handled within Kiro. One thing I did not mention yet is one of the implementations of progressive disclosure, or maybe mechanisms to help dynamically load the context on the basis of what type of task you have at hand. That implementation is tied to something called as skills. It was initially limited to Claude, but they made it an open standard. Now it's available as an agent skill. It's available as agent skills, which is used by most of the coding agents. Hero implements it as a skill resource, which can be installed in a machine, and it can be installed globally or made available specifically for a project. This helps to package that necessary information that can be a reference document, can be a list of things to be done, or a set of scripts which lets you run these in a deterministic manner rather than having the instructions written in pure word. And it's funny that we've moved away from not really liking documentation to write so many documentation now, right? What about your knowledge documents that you have in your hand, which are essentially style guides from your side, which may not really become part of that tools or a general skill? Use steering docs for it. And if you're running a complex task with Kiro enables, or you can enable auto compaction in your conversation, so that when it reaches the threshold, like 87, 80%, it helps or sort of prompts you to compact it or auto compacts it later, so that you're able to continue with the conversation with the summarized information, which is relevant enough for that model to give you what you need from that standpoint. So you'll be able to continue with the task with the summarized information that is relevant enough without having to load everything that you learned till now. And something we not discussed yet is sub-agents or multiple agents. Kiro allows you to spawn multiple agents within a single session. Why is this important? These agents run in their own isolated context, which means you're able to spawn multiple agents from within a task or from within an agent, hand off those individual tasks to them, get the necessary information from them, and work on it as an orchestrator. Why is it important? Because the context and the token context window is per agent, which means you still retain you're not exhausting your entire context window doing the entire bit of tasks, which could be given to multiple or delegated to different agents. Let's take a look at the same demo that we had, but with some minor tweaks. I'm going to use the same instructions for Kiro, but I'm going to launch another custom agent called IAC. The configuration that I'm using here will be available in my GitHub repository. I'll make it as part of the end of the slides. The custom agent in this case has access to skills. I've installed skills in my machine using the skills command. Now, skills ends up being, in Kiro, they end up being a folder called skills inside Kiro agents, and they are essentially markdown files. But you should see the amount of context being used by these skills. When I launch the agent, the context usage has dropped from 29% to around 6%. The context files are not taking too much time. The tools are at around 6% because you have got Terraform and MCP servers. It has already loaded the Terraform skill here, which I've written. And it looks through my Terraform version to identify that, yes, it has support for list resources, or it has support for query. Then it looks at the AWS provider 6.x version, which identifies that it has list resource support for AWS IAM and AWS S3 bucket. Which means it's gone through the process of identifying or using that skill as the necessary document of relevance for it. Once that's done, it goes through identifying all those documentation and runs through the Terraform import command to generate the resources. Yes, there are 141 resources as I mentioned earlier, 100 IAM roles and 41 buckets. The change is because of a property within AWS provider, which doesn't seem to cause any harm. But I do want to take a look at that provider change to see what is that information, what is that particular property. But at the end of the day, it completes the process. It completes importing all those 141 resources that I wanted it to do. Taking a look at the context, we are at 48%, which is around 40% less than the original one. Now, the context files are on around 0.6%, I believe. You have additional ones coming from the prompt. Keep an eye out for that, because it's not just your prompts that's adding to the context, right? Your prompt is very simple, like 3 or 4 lines in there. The interactions that you had with the agent, the results that it got when running those commands, all of them combined to become the effective prompts for it to steer the agent or the model to do the next step. Whether it's to list the IAM roles, list the AWS S3 buckets, or gather necessary information to get the identity data for it to configure. So we went through the skill, created the information, created the necessary configuration, imported them, and made it available for us. But at 40% less usage of the context. Can we make this better? Yeah. Let's take a look at sub-agents. So I have added another agent called Terraform Query and given access to that particular agent or sub-agent to be invoked by IAC. Again, the configuration is part of the GitHub repository that I'll share later. When you look at the initial context load, it is still showing that 6% because it only has access to the same skill resources. But in the prompt, you're slightly tweaking it to say, go call those sub-agents where needed and pass in the information to the main agent, in this case, IAC, for task compilation and confirming the final thing. So you can see there are 2 Terraform query agents. They're essentially 2 instances of the same agent running in parallel. They're effectively doing the same set of steps, but for 2 resource types, one for IAM roles, one for S3 buckets. It's creating its own folder structure so that it doesn't, the Terraform commands don't really have an issue. That's the reason I had to tweak that command a little bit, my prompt a little bit. And you can see they already completed the tasks. And then they're passing the information back to the main agent. They've used the same skill. They necessarily provided the import configuration based on this information that they retrieved and passed it back to the main agent. Yes, the generator config might have some read-only values which may need to clean out. Similar outcome, we have 141 resources imported and 41 to change. That changes again because of the AWS provider property mismatch. Now, how did it do with respect to the original, the second demo that we had? Again, it successfully completed it, but we handed off some of those work to an underlying agent rather than having to do it yourself. Again, in this case, it's redoing it just to verify that it's imported it. The first one is a plan. I believe it's doing an apply now. As the message says, we have gone from 48% to 37% of context. And what constitutes this context? The same resources, like the context files, the tools, the prompts, information. That prompts has gone down a little bit, but is still adding to it. You can see that the information that the main agent also used, along with any additional steps that it did, along with the RMSs that I saw, which it took us feedback, running the Terraform apply commands, all contributed to that additional set of context usage. Now, see, you've seen 3 different demos. One with the general agent, which had all the documents that I could probably give. Then second one with a skill, which was effectively curated for it to be performing the search and import. The third one with the same skill, but with multiple agents, which can be delegated the role of identifying the list of roles and querying and generating the resources for us. So what do we look at today? We looked at context overall and how providing more information than needed can hurt the results. Agent skills is something which I'm very excited about. And I'm trying to see where I can use it from the standpoint of how I interact with my agents to make sure that I'm using that concept of progressive disclosure as much as I can, trying to reduce the impact of that context bloat and rot. Sure, if it gets to a stage that you have, you're reaching the end of the context window due to whatever reason, enable compaction. If there is a coding agent, if your coding agent supports it, absolutely use it. Helps to summarize it, helps you continue that conversation in case of complex tasks. And please, please, please hand over those, enable the agents to run those tools in an autonomous fashion so you can give those responses and feedbacks that is necessary to provide you the right and accurate results rather than having it to run in deterministic way. So we made it to the end. I'm going to leave you with a few QR codes, some to download the Kiro IDE in CLI if you have never used it before. The second QR will lead you to a GitHub repository with the agent configuration and the CLI settings that I've used in this demo. If you're interested in creating or contributing to the Terraform skills out there, my blog will give you an example of how to do it, along with mechanisms or options to validate and review the effectiveness scores, which Tessel gives you. And as I said before, there are multiple ways to get your model to respond better with less context rot or context blot and inefficiencies or inconsistencies that you may see right now. Take a look at the models that you're interacting with and understand what is already baked in and was already understood without you having to provide additional information. That'll go a long way in reducing that context usage that you talked about. With that, thank you for joining us today. Hope you found the session useful.
Perfect. Thank you, Manu, for that session. That was great. Another of our HashiCorp ambassadors. That was a great session. Just we're almost Richard and I are almost at the end of our emceeing block of duties here, so we have, I think, one more session coming up after this. But just remember, you know, if you're just joining us now, or you've had to come and go throughout the course of the day, that everything here is going to be sent to, you know, put to our official YouTube channel in the coming weeks. So you know, it's great to stay here if you can, but if you have to step away, no worries. We have you covered, and we'll be able to share everything. So I'll hand it over to you, Richard, to, again, after Richard and I are done, it just keeps going, right? The event goes till tomorrow morning. So here in the world of, you know, television, to be, you know, the prime time is yet to come. It's still, you know, we're not even into the evening yet. So yeah, we've got a lot, but one more session to come here in our emceeing duties anyways.
I was thinking, I was picturing like the Energizer Bunny, that it keeps going and going, but then I remembered like a non-trivial fraction of our audience probably never saw those commercials.
Might not have, yeah, that's
because
correct.
they're too young, not because they're too old. And then I was like, oh, and also it's like a very America-centric commercial. Like, I'm not sure they had. Actually, put it in the chat if you're from the UK. Do you have like the Energizer Bunny commercials, or do they have something weirdly British, like the guards at Buckingham Palace kind of thing, but with like a battery? I thought I remember seeing something like that at one point, but I could probably Google this. But I figure asking the chat's much more effective. And if I were to ask an LLM, it would also hallucinate just as much as my own flawed memory. But with all that being said, yeah, let's introduce Benjamin Likens, who's a returning speaker to HashiTalks. So I think this is we'll call it his sophomore album, if you will, on simplifying scaling and securing observability for non-enterprise teams.
All right, so thank you everybody for taking the time out of your day to watch this talk. I'm Ben Likens, and today we're going to be talking about simplifying scaling, securing observability for non-enterprise teams. I'll get a little bit into what that means. But my background, I came from SRE DevOps roles and really kind of fell in love with observability, and more in the sense that I would work observability rotations, and I never liked getting those calls in the middle of the night because something was missed during the day. So we're going to talk about how we can solve a lot of those issues. So here's me. I'm a senior resident solutions engineer. Pablo, who spoke earlier, I work on the same team as him. I don't really have too much of a social presence, but I do like to blog, and I've been blogging mainly about HashiCorp Nomad. And if you do want to connect with me, LinkedIn is probably the best place to do that. And then for this talk, I'm going to talk about pain points in observability, just from my experiences, both in the SRE DevOps roles and then also when I'm helping consult customers. Next, we'll talk about codifying observability in images. After that, we'll take those images and talk about codifying your observability platforms. And then once we have your platforms up and running, we'll talk about how we can codify observability when we're provisioning resources. And then lastly, we're going to talk about how we can orchestrate observability. Yeah, so this first discussion is ClickOps, and many of you are probably familiar if you've last 10 or 15 years, probably familiar to manually creating your monitoring, your alerts, your dashboards, and people become a little bit too over-reliant on that. And it really makes observability an afterthought. So you would deploy your infrastructure, you get the services deployed, and sometimes observability is missed. You can also get configuration drift where from your staging, dev, testing environments, they don't make it up to production. So you'll get drift between those environments, and then you'll also get drift if you're regionally deploying applications between those different regions. And then lastly, it's a lot of manual toil. So whether you're doing it by hand or if you are using a configuration tool out there, installing agents that way is pretty much unscalable. And if you ever have to update agents, you have to hit, could be potentially tens, hundreds, or thousands of hosts. The next thing is blind spots, and I kind of mentioned this already, is you might know what your application looks like when it's healthy. You might know what an outage looks like, but there's a lot of confusion on what does a degraded service looks like. And there's not as much discussion between the development teams, the engineering teams, the support teams that are out there to discuss when a service becomes degraded, what to look out for. So we'll talk about solutions on how to handle that. And then lastly, we'll talk about silos, and especially when you get to the enterprise level, a lot of teams you'll have dedicated SREs. You'll have developers that just focus on development of the applications. You'll have security teams, you'll have support teams, and they're all in their individual silos. And I really see that as kind of being anti-Hashi in the way, where I look at HashiCorp tooling as being very collaborative out there. So if you are building out a Terraform module that deploys a service, or maybe could be commonly used to deploy a type of service, work with the developers to understand, hey, what are the key performance indicators of that application? So when the engineers have to deploy that application, they know what infrastructure and what observability to deploy out, and then also work with the security team to have a centralized secret management solution. So instead of teams hard coding secrets or having to store them in multiple locations, look at a centralized solution that can be picked up on it. And then lastly, you want to give support the visibility. If it's a internally or externally facing application, you want to make sure that they have that visibility, whether it's dashboards. So if a customer issue comes up, and they'll be able to quickly resolve it, or to kind of give them a little bit of notice before saying, hey, we're seeing the service is now degraded. Let's see how, let's see if we can get this escalated before it becomes a full-blown outage. So lastly, with this goals, we want to simplify this by eliminating toil, any kind of configuration fatigue, and just making this, and I'll refer to them either as blueprints or templates, but really just kind of these creating Terraform modules that will simplify providing that visibility out of the box. Next, we'll talk about scaling. I did mention this is going to be focused on non-enterprise, but if you do start to grow out, or if your applications grow out, or as your company grows, you want to have the right processes in place from the beginning so you're able to scale out. So we're going to do that as images as code, infrastructure as code, and then also looking at how we can use orchestration to help with that. And then lastly, we are going to look at removing any risk associated with having to hand off passwords, whether it's between different systems, or looking to prevent users from needing to hard code passwords and secrets within their service. So for this HashiCorp tooling, what I am going to be showcasing is HashiCorp Packer, which I'll use for my image building. Vault, for every single solution, I will, except for Nomad, touch Vault. Nomad, I have a different use case that I'm going to show. But Vault is going to be for any static secrets or for any dynamic secrets. In the real world, I would use the AWS secrets engine to dynamically pull tokens. I didn't get that set up, and I'm using internal systems as well to get that set up. But there is also a AWS secrets engine that I would use in that use case. And then HashiCorp Terraform, that is going to be the main configuration tool. So it will deploy the infrastructure, and it will also deploy the necessary monitors dashboards on my observability platform. Next platform, you don't really need to have any kind of hosted solution. You can do this within your own lab environments, or within, if you have tools like QEMU or your own bare metal instances, you can use those to build your own platform, so you don't necessarily need to spend. In my use case, I am going to use AWS and some bare metal to showcase how those can be used. And lastly, for my observability platform, I thought about deploying Grafana, the Grafana stack in my own environment. But the simplest way to at least onboard observability will be through Grafana Cloud. So for this, I just pulled up the free tier. I'm only a single user. They offer a pretty good free tier to start going in and consuming the platform. So to start off, we're going to talk about observability in your images. And the goal of this section is going to be observability by default. So whenever you build out an image and then you provision it into any environment, it will come up with the necessary agents or any configuration necessary to be observable by default. Once we have that secure base image built out, any images that get built off of that base image, we can slightly tweak based on our needs. And then throughout this process, since it is defined in code, we'll make sure that these are peer-reviewed changes. So store them in GitHub, GitLab, or whatever solution you have a good process in place where someone can put in a PR. You can have automated solutions to review it. You can have checks, you can have tests, but make sure someone is going in, manually reviewing the changes and approving those. With this, my recommendation is, and this is probably becoming a familiar topic, is an image factory. But even to this day, I still see small and large customers who aren't building their images via Packer or another similar solution. What they're doing is they're essentially building a default image or building off of a default image, provisioning it into their environment, and then it takes 60 minutes or longer in some use cases to go through a full installation. That might be more extreme than what you're used to, but my recommendation and from past experience and work is you build out that generalized image. So in my use case, I'm showing have a Debian image, you install Grafana on it, and that will be your generalized image. You'll also harden it based on your security needs. And once that's done, it has observability baked in. The next step is you start to take that generalized image and you make it more specialized. I love Nomad, so I'll talk about the next image I'll build out is Nomad. So in this use case, when I install Nomad on it, it could be used for a server or a client. And then once I get Nomad installed on it, I can also tweak the existing configuration that Grafana has on it to observe the Grafana or the Grafana agent once it, or sorry, the Nomad agent once it starts up. And then after that, it would be building onto your client. So Nomad can run essentially Docker. It can run containerized, non-containerized workloads. We also have a Java driver out there. But depending on the applications and your use cases, you can further refine it. So if it was Docker, you can further refine that Grafana Alloy configuration to pick up those containerized workloads. And then lastly, we'll talk about securing observability with Vault and Packer. So this is something, surprisingly, even on my own team, people weren't really aware of. There is a function within Packer that's called Vault. And as long as you pass over the Vault address and the Vault token or some kind of credentials to get access to it, it can pull secrets. So in this use case, I'm using it to grab an API key for Grafana. And that would allow the agent to connect back to Grafana Cloud or to your self-hosted platform. Something to look out for, and it's a simple way to, instead of needing to pass around the secret between Vault and GitHub Actions or another solution, you can store all those secrets in Vault and deploy them out. So once we have our images ready to go, we can start looking at codifying our observability platform and starting to consume it. I love self-managing solutions, but if you want a hosted solution, that's probably the quickest way. But I've also worked in environments where they didn't have authorization to do a hosted solution. You can talk about government, you can talk about EU, where they want to protect the data, and there just isn't a solution that you can use that is hosted in the cloud. So you might want to self-manage it. So if you are self-managing your solution, what I recommend is to build it out via Terraform, codify the infrastructure, and then so when you deploy it out, any changes can get reviewed, approved, and you can also set it up for disaster recovery. So whenever, say there's an outage or anything like that, or you need to do a migration, you can leverage that existing configuration and deploy it into either a new region or to redeploy it on the same platform. Once you have the platform up and running, you can start looking to consume it for dashboards, alerting, notifications. If you're using public cloud, you can connect it back to AWS, Azure, and Google, so you can start consuming metrics that those services provide. Another neat feature to keep your eye out for is if the platform offers, I'll say like it's a config or ClickOps driven approach that will allow you to export Terraform. So I know Datadog has this, I think New Relic has it, Grafana has it as well. If you go in, you do the ClickOps, it will sometimes give you that option to export whatever changes you made on that page to code. So the example that I have here is when you set up your AWS account, you have to create a scrape job that will essentially tell Grafana, hey, these are the services I want you to scrape. It could be tags. You can set up the interval for how frequently it scrapes. What you can do here is you can copy that configuration and then make it more dynamic with variables, locals, and other options. Stick that into a module and then use that as a repeatable solution for whoever consumes that module. Then lastly, we're going to talk about securing and centralizing secrets. So key theme for this, most of my solutions are going to be Vault-based, so having a Vault server up and running. If it's static secrets, which in my case, Grafana Cloud required static secrets, it was authorization tokens, API tokens. You store that into Vault. AWS, as I mentioned earlier, we have an engine that will communicate with AWS, pull a short-lived token that can be dynamically used, and that token will expire once it's done. And then lastly, we'll have ephemeral blocks, which were released in one of the more recent versions of Terraform. But this is a good way to, instead of hard coding secrets, whether through variables and then having them stuck in state, ephemeral blocks will be read. And then once the actual process of the Terraform apply or plan was done, it will essentially remove that from memory. So with that, I am going to do a quick demo of what I built out. So I have an AWS account set up. I have my Grafana Cloud set up already. I have a module that I am using essentially. So anybody can go out if a new AWS account gets created. They can add a new TFVARS file to this repository and then add a new account to it. The other thing is I have the Vault provider in here. I'll show essentially what I'm using with the Vault provider is the ephemeral resources. So instead of having these set up as variables or environment variables within my pipeline, I just set up the ephemeral values and I can reach out to Vault to pull them. So here I'm pulling my Grafana auth and API token. So I already have a var file set up. I am going to get this kicked off and running. And then in here, you can see it pulls up or essentially reads the Vault secrets with the ephemeral block. And right now it's doing the reading and it's doing the planning. Once it's done planning, you can see it closes that connection to Vault, so the secrets aren't stored into memory anymore. I can go through and check this. The Grafana team nicely has a lot of this Terraform code out there in their documentation, so it was pretty much a copy and paste for me and to take something that was static and put into a module. But you can see here, read the secrets. It's now creating the integration in Grafana. It created the AWS role. And it's also creating the scrape job where it will scrape essentially just EC2 metrics. If I go into here, I didn't have any accounts existing previously in my Grafana Cloud. Once I refresh, we should hopefully see that account pop up. So you can see that account is up there. I have it targeting US East 2. This can be to one or many regions. The other nice thing that I noticed with Grafana Cloud, and I'm honestly I haven't been the biggest consumer of the platform. By creating this via Terraform, it also gives notification that this job is created via Terraform. Usually my recommendation is to lock down your platforms, whether it's AWS accounts, this observability platform, lock it down to where only Terraform or Ansible can run those, and then have a process within CI/CD that prevents people from manually coming in and having to making those changes where it causes drift. So here you can see this created by Terraform. And then AWS, I believe I have it filtered properly. It now created the role here. So on this AWS account, I essentially gave access for Grafana Cloud's AWS account to come in here and pull my metrics. So now that we have my AWS account set up and I have my Grafana Cloud platform up, we'll talk about codifying observability when you provision. And really the goal here, and I usually use the same phrase, is killing two birds with one stone. So what I'm trying to do here is I'm going to leverage modules as templates. And then when I'm deploying common infrastructure, it could be EC2 instances with a load balancer in front of it, and then some kind of storage. It could be ECS. But as long as you are deploying that infrastructure, I'm also going to deploy resources on Grafana Cloud that could be dashboards, it could be alerts, it could be notifications. So say if Team Alpha wanted to deploy a new environment in production, they can go out, use this module. It could be Team Alpha front end for a certain application. It will create those resources. It will tag them in AWS. And then in Grafana Cloud, Team Alpha will also have dashboards and alerts that are associated to those resources. And then also during this discussion, and it kind of works out because the last talk was about AI and MCP, so I don't have to go as into as much discussion about this, but I am going to leverage those tools, even though it might sound like, paying for those kind of tools would be an enterprise level cost. You're kind of seeing it now where individual developers and others are consuming AI as a way to essentially vibe code and to do the development. I did want to mention the Terraform MCP server. So this is purpose-built for Terraform workflows. So you can connect it to HTTP Terraform, you can connect it to TFE. In this use case, I'm just using it with the community edition. But what it will do is it will reach out to the Terraform registry. It will see what existing providers are out there. It will check out what resources, and it will actually read the latest documentation. So you won't have the issue of where it's day 0, day 1 of a new resource being added into the cloud that Terraform, the older LLMs don't have access to. What the Terraform MCP server would have is the ability to access the registry and read that latest documentation. And then, as I mentioned, it can automate Terraform tasks, so it can do the initialize, it can do the validate, and then also plan and apply free as well. Just an example prompt. So if you were setting up something and say Azure wasn't an environment that you're familiar with, you needed to create Azure storage buckets with Terraform. If you weren't familiar to how to do that, you can ask. As long as the MCP server is up and running, it will now reach out to the registry. And you can see here, at least in VS Code, it will identify when the MCP server was used. So it grabs the latest provider version. It checks provider documentation, and then it also checks essentially like the resources that are out there. So it will check anything related to storage buckets for Azure to make sure that it does not hallucinate. And I'm not going to go too much into this. My recommendation, so Gautam gave a talk during HashiConf. He works heavily on the MCP server. He has a lot of documentation out there. And I would recommend go check out that talk. He goes a little bit more in detail of what MCP servers are and then how you can use this in your workflows. For my demo, I have a setup. Instead of VS Code, which I've used for probably since I started, Google, if you're not familiar with, has a new tool called Anti-Gravity, and they are calling it more of a agent-based editor versus just a traditional IDE. So you can go in, you can edit configuration. What they have in there is what's called an agent manager. So if you have multiple tasks that you want it to run, you go to the agent manager and you can give it to those commands. And then lastly, it has a browser-based feature where if you were developing a front-end application, you can tell it to open up the browser and to do testing. So essentially, it will write the code for the front end, and it will go in and test, navigate through the page to make sure everything's working. Model Gemini 3 Flash, and then I am using the Terraform MCP server. Same thing here. So once again, hearing everything through Vault, and then I am going to try to keep all my secrets in ephemeral blocks and have them deployed so nothing is hard-coded. So I will go ahead and pull up Anti-Gravity. The nice feature with Anti-Gravity, if you've never used it before, they have something called the MCP server store. This is something that we've discussed with Google about getting the Terraform MCP server added in there. But if you've already added the Terraform MCP server into into VS Code, it's a pretty similar setup. You just have this JSON configuration. If you had Terraform Cloud, ACP Terraform or Terraform Enterprise, you could put token in there so it could reach out to that to access your private registry. But for this, I am just going to use the Community Edition. And with that, I am going to open up the Agent Manager. So what I will do is I have this workspace already open for a demo application, and I will tell it using the Terraform MCP server, deploy an application, deploy infrastructure in AWS using EC2, and I'll say network load balancers. I'll say add vault provider to pull in secrets with variables. So while that's running, I am going to go back to the main page for the agent manager. So that's going to be my AWS infrastructure, and I'll say using Terraform MCP, and you don't have to specify the Terraform MCP. It's just something I've always done. Create a dashboard which will monitor the EC2 instances and load. I'll say network load balancers deployed in AWS for this application. So I have, as you can see on the side here, an agent that's running for the AWS infrastructure. I have it running for Grafana as well. And I said create a dashboard, and I also want to update it and say use the Grafana provider. I missed that. And then the last thing I will add to it is create a front end, also say create a website for HashiTalks 2027. That year it will be, I'll say it's Western themed. Use the browser to test the website. Okay. So by default, the agents in anti-gravity essentially do what will be, it will plan first. So before doing any actions, it will do its research. So it will use the Terraform MCP server. It will know or use what it already knows, and it will create what it calls a implementation plan. So it already opens up here, and it will give you details to review. So it says I need to have an active AWS account for this. I have to have a Vault instance, and then it also talks about having a secret with keys that could be used for a SSH key. And here it talks about the changes that it's going to make. So it says it in the main TF, it will create the provider configuration resources, variables, outputs, and then providers. Everything, once you review it, it looks good. And here it will do the automated testing. If there was anything else that you want to update it with, you can comment and you can say, by default, create 3 instances. So I put that review in there, and I will go ahead and proceed. And now that one is up and running. And this one, it looks like, and I will actually say HashiTalks Terraform. I'll say I'll allow this. So it's going to go through and it's going to analyze what is already existing in this structure. I will let that go ahead and run. And then the last thing here was the front end that I asked it to create. So we will see, here's the website, Western themed. I will go ahead and tell it to proceed. And then as it's running, it will have commands that it prompts in the background. So this is running a Terraform init. You can see here that it's using the MCP server to get information about Grafana. And then lastly here, it is creating my website And it looks like it is going to try to get it to run. And it's still running. But probably for time, I might just go ahead and jump off of this. Just wanted to kind of give an example. New tool that I've been using. I wanted to kind of showcase what the Terraform MCP server is doing. AI is here. I think it's here to stay. As much as you want to be a professional at whatever language or what you're doing, it's just something I think that we're all going to have to interact with. So similar to me learning Terraform back in the day, it wasn't a niche. It's become something that is now the industry standard. I feel like this is something that is a good recommendation of what to learn. And there's other tools out there that you can also play with. Okay, so I'll let that go ahead and run. Last portion I want to talk about is orchestrating observability. And this section, I am going to talk about HashiCorp Nomad. And for me, it's a simple solution. You don't have to be kind of a new platform expert. If you understand Linux, if you understand Windows, you can easily install and set up Nomad on it to orchestrate your workloads across those compute instances. So with orchestrating observability, what I am doing is, oh, now it's popping up the website. So I'll use Nomad to essentially replace and mimic systemd. So in my home lab, I have bare metal. I use multipass if I want to virtualize instances. Instead of having to individually jump onto those and maintain them or configure them with a tool like Ansible or PowerShell or some kind of scripting, I can just use Nomad as that single pane of glass. System job deployments. This is something new to Nomad 1.11, and on my blog, I wrote up a post about this. So similar to like service deployments with blue-green, canary that you would see in Kubernetes and other platforms, and even on Nomad. Nomad now for system-based jobs, which are kind of a special job, which will run a single instance on every host that it can. You can now deploy them in a much slower manner. So if you were going to update, say, some kind of system-based job that runs in a container, if it's going to destroy that container, instead of destroying it and creating it on every single new host, what it will do is it will spin it up on a single host where you can go in and manually or have automated checks and have it run that container. And you can see here, this is the manual option. I can go ahead and promote it. My secrets block, this is something also new. There were other ways within templates to pull secrets, and what the secrets block does is it's very good for just in time. So it will be read once when the job and task is getting created. So in this example I have here, it will read the AWS access key, ID, and region from that configuration just a single time. Since this is, I think I set it up as a batch job, it will just be read that one time. That batch job will run, and once it's complete, the next time it will run, it will pick up the new secret. So this is a simple way to store your secrets. Just a quick note, it has built-in support for Nomad. It has support for Vault. You can also do custom plugins and everything. It looks like I'm creating balloons right now. You can create custom plugins with the secret block. So if you're going to AWS or have another provider out there, you can do that. So this last one I will do very quickly because I know I am probably already over on time. I have a multipass instance set up, and what I am going to do is I have it already set up with Nomad. I already have the configuration set up. I have telemetry set up. And if I go into my single Nomad server, I already have a Alloy job that is up and running on 2 instances. They are connected back to the cloud. What I will do is systemctl start Nomad. So this instance is called HashiTalks 2. And once it starts up, if there are no errors, yep, looks good. Okay, it's up and running, and I can already see the instance is up. And then if I look into jobs here, you can say it's degraded. Oh, and I knew this would happen on a live demo. Let's see. So there's two things. My other instances, I had Grafana Alloy set up already. There is another configuration block that you can set up in your Nomad job, which is called artifacts, where you can download the artifact, which in this case would be the binary. I did not set it up, so my fault on a bad demo, but essentially what it was trying to do here is it was trying to run the Alloy binary and connect it back to the cloud. Just a couple of items I will touch base on with my job configuration if you're not familiar with Nomad. This is running as a role exec, so it is running essentially what would be bare metal. I have the command that's running, so Alloy was getting set up in user bin Alloy, and then these are the command arguments that I have set up. I'll post this to my GitHub afterwards, but here I have the secret. I have an environment token or environment variable that's getting passed in when the task executes to pass in the agent token. And then and here I have a template that will create the config on fly. So if I ever update this template, it will relaunch the Alloy task that is running with the latest configuration. But yeah, so thank you all. Hopefully, this showcased how to simplify, how to scale, and how to secure observability within your environments, leveraging Packer, Terraform, and Nomad, and same with Vault. And thank you to everybody in the community. This is my second time doing HashiTalks. I've done HashiConf twice. I love meeting people in the community. If you want to reach out to me on LinkedIn, feel free. I have my blog. I'll make sure to upload my slide deck into the storage that we have them being uploaded. And yeah, feel free to reach out. And thanks to my RTS team and my family. But yeah, I'll jump off. Thank you.
Awesome. Thanks, Ben. And just as another reminder, we still have HashiCorp developer.hashicorp.com that you can use for any kind of learning. Eventually, you'll have as much expertise as Benjamin does. I know I used it when I was learning Terraform specifically. It's got tutorials, interactive labs, architectural guidance, product documentation, and prep for the certifications. I think the first MC block this morning gave away a certification exam. So if you want to prep for that exam, that's the place that you can do it. And we're about to take a 5-10 minute break before the next group of MCs joins. That's me, Michael Cusser, another developer advocate on my team, a peer of mine, and Ned Balvance, one of our HashiCorp ambassadors, will pick up where we left off. Thank you, everybody.
Thank you. Thanks, everybody.